Hello, good morning.
How are you?
I'm good. How are you?
Yes, I'm good.
Good morning. Can you provide your microphone for YouTube translation?
Yeah.
Oh, great. Oh, thanks. So today there will be a new link to Zoom, or it will be the link of yesterday.
I think you have the post of Zoom will be better.
Okay. I mean the link is the same as yesterday.
Yes. Controlling using one PC would be easier to manage.
Yes, it's much easier. Yesterday we tried and it was a success, so
Yeah. That was better.
Yes, it's better. The meeting scheduled for 5th of October, start 7:30 a.m. Maybe we should...
6th October, different link, different from yesterday's link.
Yes, we have to get a new link.
Yeah, this way. Okay. I sent mail you Thursday. Fine.
Доброго ранку. Как это? Я кандидат. Первый глаза. Вчера переживал за аспирантку свою, это первый раз закладывается в таком
жизни?
Ну, в таком обществе,
Да, в таком обществе. Так.
Второй год аспирантуры. Ковид все время был.
Да, да.
Никуда не
Ковид — это страшное дело. Ну, мы сейчас сделаем вот так вот. И YouTube трансляция, и Zoom трансляция, и все в одном компьютере.
Это не просто.
Вот видите, Zoom, YouTube. Вот нас уже смотрит один человек нас, видите? Это, наверное, я. Так.
Вот этот вот 1.17. Ну, можно оба, да.
Обновим, да? Копировать.
Сегодня они.
Presentation. Окей.
Спасибо.
Не за что. Так. Тут у нас красный тулс. Аудио. Микрофон. Элкаст.
Now I send this today's Zoom link.
You sent to everybody?
No, only you.
For me?
Yeah. Mark sensei sent to everyone, I think.
Okay.
Yesterday, did you send Zoom link to everyone?
To whom?
Yesterday, did you send?
No, it was Mark. Mark was sent.
So Mark will.
But can you send the link for Zoom to Mark and Fumi? Because Fumi also distributes among the Japanese participants
Yeah.
the Zoom link. And I will also get the link.
Okay.
you send me to my Gmail?
Gmail address.
Amen. Kanasas, yes, okay. Zoom link. Okay. So you're the host, yes?
Now, now I'm after you created host. Now you are host.
Thank you. Now. Did you send this link to Mark and to Fumi?
Yes.
Yes. Oh, yes.
I sent yesterday.
You sent yesterday. Again, something wrong with this microphone.
Why is red?
Please push.
Could you help me please say something and I could hear you when you could translate near the mic.
Hey, hello, how are you? Can you hear me?
Oh,
Okay.
yes, please. Okay. Yes, thanks. It works. Dzień dobry.
Mam panu też podpisać delegację jako organizatora.
Tak, oczywiście. No, jednak nie mam pieczątki.
Może być bezpieczonki,
Może być.
jakaś data i...
Aha, Państwo przyjechaliście skąd?
Do Centrum.
Aha, a gdzie muszę podpisać? Czytelnie czy tak?
Nie, cokolwiek, żeby nam się...
No dobra.
Proszę coraz liczyć, że podnieśmy.
Ja mogę jeszcze czytać.
I datę.
A datę, a która data? Siostra?
Wczoraj, tak? A, że dzisiaj?
No to
Wszystko ja.
Ja już dzisiaj nie mam.
Proszę.
Dziękuję bardzo. Dziękuję. A Państwo macie jakąś tam prezentację? Nie? No dobra. Jest. Героям слава!
Could you start record the link when the start?
Okay. Record to music.
Recording in progress.
Only host can start recording.
Yes. That's great.
First of all, this look far from here, there is a Japanese restaurant. If you want to continue just the English book English probably less than French. Yeah, because you know, that's the same as the training. I understand what is here. The Georgian line is good. Yeah. So you can try the Georgian first. This another version. You try it. In Italian and one. Steam is a lot of tests. Зачем проводить точку докладу? Nobody will give us assurance. We are alive. Yeah, but we hope so. Yes, we do.
Вот на тот, который вчера.
Секретариат. Давайте посмотрим. Это вы выступаете после кофе-брейка? 10. А, 10. 11. Все?
Okay. I have reason to the position of authority, but only First of all, I want to see the we need to make This means that this song is so urgent. We proposed this. Let's because I need to check. Maybe we have more some. Because how we in the moment while we launching because we can't get this
I can test it.
This is the list of the microphone. Is it good? Is it not good? Please confirm.
Dear colleagues, please take your places. We are starting our morning session. Our today's first morning session is radioactivity dynamics in forest systems. And the first report is by Professor Radiological danger of wildland fires and firefighting in air-contaminated places in Chernobyl school zone.
Good morning, dear colleagues. I'd like to present you our theory work about the estimation that was for the fireman during the fire on highest contaminated territory in Chernobyl school zone. It's worked together with Medical Center because we use the data of measurement activity concentration in the air. During the last 7 years, we had the fire on the half part of the territory of exclusion zone. Outside the Chernobyl exclusion zone, we haven't any problems with radiological problems with danger of forest fire for the population. The uptake of cesium in Kyiv, for example, is less 0.02 milligram per day, and the dose less 190 per day during the highest fire in Chernobyl exclusion zone. From the estimation, he presumed the value of dose during the April 2020 was for the area for the children was only 30 and 40 microliters. It's very, very low value. This value uptake after the forest fire, key, for example, we obtained now this raw urine receptor only. And it is not possible to estimate the corrective dose if you have this very, very low level of individual dose. I really don't recommend to use this value for the estimation of the risk, cancer risk, because it's very, very, very low value. And we haven't any problem with fire for the population outside the exclusion zone. 20 years ago, we had the active experiment with the simulation of resuscitation rate in fire during the forest and middle fire in exclusion zone, estimated dose for the fireman, for the people, population outside the exclusion zone, and also for the worker in the exclusion zone. We estimate the fire in different places of Chernobyl exclusion zone, forest fire, and estimate the dose for the population. You can see the dose, it's very conservative estimation, where the direction on this settlement during the time of the fire. Very bad weather condition and dispersion of radioactivity. But in this case, we have the dose, the less 1 microgram. It's very, very low value. And also resuscitation, there is redistribution of radioactivity. It's very low. You can see here, it's about the less 1 becquerel per square meter. It's in the thousands times less in comparison with global fallout before the Chernobyl accident. It is not an important value. Also, we estimate the value for the worker in Chernobyl nuclear power plant reactor, and the dose is about microsieverts. The highest dose we have was a fireman near the fire, because it is not possible to use the model for this estimation, and we use the measurement activity near the fire. In our old publication from our experiment, we estimated the inhalation dose and the total dose. But this estimation was very conservative. And now, if we use the dose, the highest value dose coefficient for the inhalation, for the worker from the basic safety standard, for example, for cesium, it's for the AMAT 5 micrometer, and for type of the solution F, for the strontium 1 micrometer, for plutonium 1 micrometer, and the different type of the solution, and we use the highest value for each rating type we use. It's very conservative. In this case, we obtain the inhalation dose in comparison with external dose in 10 times less. External dose in any case is more higher in comparison with inhalation dose for the fireman. And also you can see the influence external dose from the cloud and inhalation dose. The difference very big, but in mass media you can see the increase of external dose in fire during 10 times and 20 times. It is not true, because the dose before external and after fire is the same, and higher than, because it is not possible. Value from the cloud is very low, because activity is very low in the air. During the 2016, we had the fire of the territory, highest contamination territory of red forest in the area 300 hectares, and 2 years ago we had the fire for very big territory, and also the territory red forest and near nuclear power plant. For this fire, we estimate the dose for the fireman. Here our estimation of different landscape in red forest. Here is a contain from the fire materials, density of fire materials for this territory. Here is distribution of the fire during 2 days. And here the release of emission of strontium, for example. Here also we have cesium for plutonium from this territory during the fire. And here is the dynamic of release, strontium and cesium, plutonium and emission. Here is the density of contamination. The density of contamination and the distribution of radioactive in forest by because the different ones. Here you can see the point of the measurement activity concentration near the front of fire, here in 2016, and here 2-point measurement in 2020. It is highest activity concentration. Here is the point of monitoring around the Chernobyl nuclear power plant of epicenter. And here you can see the measurement activity concentration in point of stationary point of the last point of epicenter. And for example, here in Kakashi, it's distance about 5 kilometers from the source or from the red forest. But in this point, activity concentration of strontium is higher in comparison to activity with this. And also another point, you can see we have maybe the same area for the activity concentration of the strontium and for the cesium. It is not near the fire, it is the distance. For example, here 5 kilometers, and here is distance about 30 kilometers in the digit shape point. And also, you can see the difference is not very big for the strontium and for cesium. Here is the same picture measurement of circuitry points in 2020. The activity concentration for different point in Chernobyl, Vitaly, nuclear was before the fire, in highest contaminated territory, during the fire, and after. And I said, the fire don't include in the change of the dose rate. And here is a measurement, real measurement activity concentration near the front of the fire. For this point, we estimate the dose of the fire. The highest value obtained is for the 2016 and here 2020. Yeah, this point. The highest value activity concentration for we obtained for the strontium. This value was about 1.2 becquerel per cubic meter. It's highest value for strontium. For the plutonium isotope, the highest value was about 4 millibecquerel per cubic meter. And also very important, when we estimate the dose, also need to use the activity concentration of plutonium-241 together with alpha-emitting radionuclide. The most important is strontium. Influence the cesium is very, very low in the dose. For the dose, influence on cesium is less 1%. And as you know, moderate transfer of the cesium. Cesium is not important for the radiological measures. Important strontium, plutonium, and americium. And also, for this case, here you have the total inhalation, internal dose, and here you have the external dose, and you can see the external dose is more higher in comparison with internal inhalation dose. And in any case, the biggest value will take about 20 millisievert during the walk 1 hour. If we will have the dose limit 20 millisievert, it's 1,000 times higher in comparison with this estimation. And the people can walk during the 1,000 hours. If during the day 10 hours, it's 100 days in the fire. It is not possible. And the real we have the problem with dose higher the dose limit in this case. But you can see from the cesium, the value of dose, for example, in comparison with strontium, is very, very low. And also, certificate obtains the activity in the respirator of the fireman and also with the staff of epicenter during the sampling of the aerosol sites. And the activity of strontium and cesium in the respirator during the walk about 2 hours was about from 1 the maximum value to 4 becquerel. If we used the volume of the air from 0.53 cubic meter per hour was during the hard walk at the people, we obtained the value of activity concentration the same of measurement by aspiration of the air. It's about less 1 becquerel per cubic meter for the strontium. This result is very good agreement with measurement activity of radioactive aerosol. And estimation of inhalation dose here was without any radiation protection, without the respirator. If you use the respirator, the inhalation dose will be 10 times less. And it is not possible to estimate the internal dose by measurement, for example, containing cesium in the body, because it's a level 1-2 becquerel. It is not possible to obtain this result from the inhalation. And from our estimation, we, together by the support, the support over here. We create the software for the data center, and this software, by this software, you can estimate the dose for the fireman for different point of the Chernobyl exclusion zone for different type of the fire, and the people obtain the information about the estimation of dose and fluids to the health before the beginning of the war. And this estimation very good correlation with measurements the activity of radiant light in the air and simulation of the dose. Thank you very much.
Thank you, Larry. Any questions to our reporter? No questions? Thank you. Okay, well, let's save a couple of minutes. The next our report from Chernobyl Ecological Reserve, ecological consequences of Russian invasion for the ecosystems of the zone.
Презентация. Она его прошло. Давно.
We have 15 minutes.
Может, Господи, тысячи показать. Да. Почти 18. PDF? Да. Есть переключатель.
Chernobyl Reserve is some kind of sanctuary for biodiversity in Ukraine. It's one of the biggest natural reserves. That native reservoirs in Ukraine have a lot of biodiversity, and I won't say how many of different species. You can see it on the slide. We have a lot of species which are attached to different kinds of species like in Ukraine and in Europe and global scale. The main ecological consequences of Russian invasion is, first of all, is increasing in number of big fires. Another one is illegal logging. But this one is not as great like wildfires because logging usually in small scale, sometimes it can be just few trees around the roads, and it's quite hard to detect its basis if we can't go around the exclusion zone. Another one of damage to ecology situation is disturbance or removal of the fertile layer of soil. It's most expensive like trenches or some fortification built by the occupation forces, and it's have a local character. And from this year, you already start to learn how this influence on the ecology of the flora of the exclusion zone. One of possible influences is also poaching of wildlife, but we all know that there are a lot of animals in this exclusion zone, but we can't prove how many of it was illegally hunted during the occupation, because if there is some dead animals, we have a lot of predators like wolves and we don't have any evidence after just a few days after the incident. One of the another big problem is landmines and unexploded ordnance contamination. Because we have a lot of, some territories that have military action, some territories occupation forces there. We don't often have exact territories where we have landmines or unexploded ordnance contamination. It's linked to situation where we have big restrictions to move around the coastal zone. We can't go to the forest. Usually can't move on with the roads, and it complicates the work of natural reserve and all the enterprises in exclusion zone. Also, we probably have some chemical contamination with pollution by household waste and germs of military equipment, and in general some damage to ecosystem functions. The last one is quite hard to estimate because ecosystem functions in the territory of exclusion zone were never estimated, and one of them is the biggest is deposit contamination of fragment exclusion zone, and it's need to be estimated what interesting reaction have on radioactivity contamination. We start to estimate ecological consequences of military action on exclusion zone from wildfires, because it's easiest to detect from the satellite data. But we need to differentiate, because the Chernobyl exclusion zone have a lot of wildfires, as you can see on the slide. Some years we have up to 100 and more, and in some critical years we have some big wildfires with tens of thousands of hectares of fire. So we need to differentiate which wildfires will occur through the military action with the war and show it. This example of wildfires in 2002 is I just have some data from more disciplines to show that big wildfires in such it's quite rare occurrence with the inclusion. We have such big wildfires in 2015, 2020, and now we have a lot of big wildfires in 2022. So we start from mapping wildfires. We using the civil channels and manually detect the orders of wildfires to determine the consequences and estimate the area. So for now, we estimate that during this area in the exclusion zone we have 66 wildfires on area more than 31,000 hectares. From this so we have around 50,000 hectares occurred during occupation, and the rest of the wildfires were after the liberation of exclusion zone. The red one in the slide is during the occupation. Most of it was in the southwest part of the exclusion zone. And the yellow one is big wildfires which were after the occupation. So now we have recorded more than 9.5 thousand hectares of grasslands, more than almost 18,000 hectares of forest, some swamps, and lots of categories of lands. This example of the maps with different species which were recorded during the wildfires in 2022. As you can see, these wildfires were in spring during the occupation, and at that time most of it was on the grasslands of the former agricultural land. And the wildfires which occurred after the liberation of the exclusion zone were a lot of forest wildfires. So we need to estimate how it influences on the general situation with this forest and how many forests will die after it. I'll try just make some indexes with other data. It's show the severity of wildfires. Usually use to estimate severity of wildfires, but we need to verify this data to determine real damage to forest and the amount of litter plants during the wildfires. The main reasons for wildfires in 2002 were actions in February and March, actions by Russian occupation forces, prevention of wildfires, tumor exclusion during the occupation by occupiers, coordination of exclusion zone by municipality lockdowns and landmines, destruction of stolen fire inventory and fire trucks. Landmines and municipality lockdowns clearing is quite long and complicated process, so especially for forest areas. We should expect for the need to determine miners during the wildfires, firefighting, which tendency of the occurrence of wildfires will continue in the future. So we expect that in wildfires will be the next few years at least. And we have some complication in estimation of consequences of ecological damage by the Russian invasion. First of all, it's a lack of methodologies for recording losses of military action, for the quantitative and monetary assessment of damage to ecosystem and ecosystem services. Yesterday in the evening, we had some presentation about this problem. Also, we have lack of the coordination by lines and municipal departments. And also, it's quite hard to determine to find out small areas of damage using reliable free satellite data, because some of data which have bigger pixels like 1 meter or 5 meters is usually paid, and we haven't access to it.
4 minutes.
Thank you for attention.
Thank you. Are there any questions for our reporter?
Yes.
Please.
Yeah. Have you reached out to Planet Labs about getting satellite imagery at higher resolution?
In the beginning of the invasion, like beginning of March, I tried to ask Planet. I tried to decide, but they redirected me to some Ukrainian films, and I just don't finish this process because it was too long for that time. Because in that period, we need to quite quickly determine what areas are important and what will be consequences in that time.
Let's talk later.
Okay.
Any other questions? Please.
Is it possible to detect wildfires early enough with satellite imagery? Or do you need some analysis?
In satellite images, we usually use some existing system like Philips Edis. They have time like around 3 hours from the satellite moving around the point of wildfires and the data during the sites. So it's not quite very quick response to wildfire if you use only satellite data. Maybe in future if we shorten this timeline, but because you know that it can be like 1 hour, it will be quite bad, but it's not the best solution for wildfire detection. Because for 1 hour we can have a quite big streak of fire.
No questions? No questions? Thank you.
Next, our report is drone studies of the forest ecosystems in the Chernobyl exclusion zone. It is prepared together by our Japanese and Ukrainian colleagues. And do we have a reporter online?
Who is reporting?
Mr. Holanka?
No. There is no such Mr.
Where is that? Литвика, Okay, maybe I suggest to shift to the next presentation. And we shall check the individual reports. The next report, unless are you ready?
Yes, I'm ready.
Okay. Leslie.
Hello everybody, my name is Oleg Yasinski, Chief Executive of this company. I will very shortly introduce my company. We have 14 years of experience of selling satellite imagery and also mapping based on the satellite imagery. And we also suppliers of all commercial operators of very high resolution imagery in Ukraine. And I wonder that when the previous reporter asked the Ukrainian distributor of Planet, and maybe it was us, but I have to check, not us, because we are also distributing Planet data in Ukraine. And if it was the case, we would provide this data, of course, for free for your research. In 2016, we provided a creation of 25,000 scale map for exclusion zone for the Rhodos project, thanks to Mark Железняк. For this work, of course, it is a very huge need of constant updating maps of the exclusion zone because there is a lot of wildfires and some changes to this territory. For updating maps, we used Spot 6 satellite. It's 1.5 meter per pixel resolution, provided by Airpass company. At that time, it was the newest data possible to find on the internet, and it's not so expensive because it's just high resolution, not very high. That's how it looks. Spot 6 data. We also used a 1986 topographic map made during the Soviet Union of 10,000 scale, just for the reference where the villages were, where the fields, the crop fields were. We also used the Sentinel satellite data during the winter time because one of the requirements of the project was to distinguish between coniferous forests and just regular trees. The deciduous, yes, because the fir tree and regular. So we created this map of 25,000 scale, and now it is the reference for some of you may be presenting here. We also provided in 2020 digital elevation model of Sahan River watershed. We also used the 10,000 scale maps made during the Soviet Union because the terrain hasn't been changed a lot in the exclusion zone, and those isolites, if you see, were just digitized, and as a result, we have got this digital elevation model. The absolute vertical accuracy 2 meter linear error 90, and it is just corresponding to the accuracy of the 10,000 scale map provided by Soviet cartographers. But the main activity of our company is supplying the satellite imagery for Ukrainian customers. This image, you can see the 40 centimeter data of Chernobyl field from the shotgun industry. Chernobyl industrial site. It was made on March this year. And just for your comparison, we also provide data of black sky imagery. This is 1 meter resolution, if you see. And this is the regular Sentinel data, which is available free of charge. So you can download from the internet. So just the comparison for the same table. The maximum possible data available in terms of resolution is Maxar 30 centimeter data. And last year also Airbus launched 2 satellites of 30 centimeter data that can be acquired at nadir. So here you can see the off-nadir angle is 25 degrees. So it was just like off-nadir image. But still, the original is 30 centimeter of Worldview 3 satellite. We also provide imagery for Zaporizhia nuclear power plant, and it was acquired in April, I guess. There was the fires near the nuclear power plant caused by the sharing of Russian military force. And you also can see the holes in the industrial building of Zaporizhia power plant. And you can also... It's 30 centimeters, but as soon as this image was acquired at nadir, maybe 20 degrees of nadir, the ground resolution is about 35-36 centimeters per piece. Here you can see the military equipment with the tanks or BTRs. I don't know how these vehicles are. So it's a military vehicle which was located along the industrial building and near the reactor itself. I would like to shortly provide you a demo of Secure Watch. This is the geo portal, which just a moment. So this is a geo portal. You can access it with your account, if you pay, of course, for this. So that's how it looks like. This is our account of this company as soon as we are distributors of Maxar. Here you can find the imagery of Maxar. So the whole archive possible of Maxar can be found here. So first of all, I would like to show you the Kherson area, where now is the active military. It is active in terms of military activity, and it's Novokakhovka. I want to show you the Antonovsky Bridge. This is the bridge connecting Kherson and Crimea, and it is constantly shelled by Ukrainian HIMARS artillery. So you can see here at the bottom, you can see the possible dates of acquisitions over this area. So this is Antonovsky Bridge. And the last date it was acquired was 21st of September. If you can see, 21st of September 2022. So it was made 2 weeks ago. So as you can see at the screen, here is the holes in the bridge, which was done by HIMARS artillery. So this bridge can be crossed only by foot, not with any vehicles. And if you want to see how it was looking like, for example, in May, we can switch to the May, and you can see that there are no holes and there are no problems. Else, we can see here that they have a ferry. You see a ferry here, which is waiting to be loaded by the line of vehicles that want to cross to Kherson area.
And the other image was acquired on 19th of August. I will show it right now. You see the ferry is already loaded, and there are still some repairment works of Russians, so they were trying to patch the bridge and to make it possible to cross for the huge big vehicles, for tanks and everything, but they have not succeeded with this repairment, obviously because of the next HIMARS shelling. And they also tried to make a pontoon bridge here, but they never finished this work because it can be under attack any day. But we can see what they are thinking, what they are making in their minds, what they want to do. So you see there is an existing ferry which can carry small vehicles into this. So now I would like to ask of you any territories that you want to see which was acquired recently. Maybe you have some very important places that you want me to see, to show you right now. I can do it, no problem.
This shows the surface of the cooling pump now.
The surface of the cooling pump. Okay, no problem, no problem. Let's go to the cooling pump. But this is not requiring the very high resolution. You can see it in Sentinel 10-meter resolution, and it will be also very informative.
Maybe Mark wants to see rodents.
No, rodents is
about 30 centimeters rodents.
You can see
which part of the cooling pump you want to see?
the most white problem.
Okay. Which is the most of your interest, the area?
The west, it's
Where?
Там, кстати, закачки на другом берегу, мы созвонили. Там канал такой, это ближе воды туда. Да.
Вот это?
Да.
Okay. So this is the last image that was acquired on the 4th of August 2022.
Yeah.
So it was 2 months ago.
Yeah.
But it is, you can see it's a little bit cloudy, and we don't see a lot. But still, you see that the forest here. So this is the bottom of the cooling pond, and it's already been in forest. Maybe somebody else wants to provide some area of your interest. Your house in Mariupol or something like this, you know. So, Mariupol. Okay, no problem. Azovstal is suffered much during the war, and now the occupation administration of Russia wants to demolish all the Azovstal buildings and create a memory park of the Russian soldiers died in Ukraine, something like this. So this is another crazy idea of a crazy dictator. So here you can see the Azovstal as it was before the war. Before the war. So the last time this territory was acquired at 28th of September, you see here. It means 1 week ago, a little more than 1 week ago, but we cannot see anything because it's a cloudy image. You see the clouds.
You have 2 minutes.
Yes, okay, I'm finishing. Of course, it depends on internet connection. If it's good, then the images are displayed very quickly. So it was on 14th of August. You can see the Mariupol here it was also off-Nadir image. You can see the destroyed buildings and everything.
What is the name of the site?
It's a secure watch platform, and yes, anyone can join this platform. It costs like $6,000 for 2 gigabytes package, because this package is going for you pay for megabytes actually. Okay. So back to my presentation here. I would like to invite you all to our conference. Since 2011 we hold the biggest conference in Ukraine for GIS and remote sensing users. And last time it was in October 2021. And this year we have a war and we don't have a conference, obviously, so I hope the war will be finished this year, and next year we will hold another GIS conference. So thank you for your attention.
Thank you, Luis. Are there some questions to the reporter?
Just so slide. What is the vertical resolution of the
Vertical resolution of the images.
Yeah, of the maps.
Of the maps.
The maps.
We can do cartographic production or mapping using satellite image. In order to get a digital elevation model, you are talking about this.
Yeah.
We have to get the stereo imagery, so you cannot build a digital elevation model or digital surface model based on the model imagery. You have to get at least two images for the same area, stereo. We can provide this works, and for Maxar imagery is a 2 meter linear error 90. So this can be done using the stereo imagery of Maxar. This can be achieved. It corresponds to 10,000 scale maps.
Thank you. Other questions? No, thank you, Alex.
Thank you.
What about the skipped report?
Я послал эту агенту первый раз месяц назад. И это посылал 4 раза.
Okay, this is not a
Я
time.
немножко не в курсе. Я включал его в список адресатов. Юрий, блин, там тоже.
Вы можете спросить, ну, очень дальше. Докладчик. Я спрашиваю сейчас, и профессор Лудрин.
Let us go to the next, and our colleagues will try to find missing reporters. The next sub-project is atmospheric dispersion of aerosols. And the first report of Mr. Mykola Kolerka from the Institute of Safety Problems of Nuclear Power Plants, modeling of forest fires in exclusion zone by Radioactivity model.
Good morning. Air contamination is now determined with the local suspension of Chernobyl and global deposition with very low intensity. So the forest fires in the contaminated territories is short-term but very important source of additional atmospheric contamination. And as you know, during last decades, very many violent fires took place in the Chernobyl zone. Last decades, the largest fires was in 2015, the largest in the history of Chernobyl zone is the 2020, and the last this year. And importance of this problem, some reasons of these problems, because the additional air contamination and additional possible dose to personnel and population outside zone. An important point is the partial loss of barrier function performed by forest ecosystem in the Chernobyl zone. And very important problem is the reaction of population, because every sense of smoke in the air in Kiev creates a new wave, talks about the Chernobyl danger and so on. So it's very important to have some instruments, modeling instruments and measurement instruments to show the real situation during the period of forest fires within the Chernobyl zone, of course, and outside for the population, not only Ukraine, but in the European countries at all. One of the instruments is a set of models we developed in our institute, including the atmospheric transport model, which have some units for the calculation of formation system as a perimetric columns of the territory of forest fire. The model of numerical weather forecast, United States model VRF, which used in the operative departments in Ukraine. We have our model is the Institute too. And we use the Roosevelt model for the calculation of the forest fire front propagation. So that it may calculate the formation, the development of fire, and as the input source for the following calculation of emission and atmospheric transport. Input information about the forest, one of the important sources is amplifiers products obtained on the site of fire information for resource management system. The data of radio spectrometers on satellites, of course, information about the deposition and radio ecological information is within the Chernobyl zone about the data of forest and gas. One moment about this model. We performed the radio ecological information in the Chernobyl zone as so-called fuel models necessary for the Roosevelt model. And we may calculate is an example of the front modeling of front propagation during the real fire in the April 2020. You can see as that territory near the Chernobyl power plant, the development of the fires, the place of fires, this period. The most important problem in this calculation is the assessment of system. First of all, estimated of the release activity during forest fires. There are different approaches exist. The most used is the assessment of the area of fires, using, for example, satellite measurements or Grossman model, and using the so-called emission factor, so the part of radioactivity which emit in the atmosphere of the total amount deposited radioactivity on this territory. And now we use the assessment made on the data of Professor Kashparov and Professor Yoshenko. We assessed as 0.5% for forest territory and much more or less for the grass territory for cesium. Another approach we propose the estimation of release using the measurement of fire radiative power of this value available from the satellite measurements, and we propose such simple approach for the amount of activity during the fires using the satellite measurements. And the traditional but complicated in this situation approach, the solution of inverse task of the atmospheric transport model, complicated because there are not a very large amount of measurements of activity in the air during the forest fires, especially from the territory of Ukraine. The last slide is an example of modeling during the large forest fires 2018. This fire is interesting because it is example of real interaction between the prognostic modeling approach is the operative measurements, because mobile laboratory moved to the point where the maximum air activity in the air were forecast during the Rhodes model, and it's possible to compare the real measurements and the results of model Rhodes and our model. You can see the comparison between different modeling system from the distance point. Distance point in Kiev and the closest point within the Chernobyl zone. The general trend is similar, but the largest difference is due first the changing of weather, fast changing of weather conditions, the period, and the different approach to the system estimation within this different modeling system. Is a comparison for different meteorologic data, and example of calculation for the largest fires 2020. The territories of fires. The largest within zone and close to zone is Zhytomyr region, meteorology, and you can see the changing of moment of radioactivity. You can see the formation, some contamination in the western part of Ukraine, where the Rivne and Khmelnytsky power plant may to measure the moment of this radioactivity in these places, and some period of movement to Kiev, to the south, and trans-boundary to Belarus and Russia. As a total time integrated activity, and very short comparison with measurements, in Kiev, and comparison with the result of our model and the RODAS system. The same estimation within the Chernobyl exclusion zone, in comparison with the measurements of epicenter, the closer to source stem, the larger of difference between the model and measurements. So it's very important to correct estimations of source stem, especially for the close zone within the Chernobyl zone. Very interesting situation took place in this period, because after the first period of fires, during these 2 days, fires almost stops, but in this period was the large wind and the dust storm took place within the Chernobyl zone and within the Kiev region and all. And in this situation, from the radioactive particles resuspended with the strong winds from the burnt territories, and this resuspension input a large part of air contamination during these 2 days. After this, the new second wave of forest fires start within zone, but additional input of dust storm this time was important. And this comparison in relative input of dust storms during this period and the forest fires for close zone. Very important dust storm, but for Kiev, input the transport from the Chernobyl zone to Kiev take some percents of the total contamination of air this period. Those estimations during the first period for the population of Kiev, you can see the very small nanozeros in this period, and 30 nanozeros to the end of this year. The main part of the external exposure, and only about 12% due to cesium and strontium inhalation. And you can see that 0.003% of the annual permission level dose. For the personnel of Chernobyl power plants during this period, we estimate very low dose too, about dozens, hundreds nanosievert. And short example of calculation for the last this year fires. Our estimation of annual emission and comparison with the total emission of fires 2015 and 2020, much larger. And you can see the main area of fires this period, much this year. Meteorology, and interesting that the places of the large part of these fires took place in the same places of the southwestern part of zone where the fires of 2020 took place. So in the same areas these fires took place mostly. And results of our calculation of the changing direction. Transport to Kyiv in this period was not very often, only some days, and as a result, the contamination of air in Kyiv, according to our model, was very low. The maximum annual contamination about 10 or 25 microbecquerels per cubic meter, compared, for example, with the measurements during the fire of 2020 in Kyiv was almost 500 microbecquerel. And the last example, we tried with the help of Dr. Sorry. With the help of Dr. Igarashi, we try to use our approach to the modeling of the forest fire in the Fukushima zone. The fire took place in the 2017 and I finished. And result, our calculation is additional contamination of air in some places, and compare with the real measurements of air contamination in this place. So, for example, for Nami town Kianashi, the additional air contamination was several times larger than the background. For Fukushima, the additional very low and compared with the background. And the short conclusion that overall conclusion is dose and for population and air contamination due to the forest fires is very low, much low to the established standards. So this estimation, this calculation is important maybe for the impact on the psychology of the population to establishing thought that the situation is under control, and the forest fires, the transport of ice, it's not danger for the population of Ukraine and Europe and at all. Thank you.
Thank you, Nicola. Some questions? No questions. Thank you very much. The next reporter is Mr. Tabashny from Ukrainian Hydrometeorological Center, and modeling of forest fires in the Chernobyl zone by road system.
Я мушу вибачитися, тому що я буду доповідь українською мовою.
Сьогодні translation. Перекладати треба, так?
Будь ласка.
Так. Sure. My pleasure.
У вас 15 хвилин. Я переклад займає половину часу.
Так, переклад буде так, треба часу.
Власне кажучи, наша робота, яку представляю тут, це є витримки із звіту, який робив Центр прогнозування наслідків радіаційних аварій, за результатами вивчення і формування населення і органів виконавчої влади.
This presentation is a summary of work conducted by the Center, Ukrainian Center of Prediction and Consequences of Radiation Accident in Ukraine, and these results were used to inform to Ukrainian public.
І, звичайно, що тут не буде детального пояснення і аналізу самих пожеж, які відбувалися на території, що була забруднена внаслідок Чорнобильської катастрофи. І Полісся сьогодні є, на протязі багатьох років, є важливим джерелом, звідки надходять в атмосферу на території України і за її межі. Це радіонукліди після Чорнобильської аварії і дотепер.
So this presentation will not focus on the mechanisms or past fire events that occurred in the forest of the Chernobyl exclusion zone that were transporting radioactivities within and outside of Ukraine borders.
Створення при гідрометеорологічній службі Центру прогнозування дало інструмент гідрометеорологічній службі щодо попередження про можливі радіаційні ризики, що виникають з появою джерел радіоактивного забруднення атмосфери.
So the creation of the forecasting center under the hydrometeorological entity, as a part of the hydrometeorological entity, allowed us to forecast radionuclide movement, dispersion, as well as the calculation of threats due to potential accidents.
Прогнозування радіологічних наслідків відбувається з використанням цифрових прогнозів погоди, які ми отримуємо завдяки співпраці з Інститутом проблем математичних машин і систем.
So the forecasting is conducted by the numerical model engine called WRF, whether this is the system that is utilized for forecasting based on the weather and temperature, based on the simulation of the weather conditions. And this is conducted this is, by the way, the link to the WRF model. This is utilized in the States and Europe. This is adding information about the WRF model for flooding various types of events. But in this case, they're utilizing for the radionuclide forecasting under the Mathematical Center of Ukraine.
Перепрошую. Це інститут із глобального прогнозу.
You mean the work?
Sorry, із глобального прогнозу.
Next. Наступний.
Sorry. Із глобального прогнозу робить спеціальні фрагменти.
Це робить інститут комп'ютера, який у вас стоїть. Це робить інститут комп'ютера, який у вас стоїть.
Ну, справа в тому, що нас супроводжує технічна і консультативна, це інститут проблем математичних машин і систем, тому я не маю права не згадувати про це кожного разу. Ну, це
Система Родос також поставила це.
Значить, система Родос нам була поставлена Європейською комісією завдяки наполегливості розробників цієї системи. Карстровий інститут технології активну участь у впровадженні брала Варна Расков, керівник робочої групи, і Марк Железняк, як один з членів цієї робочої групи.
So the Roto system was installed in their computers or servers with the help of the Karlsruhe Institute of Technology and Dr. Raskov, as well as Dr. Железняк. They both contributed to the operation of the Rotos in Ukraine.
Справа в тому, що виникало питання, з якою частотою необхідно виконувати прогнозування, для того, щоб більше чи менш достеменно ми могли отримувати інформацію про можливі радіаційні ризики.
So the key question was, how frequent do we have to make the forecast of radionuclide threats to provide sufficient information for the reduction of radionuclide exposure risks?
На цьому слайді ви бачите, як змінюються результати моделювання, якщо ми будемо варіювати прогнозом погоди з інтервалом 6 годин. Ну, 6 годин перший тут.
So this slide was demonstrating various forecasts from the Zaporizhzhia nuclear power plant. If we make the forecast every 6 hours, this one, starting from 00 UTC, we continue every 6 hours to 21. Actually, every 3 hours, right? Every 3 hours.
12 годин.
It's every 3 hours.
Один і той же вихід.
So the same outlet, the same input, so the same release amount is the rate of Zaporizhzhia nuclear power plant, let's say 80 to the power 10 of becquerel per second, duration 24 hours, and using the condition, you could simulate every 3 hours, so that every 3 hours the different weather conditions will be happening in the...
При одному і тому ж прогнозі на 3 години зміщено початок вихіду. Ви бачите, яка...
So if you delay the release by 3 hours,
того, що ті метеорологічні умови,
the meteorological conditions
вони фактично привели
have
до
changed
суттєвого
and creating different distribution of the special distribution of radioactivity. So the concentration is, the maximum concentration is listed here. Right? So,
змінюється максимальна концентрація.
Так.
Це фактично бібліотеки, які використовувалися для моделювання. Вони фактично є частиною бази даних системи підтримки прийняття рішень для розвитку.
Ти не приклавши ще. Цей слайд показує. This slide shows that two libraries utilized in our system based on the two various scenarios. I guess first is the core melt, as you see here, large contamination leak, and somehow much release, noble gas, iodine, aerosols, and second scenario library, the way it's called, loss of coolant, no core melt, and so forth. So those concentrations are provided as an input in all libraries in the system.
Я перепрошую, шановне панство, але це не про Чорнобильську.
No, this is not for Chernobyl.
В даному випадку це презентація про нашу роботу, яка пов'язана якраз з сьогоднішніми подіями в Україні.
Succeed apologizing that this is for a Chernobyl nuclear power plant, but the work that they're conducting in Ukraine in the current war situation. Yes, будь ласка.
Так що ми припиняємо.
Чому? Продовжуємо.
Але план був такий, що ми вам зараховуємо два доклади. Один про Чорнобильські пожари, а інший про про Чорнобильські пожари. Оце які стадії про Чорнобильські пожари.
Є, звичайно, він заведений в, не знаю чому, висвітлили на той доклад, доповідь.
У нас тут Чернобыльская секция, давайте просто переставим. Девушка, дай презентацию. Загрузили обе, загрузили?
Да, обе есть.
А, так это презентация моей сессии.
Да.
Це через доповідь, я перепрошую, я одразу ще.
Нет, ну начало было нормально, потому что метеорология, она для всех одинаковая.
Я не науковець.
Не, метеорология не была для всех.
Представляється,
Ты не выкинь сейчас прямо на экран. Где вы все? Где все папка нет? Я не вижу, где вижу на папку. Туда папка, но я не вижу.
Там починається крапка 2.
Открой эту презентацию.
На половине мы определили, что.
Ну, это ничего страшного, потому что, ну, я коммент. Principal, when system was installed in Ukraine, was such problem that Ukraine is a different civilizated countries.
Какая про пожары?
3.2.
А, 3.2.
Так я ж 3.2.
Уже в новом country,
А может,
да,
это 3.2.
А как это?
Это
А тогда в конце другой пожар.
24-й, все.
Нет, а что другого нет?
Может быть, последняя сессия.
Так это последняя сессия, это уже 5-й. Это не третья.
Там должен начинаться нарезать.
Может быть,
Я вчера
Мы его не вот это? Да, мы его не подписали просто номером, я нашла в конец.
For the first term, in order system was developed as a special model for
Я перепрошую, вашого дозволу повернувся до того, що було заплановано.
So we are back to the presentation that was scheduled in this session.
Всі ті, хто присутствує в цій залі, чудово розуміють, що ця територія є найбільшим джерелом мобілізації радіонуклідів, які сьогодні можуть з'явитися на території України і за її межами.
All participants of this session understand that the Chernobyl exclusion zone are the potential source of radionuclide contamination for the other areas in Ukraine.
Я ще раз повторюю, що ця презентація – це є витримки із звіту, який робила Український центр за наслідками пожеж, які відбувалися у квітні місяці 2020.
This presentation summarizes the results of the Ukrainian Hydrometeorological Center report about the forest fires in 2020.
Весь місяць фактично в зоні появи пожежі найбільш вразливими були якраз ті пожежі, які виникали на території Рудого лісу, поблизу цього Рудого лісу.
Within 1 month, the forest was burning, and the most potentially dangerous area was the area of the forest, the red forest.
За дослідженнями радіологів-лісників найбільш, так би мовити, потужна мобілізація відбувалася тоді, коли горіли хвойні ліси, порівняно з листями.
Just a second, I'm trying to think. So this is the broadleaf forests when the broadleaf forest fire were not so significant compared to the evergreen forest.
Справа в тому, що причинами цих пожеж були надзвичайно такі критичні кліматичні умови, що температура в цьому місці була на 5 градусів вища за середню кліматичну норму, за норму для цього місяця для Чорнобильської зони.
In the months of forest fires, we think that the driving force was, or the driving factor was the higher temperature, monthly temperature, about 5 degrees higher than the normal, and that was the reason for these fires.
До того ж, ця територія Поліщуків, традиційне землекористування, воно вже спокон віків вимагало спалення залишків рослинної продукції для того, щоб можна було відновити землю. І ці традиції на території Полісся, вони існують і сьогодні. І це теж є однією з причин виникнення пожежі.
Another reason was that some forests were supposed to be burned for the renovation of soils and creating new seeding as a general practice.
Радіометрична мережа гідрометеорологічної служби, вона сьогодні працює фактично по всій території України.
The hydrometeorological network is operating all across Ukraine, as you can see on this slide.
Вона працює фактично рівномірно розташована по всій території України.
The sites are evenly distributed across the whole area of Ukraine.
На жаль, аерозольних установок, які дозволяють нам відбирати проби забруднених аерозолів і аналізувати їх, вельми обмежені.
Unfortunately, the aerosol stations are very limited.
Сьогодні це Київ, Чорнобиль, Снопськ, Одеса.
So currently we could see Kiev, Chernobyl, Odessa, круги, так це. Ці квадрати. So the squares are the aerosol sites.
На даному слайді виведена типове, так би мовити, зображення місцевості, де відбуваються пожежі.
This is a
Де
typical
відбувалися пожежі в даному випадку. Рівень забруднення – це карта забруднення. Тут відповідно рівні місце пожежі.
This is a typical map of forest fire that is created based on the data of the location of the forest fire, shown by the red square in the middle. Levels of contamination, you see on the legend on the top right-hand side, and various. So this is with the cesium-137 level.
Під час пожежі, яка відбувалася поблизу Поліського, де є вельми забруднена територія, показники системи радіаційного контролю потужності експозиційної дози фактично не могла оцінити негативний вплив і появу радіонуклідів, тому що коливання потужності експозиційної дози відбувалося на рівні звичних коливань, які спостерігаються протягом року.
А що це за юніт?
Це потужність експозиційної дози нанозіверти на годину.
So this slide shows the data from the station as near the Polissky QPP as this checkpoint, and this is the fluctuation of that spike demonstrates the concentration of from about 8 o'clock UTC and nanosievert per hour. But from this graph, you see that there is no high increase in the dose due to the forest fires.
Аспіраційні установки, на жаль, в зв'язку з недостатністю фінансування працюють за вельми таким нормальним режимом, працюють кожного дня не більше 6 годин по 3 години. І звичайно, що з таким регламентом оцінити і зібрати достатню кількість інформації про неперервність надходження радіонуклідів можна, але загальне уявлення про кількість викинутих і мобілізованих радіонуклідів в атмосферу, вона дає можливість оцінити.
Unfortunately, the stations are currently operating in the almost 3 hours interval, so they're non-continuous operation, and that limits the capability of detecting the spike of the radionuclide from the forest fires.
Як я вже згадував про пункти контролю, де розташовані аспіраційні установки, звичайно, що ми вивчали і надавали інформацію про появу на цих пунктах, відповідно, це десь до 36 хвилин.
So this is the example of the aerosol station, monitoring station, when the Odessa and Bolshivka, and when do you see the observation? This is the location of the site. Observation.
Це середня величина, яка
This is the average
спостерігання для даного пункту.
That is observed for this aerosol observation.
Концентрація
And you can see that
в квітні місяці була вища, що, звичайно, відповідно до моделювання використованого Родосу, давало підстави вважати, що це Чорнобильський.
So as you can see, on the the days of April, the concentrations were about order of magnitude higher than the average values for cesium-137, and this data that was measured at this post gave the confirmation that the modeling was conducted by Rodos of the radionuclide transport by cloud and aerosols is directly connected to these high values.
Найбільші концентрації спостерігалися у Чорнобилі.
The highest concentrations were observed in Chernobyl. The maximum value was in this range, 1.1.3 millibecquerel per meter cube.
І в Києві теж спостерігали достатньо високі.
Kyiv also had very high values in April, 10s, 11s, 1.7 millibecquerel per meter cube.
700 мікробекерелів на кубічний метр, на 70 мілібекерелів. Якщо згадати норму радіаційної безпеки, вона 800 мілібекерелів, тобто на 1000 разів нижча. І, звичайно, що ніякої загрози радіологічної.
So although these values look high, so 0.7 millibecquerel per meter cube, these are the about, what was the criteria для дози?
800 мілібекерелів на кубічний метр, норма
So it's about 100 times less.
1997 році.
So about 100 times less of the criteria for the, which is 800 millibecquerel per meter cube.
And every day during the year.
Що?
Це на період, це daily, ну,
Це
середня. Так.
Це та норма, яка в цьому підрахунку дає 1 мілізіверт понад природний рік.
800 millibecquerel per meter cube is the annual average.
Ну, на даному слайді видно, звідки відбувалося це пожежа, це у нас.
And this slide shows
майданчиком і
another fire locations.
Інше. Це результат моделювання.
This is the results of the model simulation.
Результат моделювання і результати вимірювання.
And so this is the example of the results of model simulation. So this is the concentration of cesium-137 becquerel per meter cube for the April 10th, 2020. Starting, you see the sources, and it's.
I'm sorry. Where is the source there? It's not in Chernobyl.
The fires here and here. It's on the previous map. It was.
Відповідно джерел поширення поширилися викиди на території
From the fire source, it's spread all, covering the whole Ukraine, from north to south, and also going east.
Порівняння вимірених і розрахованих у даній таблиці говорить про досить порівнянну достовірність результатів, які прогнозуються.
So if you check the modeled and observed concentrations, then we see that the calculated and the measured values are pretty aligned, but very close. So demonstrating good modeling performance.
Ну, це відома інформація, вона взята із джерел наукових дослідників про те, що в квітні місяці в Чорнобильській зоні горіло 2600 квадратних кілометрів лісів.
This is well-known map taken from other sources.
2600 квадратних кілометрів.
So So the
Ви подивіться, це ж Житомирської області і не тільки. Я обмовився, тут зона відчуження і Житомирська область.
So this is the exclusion zone in the red, and this is the Житомир's
Родинський район.
На хвилину. Одна хвилина.
Я зараз закінчую.
So the total is 2,600 square kilometers that was established for the forest fires in April in Ukraine. So one more slide. How many forests were burned every day?
Сумарна активність, вона підрахували наші.
The total consequences
збігається з
are calculated.
інші дослідження.
Are calculated in our institutions and are consistent along the line of other estimations.
Ну і загальна висновок, що найбільше забруднення внаслідок пожеж сформувало максимальне забруднення додаткове 65 бекерелів на квадратний метр.
So as a conclusion, the additional forest fire sources of cesium-137 added about, as you show seen here on this legend, the source of that happened, the forest fires that happened here at the exclusion zone.
Там до пожеж було, ну там мегабекерелів на квадратний. Це більше, ніж до репресій. Там взагалі в 30% не можна рахувати.
Even this fire, so all this total, in total, the maximum value contributed by this fire is 65 becquerel per meter squared in the location. And it's really the fraction of the percent that is done.
Моделювання поширення по всій Європі.
And this is the whole Europe as well.
А це останні результати.
The latest version of
18 травня в цьому році.
May 18, 2022.
Зоні відчуження.
In the Chernobyl exclusion zone.
Вони відбувалися на не дуже забруднених територіях поблизу.
So the fire is shown by cross, but you see it here, that's what happening, the location of the fires, which are not really highly contaminated compared to other areas in the Chernobyl exclusion zone.
Народицьким районом, де досить високі рівні поблизу села Рудня Сошня і Єса.
Мені, будь ласка, висновок.
Так. Пожежа і висновок, що фактично внаслідок пожеж, які відбуваються в зоні відчуження, радіологічні ризики для населення України є мізерними і фактично наша інформація відіграє роль не стільки, як би мовити, науково чи якогось спеціального дослідження. Це скоріше психологічна інформація для вирівнювання психології людей, щоб вони не гостро реагували на появу племін із зони відчуження. Радіологічної загрози фактично пожежі в зоні відчуження, навіть якщо вони відбуваються на вельми забруднених територіях, фактично не виникає.
The conclusions are that even the forest fires happen in the highly contaminated territory, the Chernobyl hotspots of the Chernobyl exclusion zone, the radioactivity risks are minimal, and this information should be provided to general public to make them feel that this threat is not there. Okay, thank you for your attention.
На жаль, вичерпали весь час, питань, чи немає часу для питань. У вас залишилось 5 хвилин, щоб закінчити попередній доповідь, але не дуже.
Дякую, що прозвонив.
The next presenter is Igarashi-san.
Yes.
Processing of the satellite monitoring data on the forest fire in Chernobyl exclusion zone.
Thank you. Title are a little bit different, but I'm going to speak about how to detect the wildfire at the Chernobyl exclusion zone. And this is my first motivation. So as you see, we have a huge wildfire in 2020. Then, as Dr. Tareko said, about the 870 square kilometer. This is 33% of the Chernobyl exclusion zone. And finally, the huge amount of the radionuclide was emitted due to the fire from the burned places. And the current, we have two big challenges in terms of the radionuclide transfer estimation. So first is the estimation of the burned area. And the second is the fire assessment of the fire severity. And the first is this is already Dr. Tareko said, we have a huge, like I said, the range of our estimate depends on the estimation of the burned area. At the same time, the fire severity, this is also make a huge uncertainty because as you see, the temperature is one of the most important factor to emit the radionuclide from the soil, unaided surface soil, or vegetation. And so we need to overcome these two issues to move to the next step. And so firstly, in this study, I just focus on the estimation of the burned area. Okay, and maybe you know this website provided by NASA, and many people use this website as how can I say, fire indicator or something. However, this is a result in last 24 hours data in Japan. And we also have some anomalies here. And this is maybe Nagoya City in Japan. And some part was indicated as the fire or something. But this is just summer anomaly, not a fire. So so this is a burned area product from the NASA and ESA. And maybe we have these two products, but we also have a time lag from the actual fire to data release. For instance, in case of NASA, they have a 3 to 4 months delay for their data release. And this is very small, but in case of ESA, the last data update was December in 2020, almost 2 years ago. So, however, when we evaluate of the radionuclide transfer emission or something, we need to get the burned area as soon as possible. So, not me. Our team, developed the concept to detect of the burned area from the differences of the vegetation index. And so maybe it's easy to write. So when we have some, how can I say, the interest point, they also have when we have how can I say, interest to some specific part, that place has like a specific, how can I say, the history for the surface situation. And when we have devices, for instance, time 1 to time 2, these, for instance, these history move to the to the next stage by the time dependence. So so usually the differences between these two time steps can appear as a normal distribution of something. But when we have some specific specific something inside the zone, like including the 5 square area or something, then this histogram a little bit change, this distribution a little bit change. So our method is to make differences. Is these two distribution. So finally, we can get some kind of the double peak here, and decided to, okay, so this is a bound area or something. And so this processes was automated by the AI algorithm by colleagues in Chiba University. So, okay, and to evaluate our AI system, I used the report from the epicenter in 2015, the fire near the fire near the middle of the Ushi River, and this is also the data provided from the Ukraine National Specialized Company via Professor Tarenko. And we applied our method to the fire events 2015 and 2012, and compare with the NASA or ESA product. And of course, there are some index to evaluate our accuracy or error or something. However, as my conclusion is our product had success to evaluate the actual bound area. And our accuracy is higher than NASA or ESA product, and higher NASA or ESA product, and our error is smaller than their product. So now we get the very good product to detect the wildfire in Chernobyl zone, and this time we applied our method to the wildfire in 2022. I mean the fire in 2000 and applied the Chernobyl zone. And and the left side panel shows this is the wildfire map, which was provided by the Valentin Prosak, and he decided this burn area by the Sentinel-2 and his professionality at the local site for the long time. And this is our result in there. And our product almost can detect the same area as a Prozac product. And so actually, maybe it's not easy to identify the difference of the color via the this system. But for instance, this is the case of here. This is a satellite image in January 2012 this year, and this is a batch in this year. And you can see the differences of the surface color from the how can I say, like a glass color to very dark color. And of course, this is the case of the site B here and the sheet there. And as you see, you can see the smoke from here. Okay, yeah, thank you. And so our product mainly almost can detect the actual forest fire before the NASA or ESA product. So, and we applied our algorithm to the northern part of the Ukraine, including the north part of Kiev city, like A or B. And so our product also detected the smoke from the Anton International Airport in February this year, and northern part of the Kiev city. You can see the color here, and the smoke also appear these places. And our product detected this area was the burnt area or something. And in March this year, here, so I forgot the city, Chernihiv, yes. There are also some places of the wildfire, and you can see the smoke there. And our product, also detected this area as the like a burned area or something. So, and west part of the Chernobyl in March, maybe D is here. Yeah, this is the obvious. It's clear to see the first fire. So totally our AI wildfire detection system, the totally found 545 square kilometers was burned during the February to March in this year. I guess this is due to the impact of the war. This is very sorry situation. Okay, so yeah, that's all. Thank you very much for your attention.
Maybe some questions with Russian. No questions?
Here, what is the special resolution of your systems? You are using freely available sample images, or and when you have our product, what is this commercial product or it's research level product? So is it available for use or for?
Yeah, good point. Good point. Yes. So basically, our product uses the MODIS data. So the resolution, the spatial resolution is a 250 meter, and not so, how can I say, small. So maybe just to get the to get.
So these are free data that you.
Yes, it's free.
Okay, and can it be applied with the high resolution data, or the algorithm? And when you say your product is some software tool, or
so basically, our how can I say concept to detect the forest fire is quite simple. So maybe it can be applied for the how can I say other data set. I guess.
So you are speaking about approach rather than some software tool. It's approach, it's methodology.
Can we get the code, please?
Excuse me.
Can we get the code? He just brings to run.
Code is available. Yeah, available. After the accept of the scientific report.
Okay.
Yeah. Of course, how can I say? I don't have any. How can I say? I'm very always open. to my data set. Yeah, those points. Yeah.
Can I understand, when you say wildfire detection, you mean the assessment of a previously burned area?
Exactly.
Rather than real-time detection?
Yes,
So it's
that's right.
getting a better estimate of the burned area.
Yeah, that's right.
More questions?
And to compare a product is like that of European fire EFIS, because EFIS have quite good data and area for wildfires too, but they use Landsat and Sentinel data. So, how accuracy your conclusion?
So in this case, I just compare with the NASA and the ESA dataset. So maybe the NHS will try. Thank you.
Other questions? No? Okay. Thank you, Rashi-san.
Thank you.
And we have finished this session, and now we have coffee break.
Coffee break, I have an announcement. We have a plan after the next session, 1 hour discussion. Yeah? And after the next 2 sessions. And I don't know about the quick problem of this because it's not the time for the questions. It's good visibility. And I am the moderator of the discussion. I have my own plan, what I have to discuss, but I am not ignoring. So I ask you, BBC, what key points should be discussed during the discussion? Please send me email. I will prepare the list of this point items to discuss. Thank you. And we will continue after 10
Я послал e-mail с моим презентацией на организацию инженеров. Да, вот открыл, он там линк. Ну, то, что 9 мегабайт на почтовый сервер, что это на Gmail. Я пишу презентацию.
Нет.
Напускаю? Нет. Где флешка? Давайте флешку. Попросити подивитися 30-сантиметровий.
Зараз спробую покриття.
Ні, я теж
So this is Eric Hall. So you missed a quite good presentation because done a lot of numbers, methods, archive of different satellite methods, progression, progression was they give you to discuss possible points. Because you see, there are 2 points for years ago.
Actually, I wanted to talk to you yesterday because I was here listening to your report. We are providing satellite imagery for customers in Ukraine, HR imagery, so it's Maxar, Airbus, Planet, and everything. We are official distributors of Maxar to Ukraine, and based on this satellite imagery, we provide messages We also participate in scale map update for the whole Ukraine. The biggest share of the work is done by our company. So I wanted to ask you which satellite is projects, existing projects, future projects.
I mean, until now we haven't needed a lot of satellite imagery, but in this particular case, the project that I presented yesterday, think there's opportunity to work together on collecting and analyzing
Also, our deliverables have levels of disturbance in the different areas. Here maybe we also, I think that the potential enables to apply some satellite data and information, but also maybe some we provide we do it also.
Especially after the war, that's why
so for our project, as I said yesterday, I'm creating the budget now, and the application which describes our partners and how they're employed. So it would help if you could write a short summary of your company and what you do, and also an estimation, like an offer on collection of satellite imagery for the zone and this analytic program.
Lower resolution. So identify how possible the GDU for the structure. If you know the physical side, we don't know. Then you can start.
I mean, a lot of locations are going to depend on our interviews, right? We're going to talk to people, they're going to tell us what they observe disturbances, and that's where we will focus in.
This can also identify from the
areas, yeah. It's possible. I'll just write you an email so you can respond. Excellent.
Yeah, I have another project, it's a successful project, so
Це просто місце зробили мого батька, так що хочу подивитися. Да. Просто я, знаєте, думаю, що це зробили люди, так що це розсуди. Так що, а ви співпрацюєте взагалі з розслідувачами? Надаєте їм як заплату чи вони мають платити?
Які розслідувачі?
Дивіться, як дати.
Ми можемо розповісти.
А то кажете?
А в чому проблема була? Він
А як дату поміняти? Потрібно 28. А як часто повинен бути? Якщо є.
Коли це відбулося?
Дивіться, це відбулося десь в 5 годин вечора, він перестав брати
10:30 ця зйомка
ранку. А тоді можна? А є перше, а вже наступне 10 березня. Да?
Вам дуже повезло, що взагалі це так. А що ви дивитеся? Це раз нам говорили, раз нам говорив 2 дні після старту.
Я вам просто так поясню. Мій батько був командиром взводу тероборони. І він був, ну тобто не оце, що прийшло, а він був там дуже довго. І оце коли сталося, то от вони з його тіла, коли я не знаю, хто його вбив, може це вони з його тіла зняли все. Ну тобто там годинник, от таке. Потім він прийшов в своєму спорядженні весь. І вони їх забрали, бронежилет, сумку. Тобто моя мати каже, типу, давайте оформимо це, якщо ви забрали. Ну, типу, забрали, то давайте ми це оформимо. Ні, ми всі хороші, ми всі потім поїхали мародерити у Харківську область, оце так. Ну, дивіться, вони не всі такі, звісно, але те, з чим я стикнулася, це просто пиздець. Так що...
Це не росіяни?
Я не знаю, може це були диверсанти, знаєте, які записалися, бо вони ну, так себе вели, що вони... Да. Ні, там просто були оці, які прийшли у військкомат і просто з паспортом отримували зброю. І от, можливо, вони там теж були. Просто, знаєте, там ще такі командири були дуже цікаві, які там засіли. Отут є цей Леруа Мерлен, і от вони там сиділи і бухали. От просто от так.
А що відбулося?
Ну вони там як дислокувалися, він, до речі, досі закритий. Ну тобто вони там своїми справами займалися. Так що таке. Ну так, я бачу просто, що це до цього було, а наступне то нічого.
Наступна дата це 50.
Так, я бачу. Ну, взагалі, цікаві речі дуже відбувалися, то там. Якщо таке. Просто це, знаєте, вже воно як доходить до погрози, вони погрожують сім'ї, що якщо ви будете копати, то...
А хто погрожує?
Це частина, в якій... Так. Вони кажуть, вам буде...
А там можна на OpenStreetMap перемкнути? Я маю на увазі в цьому.
Дивіться, оце коли були Бучі, таке це не було.
Коли було в Бучі? Так, це не було. У нас є це дата.
Він один із цих будинків
Стадіон.
А це в частині було?
Ні, це десь там.
Вишнева, 1004.
Знаєте, якби таке сталося,
Ну, ніхто б не повірив, так.
не повірила. Таке може бути.
Так там же ж не було ніяких руйнувань, нічого.
Сподіваюся. Що тут цей робить?
Да. Оце.
Я, в принципі,
Я не знаю.
Ще один в центрі лісу.
А оцей ось там стоїть день, як ви бачите, я їх просто теж.
Ну так, потім можна це якщо збирати.
То зараз в нас
Потім другий центр
ну я потім, знаєте, розказала, як була еколог.
Ну так, так у вас. Приватний сектор український, загальний блок.
Там, до речі, 4 акумулятори, як я.
Ну, не знаю, що це готувати.
Як воно що ходить,
просто зробити
А на телевізорі є
просто вже 2 тижні, як нема погоди загального.
Це менше.
Це
не з'являється. Це де в Маріуполі.
Якщо ви скажете, ні, до нічого нам треба вивчити його. Я повивчити, а вона
Цілий час. Вже повинні бути це, що можна зробити.
Ну, пам'ятаю.
Готовий до починати? Я буду починати. Зараз.
Оцей, так? Ну, цей 26.09.
Одна там серед них ця презентація. Опять 25 с этим ой, блин, тупорылый ты PowerPoint. Только
finish that space by the end of like February. So you use it
сейчас, 2 минуты.
That you applying.
it can be other. Or you mix other rather being
It's not metro, it's underground line for trains.
Dzień dobry.
Pytanie, bo tak wyszło na platformę, nie mieści w ekspresie. Ile macie tam przerwę?
Już
5 minut?
Już się
A mogę tylko z filiżankami zaraz przyjechać po cichutku?
Tak.
Żeby nie było przeszkadzało, bo teraz wziąłem tej brudnej wody.
Teraz za kilka minut zaczynamy.
Ale muszę jechać na restaurację, to tak
jeżeli
wejdę po cichutku i tak zupełnie, no tylko lubię tą porcelanę.
They just call me and usually come there.
Nie no, widno, reszta się daje wykonanie.
Let's start with the position now.
We're waiting for people to start.
Okay, please come back to your seats and we will start the next session. Session number 3, the development and implementation of the tools to predict and respond to accidents.
We have,
Dear friends, dear colleagues, please return to your seats. I will start without you. The first speaker of our session is Dmitry Tribushny from Cultural Institute of Technology, KIT, the columnist co-authors of Tabachny, UHMC, and Professor Zhelezniak, ER. Please, the floor is yours.
Thank you. Good morning, afternoon already, everyone. Today I will talk about the Gerodo system, why it has been developed, what it can do, and recent applications to model the potential consequences of the synthetic accidents or the preliminary potential accidents at Zaporizhzhia NPP and general infrastructure to model or to run such scenarios for virtually any location in Ukraine, particularly, or in the world in general. Okay, so we will talk briefly about the background, why there is a need for decision support system, what the decision support system, not talking about Gerodos specifically, but decision support system in general. What this can deliver for decision-making teams in case of nuclear accidents, particularly severe accidents. And Gerodos is an example of decision support system. What it can do, which task it solves, which simulation models it has. And we will see one example of assessment of potential contamination released from nuclear power plant or Zaporizhzhia power plant. Okay, why decision support system at all? It is clear that the accident happened, unfortunately. So there should be preparedness for those, like what to do during the accident, after the accident, what would be the best or at least the good countermeasures. And of course, one important point is to avoid the questionable decisions. And these decisions can come up easily when there's no decision support system used, or there's no information on the cloud movement is used. And also these tools, the decision support system and the internal tools can be used for planning of the future power plants. There's also a great need for decision support system in the world. There are already operational 450 plants, and many are in the construction, especially in Asia, Eastern Europe, and Middle East. And once Rodos project was established and implemented, the end users requested support by a competent partner. So one organization responsible for the support questions and extension of the system, not the consulting company. There are different phases of event when something happens. So the normal life is the preparedness. When nothing happens, the stakeholders can take participation in the discussions, in understanding the results of what decision support system presents. And education for the personnel can be done, research and development for the new tools, etc. But once the emergency happens, then there are several phases with different durations. So first of all, the urgent response phase from hours to days, and inside within the urgent response phase, the implementation of early countermeasures is expected. So first of all, this should come out not arbitrarily, but as some pre-calculated or the real-time calculated results. And the next one is the early response phase, which the duration days and weeks. The early protection actions are required. Again, pre-calculated, or there should be some base on the decisions. Why this one? Why that long? And after weeks, the transition phase into the long-term phase starts. So the early countermeasures should not be, they can be lifted, and preparation for the long-term remediation countermeasures should be done. Again, which countermeasures for the long term? Preferably there should be the scientific basis, so some estimations, or the countermeasure A is more efficient because it will reduce the total dose. How much it will cost, that much. Countermeasure B, etc. The decision support system for nuclear emergencies should definitely take into the consideration several pathways, so external pathways and internal ones. The external pathways is those which the human body receives from the external irradiation, ground, from surfaces, or from the passing cloud. Internal ones is the dose which the human body receives from the inhaling of the activity cloud or ingestion of contaminated food. There's different contribution of different pathways with time. So in the early hours, days, this is the inhalation from the passing cloud, inhale from plume. The further we go with time into days, this is internal, external from the deposition. Then comes the ingested with food, with months, years, and later ingested with water. Again, you can have some idea which one contributes the most in percentage. But again, on different time scale, or in different moments in time, different contributors become more prominent. So the three main contributors already mentioned is the dose from the cloud, ground, and inhalation. So these are called as CLGRH. And for a typical nuclear power plant accident, there had been a study has been made. Which of those contribute the most? So with no rain condition, it's the inhalation which contributes almost 85% to the short-term 7 days exposure. But for the lifetime, this is the ground contamination. Similar, almost 85%. With rain conditions, this is, well, for the short term, it's ground contamination in both cases. but for the lifetime effective dose, it's almost 100%. Again, this table is just for you to have the intuition what is important during and shortly after the accident. Again, which nuclides? In Gerodos, in particular, we have a list of 140 nuclides which are recognized by the system, for which the special coefficients are in. But in general, only a handful of nuclides is sufficient to cover about 90% of the dose. And these are the krypton, iodines, the main ones, tellur, rubidium, and cesiums. So for the short term, here the percentage of contribution of different nuclides to exposure pathway is shown. For the cloud dose, it's mostly krypton. Again, for typical nuclear power plant accident. For the short-term doses, this is iodine, or the ground contamination. Inhalation is also iodine. If we combine all the different iodines into one group iodine, then it becomes even more important. And only for the ground lifetime, the cesium plays a major role. This table, we usually share this data for our end users. We ask how many nuclides we should introduce into the source term when nothing is known. We say usually when nothing is known, then at least a handful of the known nuclides. When there is an additional information from the power plant provider or from the accident description, then yes, you can extend the source term. So decision support system in general, which task to solve? It should provide a consistent and comprehensive information on different levels, local, regional, national, international, for all accident phases, early phase and later phase. During the real event, the decision support system should provide the real-time or dynamical information. It should use the actual weather. There should be a possibility to enter the most up-to-date known information about the release. The results of the decision support system should show the effect on health, agriculture, economic impacts. And the system should compare the effect of the countermeasure. If a countermeasure A is more effective than countermeasure B. When preparing for possible future events, the system should provide the opportunity, possibility, creating different scenarios and producing background material for planning exercises, training of the personnel. A general good decision support system should assist decision makers in evaluating different measures and promote common emergency management frame. There was a big problem in Europe in early 90s, different criteria for countermeasures. There was no common frame. So each country provided its own vision on the criteria. Now it's better with there are IAEA recommendations, and in many countries the local criteria are similar. So now Gerodos as an example of decision support system. Rodos stays for real-time online decision support system. It's a multi-user operational DSS which can be applied and which is applied in national, regional emergency centers for off-site nuclear emergency management. And here are the countries where Gerodos users exist. In green one, these are the new installations from year 2020 and up to now. The Gulf countries and West Balkans. Okay, then I will be quick. So the system has a wide IT applicability. It can be installed easily at Microsoft Windows Linux. This was an important step after the original Rhodos. Now it's JRhodos, Java-based development. Okay, I will skip the which inputs, outputs the system can produce. For those interested, please take a look at the presentation, the PowerPoint. So there are different models to calculate an atmospheric dispersion scenario, and now the application to Ukrainian power plants, you know the locations. And the biggest questions existed for the Zaporizhzhia nuclear power plant because it's occupied now. And even in Germany, there were media running around what will happen, will Germany be affected or not, how much, etc. So would there be consequences if something happens at any Ukrainian power plant, and in particular in Zaporizhzhia? Which source term to use? And if there are risks from other nuclear installations, like the first neutron facility in Kharkiv. So TIT has been working and is working close together with Ukrainian Hydromet and the Ukrainian Emergency Management Organization within the Hydromet and the Ukrainian regulator. For Ukrainian power plants in general and Zaporizhzhia, yes, there is a threat and the assessment should be performed. KIT supported both Hydromet and the regulator to set up or check the existing Rhodos instances for this purpose. We have helped to refresh the knowledge and refresh the data, so essentially it is the same installation with this very similar data as we have in KIT. So since August...
From April. From beginning of April,
From April 22, KIT exchanges the modeling results daily with Japanese colleagues to compare those with another atmospheric dispersion modeling implementation.
And Japanese colleagues also send results to Ukraine.
This helps to be sure that our modeling software calculates the reality and not something. Because the results of different atmospheric dispersion should be very similar. The weather is the same, but source term it doesn't matter because it's only cloud movement is important. And another important part is the automated calculation. They are great help to be prepared for unannounced visits, unannounced requests from ministries and media. And as I said, in August there have been 5-7 different ones from Germany and Switzerland, asking, hey, can you please show us some results? What happens? Will it be a disaster in Europe or not? So, how it works? In the system, the user selects the scenario, an XML file, which stations, presses OK, says how often, so every 60 minutes, every hour. And the system runs those scenarios automatically every hour. We call it recurrent job launcher. We have set this up. Important part is that the actual weather is automatically downloaded from the freely available US weather service nomads. The same weather comes or can come to Ukrainian Hydromet, and they have also the WRF installation, the final resolution local forecast. Calculations 36 hours long, every hour for all the stations in Ukraine, particularly in Zaporizhzhia. And there are several important endpoints like cloud arrival time, which shows the cloud movement and how much time it takes. Areas for early countermeasures in those rates. So this is how the collection of results is, how the project looks like. And once there is a request, we simply select the pre-calculated project and visualize the results. So there is one scenario, predefined source term for heavy release prepared by the regulator. 36 hours long, made in August. Similar setup with automatic calculations is done also in Hydromet and by a regulator. Cloud arrival time for that specific scenario looks like this. So this area will be potentially covered or hit by the cloud. The definition of how we say the cloud has arrived. Yep. Then ground contamination, the sum of aerosols. Again, the colors for the media, it was not clear what is blue, what red. Red is usually a threat, so something bad. And they asked, okay, where would be the area for countermeasure? The answer is that everything above the 10 to the power 7 here. So orange and up. For this specific scenario, this is this area. For when the weather conditions are different, it will be completely different area. And there are even cases when there is a long tail going in the direction of Germany, and some food countermeasures should be taken. But usually this is not the case. The usual behavior is that the wind blows south, southwest, or east. Same.
That's in Turkey,
Same.
Russia,
this area usually. Or going further to Greece, Turkey, depends on how powerful the system is. So those relate at the end of the scenario, or we produced also the animations. No animation, doesn't matter. The animations are most loved by the media, so we can put them on the screen, they can print some of those.
And what comparison is a lot of modeling in Ukraine?
As I said, the Ukrainian Hydromet has also set up Gyrodos. They use a slightly different source term, but also for heavy accident, and they use two types of weather provider, or either the free NOMADS data 0.5 degree, 0.25 degree pixel, or the more fine, the final resolution WRF calculations, which give also the local effects. And these have, when the user takes WRF as a provider, the local behavior of the cloud can be quite different. So my main point was that it was important to set up the infrastructure, the decision support system, plus automatic weather download, plus automatic calculations. And which weather provider and which scenario to use, this is then up to decision makers or up to the personnel to select. Of course, there are differences, so we can produce later, or we can talk to Leonid Tabachny on producing those results. I have not included them in this presentation. The general behavior of the cloud is similar. The local effects are different. Local means the first 50 kilometers. So, in summary, Gyrodos is a decision support system for nuclear emergencies. It solves the common tasks. It can be, or it contains the models for atmospheric and also for aquatic pathways. It can be installed centrally on one computer, laptop, moved around, and also in a distributed manner with big server in the organization, server clients, accessing the server locally or through VPN. The Ukraine war demonstrated the importance of the consequence assessment, even when the source term is not known. So that's it. Thank you very much.
As co-author of this presentation, I would like to say a few words. Why my name also was this course? Because situation happens that we in Ukraine, after implementation of this project in Ukraine, we have brought it in several centers. It was in the Bashman Center, it was in SMRU, and it was in the Lugar province. When first week after the start of the war, the majority of the settlers stopped to work. Because the Washington Center could not work because Kyiv city was blocked, as we remember, the bridges was not possible to cross by the Ukrainian Syrians. And there was out several, maybe 1 week or something more. Вы не работали, наверное, дней 10, да, когда в Москве перекрыли. Значит, in this situation, of course, we should use this responsibility to support the Korean government. At this moment we have contact with Tatiana Kutuzova and due to her support and support of our ambassador, Mr. Kutuski, it was letter to Japanese government structure to ask also to take part this to be such distributed center. And we involve one of the main Japanese authority who may possibility for modeling. Unfortunately, we cannot now possibility to say details of this preparation, but in the moment where the Washington Center stopped work, and stop work in the not working center in the, I don't know about the SMBU, but in the National Guard, only the work in this moment Rivna Romanenko. At the same time, it was a decision that cooperation between German and Japanese modeling center, and Japanese modeling center received from Germany, from a team of KIT, they received source term for reactors. And from the April, each day it was preparation for the accident in Germany and in Japan. And it was very really important because when we start to compare, of course we see in one moment that from 3 modeling centers, Ukrainian, Japanese and German, 2 provide the same result, but 1 provides different result. But in this question it was no problem which result is correct because both centers provide modeling the same. So it helped to improve situation. What is the difference with Japanese system? It's used, of course, another methodology. They use methodology of GMA, Japanese Meteorological Agency. And of course, they use their own model discussion. But when in this situation, even with the difference in meteorology, the same source can be received was result for Japanese and German result. Practically, with Japanese you never have big difference. All time because the same basic equation, but different methodology because it's different but not and also now in working very close with Centrum Tabachnik was saying about it. Now also good comparison for direction for the but difference in the source term, different source depth is different is the level of deposition and concentration. But this question was a fuzzy group. So this international community practically helped Ukraine to receive the trustful result. It continued. So, and also we try to implement, also use intellectual possibility of United States. We will calculate two national laboratories start moving in this direction, also provide information for Zaporizhia in our next presentation. Thank you.
Yeah. Thank you for the comment. Do you have any question? We have probably, okay, we have 2 questions. Okay, please go ahead.
The biggest problem in the system, the RODOS is search term, description, of course. For example, after the accident, after the release of radionuclide, the first information about the dose rate we can obtain from the monitoring system. Without the content of radionuclides, concentration, it will be only increase of dose rate. Can you recalculate this value in online regime for reconstruction of those search term?
We have such an internal
because very important one knows that if you obtain the information after 3 days, you lost 3 days for countermeasures.
Yes. So we have an internal project directed exactly to the source term reconstruction based on the information on the measurements around the fence. So 500 meters away from the potential release point, or 1 kilometer maximum. The results are mixed. I would say sometimes it works, sometimes it doesn't. And this approach is not very much applicable throughout the world, because it's not very common that the release location has many monitors not further than 1 kilometer away. Like we discussed this with the Hong Kong Observatory, and the closest power station is the Chinese one, 50 kilometers away. They have no access to it. So,
for example, for Zaporozhye.
For Zaporozhye, it would work.
Each unit work different time. The very different contain of radio supply. And the release may be very, very different. Maybe gas, maybe different fuel. It's and very difficult to recalculate from the increase of those rates. Because you have information about.
I can say problem. Now in California, 3 o'clock of the morning. Yeah. And now waiting to my presentation. I have request to start the presentation. Start. May first put California, Canada, and you after that. Okay. So I put the situation in Zoom. We see Boris Pavlyuchenko in the Zoom. Before Boris start, we see Boris.
Boris Lopez.
No. Red one.
Boris Pavlyuchenko.
Yes. Please ask him to Boris Pavlyuchenko. Could he ask?
Микрофон, у него микрофон.
Ну, по телефону надо слышать, по крайней мере. Борис.
I asked him to unmute, but he doesn't respond.
Okay. Владимир Королевич, Канада, do you hear? Are you here? Владимир.
О, Владимир.
А камеру можешь включить? Привет.
Hi guys.
Так что мы пустим Канаду тогда, потом уже продолжим обсуждение.
So we'll continue the question. I know you have some more questions, so we'll continue during the discussion. End of the session, we have some time to discuss.
Okay.
But, thank you very much again.
Да, Володя, учитывая, у тебя который час сейчас? Ты меня слышишь, Володя?
6 часов, 16.
Что я путаю?
6 часов.
6 часов чего?
Вечер. Утро.
Well, morning. AM.
Расскажи, где ты находишься, и тогда...
Okay, guys. Is Ukrainian or English, actually, when it comes to official. So it is English then. I'm in Canada. That's the river. Chuk River, the war address is used to be, then it used to be an ACL. Right now it's Canadian nuclear. The water is government owned, privately operated. We have a mandate, we have a contract from government. Okay, any problem hearing me?
No problem.
Okay, good, because I see a lot. Anyway, we are a research and development facility. In the first place, we used to have a research reactor indeed. We are not in utility. And for this reason, we serve Canadian nuclear industry, providing them with a small-scale nuclear emergency response software. And we provide all the R&D needed for government of Canada to answer all the possible questions that may cause that death. This is very more than university then, because the university compared to us have smaller contracts, shorter contracts. This presentation today would be the succession of some projects I had in the past, and then it was taken over by Mr. my co-author, actually, at the moment, at least at this project, his project team. I'm a holder of a couple of tasks on the office. And this is an emergency response optimization. Let me start the presentation. You tell me if anything is...
Can you share the screen?
Share screen, share screen.
Yeah, that's what I'm doing. Second. Okay, here we go. Okay. Sorry.
This was the first slide. Start from the first slide.
Yes, yeah. And yeah. There's a different screen. That's cool. One second.
You can see your screen, you can start talking.
You see your slide over here. We can see your slide.
Screen one. My apologies. And it's the first one. And
6 again.
Can you, I cannot tell what you see.
Slide number 3.
We see slide number 3.
I'm sorry now. Tell which is on the screen now.
We can see slide number 3, but okay, this okay. We can see slide number 3 now.
Okay. Now I have the big stop control, which I lost.
Please explain what you want to do. Maybe we can help.
You can optimize your presentation.
So I want to share with you the screen.
We see your screen. Everything is okay.
Slide number 3 is currently
Slide number 3.
PowerPoint presentation mode. Do you have two screens or something?
Do you see the first slide?
No, we see the third slide. 3.
Yeah, I see this information right there. So, okay. Do you see the first slide now?
Можливо, українською мовою треба сказати. Згадаєте?
Yes, now we see the first
Бачите перший слайд?
Бачимо тепер.
Бачимо перший слайд.
Окей. Utilization emergency. Бачите другий слайд?
Бачимо.
Good. I'm very sorry about that, guys.
No problem.
Okay, so emergency response. It's plenty of strategies. We did indeed have robots in the past. We did indeed have ours implemented, and that's where we have very deep ties with everything we do. Except it is not just us, Canadian nuclear laboratories. It's Health Canada. They run ours. And they run ARPAs in parallel with a couple of other systems. Now, Environment Canada supplies them with meteorology indeed, and predictions of plume transport and dispersion. Yet the tools remains the realm of Health Canada, obviously, but that's integration in different areas. So we are optimizing emergency response protection strategies for nuclear accidents. And this is a presentation by Dr. Little Bell and myself. Overview, we serve the traditional and usual to all of us mandate, ensuring readiness to respond in event of radiological nuclear emergency. In Canada, our broad science and technology mandate is to inform decision making and solutions in emergency situations. First, organization of response, consequence management, and so on. So, preparedness, pre-release, accident release, transition to a hard phase. All only too familiar to all of you, and subject to attend to are indeed, again, all only too familiar to all of you. That's a partition, and there are a million ways to skin the cat, so that's one way to partition. One way. Actually, I'm way more focused on environmental transfer, field studies, and dispersion modeling, and aquatic transport. Time dispersion, I delegated it now, somebody else. Yeah, and I started UV mountain measurements. Everything else is loop and here answers. Or if you have any questions, you may later contact him. So challenges we face. Obviously, we cannot deploy, we cannot have a luxury of blind measurements. We cannot just push the button and expect some blind measurements to inform us, simply because we have too much to deal with. So even if you cover completely the surface, and to give measurements would also be insufficient. So we have to follow the alternatives to blind measurements are following the plume. And they have their challenges in turn well. So first of all, we need the best available precision in space and time. That's never possible. Real-time recording in rapidly changing weather conditions. Again, on site it is downwind with plume mechanism. Inevitable scarce instrumentation and other resources, and the need for optimization of the deployment during acquisition of data, radiological data in the first place. Dispersion, transport, and those modeling based on the data and emergency response and protective measures to communication. These challenges are eternal, they will haunt us wherever we go, and we will never completely satisfy them. So that's an example of Bruce Power. It used to be the largest utility in the world, I believe. Then it was indeed surpassed by Chinese. Somebody else really lost track here. Anyway, that's a Bruce Power, Bruce Peninsula here, and Lake Huron. You see monitoring stations, roughly at 1 kilometer space in the vicinity of stations, and in the climate, it seems to be fine, because they see it's upwind, downwind, for whatever wind direction it is, showing the same amplitude of gamma emissions of stations. So in the near field, we thought in the distant part that we are covered, indeed we are not. So the plume has too many peculiarities in the meteorological field. Is too complex to be handled just by this amount of measurement. That's why we need mobile measurements going along with the field. So some ongoing capabilities we have developed and keep developing, so radiological data simulation. For algorithms, we measure specific parameters whenever needed, for conservators for distortion, position, and migration of radio nuclei. Airborne gamma spectrometry using an unmanned area neutral POV or ground-based air sampler implemented into a system of data simulation. Yeah, we wanted to ideally to have what we have in FDR in meteorology, not very common then. So we studied, as I said, parameters. For example, we studied solid absorption kinetics in feldspar plates, looks for vertical profiling, indeed for signal strontium as a function of acidity, temperature, concentration. We are looking at experiments on a sloped surface. We didn't do it yet. If you want, anybody want to participate in design planning and results sharing, yeah, that would be a bonus for us. It is not a highest priority for us anymore. The combination of different materials highest priority, one highest, and we studied many surfaces, vertical, horizontal line. Current goal, source construction, again a terminal goal. Optimal use of resources for key location in real time and in 3 dimensions. Because of the hotspot localization, during the position is all efficient for decontamination for follow-up effort. Terminal wall. Advanced predictions, modeling of radioactive contamination spread in the atmosphere and water bodies in those moments. That's where we are in the moment. Those were the projection model of nuclear radiological incidents, dispersion model and a particular focus of research at near-field dispersion. As I said, we serve utilities in the first place, then federal level takes over. So larger than probably 50 kilometers, it's definitely federal. Deep model up to 100 kilometers indeed. For utilities purposes, and it's an overlap, obviously, and actually this is a near field what we do, and where we serve all colleagues, the operator. That's why near field dispersion. The other application is small modular reactors coming our way, and emergency planning those, or on-site workers in bigger reactors. Urban dispersion complex flows, CFD and wind plan already deployed now. Nearshore aquatic dispersion, mostly experience. We abandoned models for a moment. We tend to use Hawks models, but we didn't do that yet. Mostly experimental. Coupling field measurements with dispersion for optimized ground force operation and projections. Develop environmental monitoring techniques for characterization of human source. Near field dispersion requirements of small modular reactors, emergency planning zones. Again, near field is our focus for obvious reasons. We run models like Max, Rascal, Adam is ours, Ringpulse is yours. Challenges with near-field dispersion projections due to complex topology or building their characteristics resulting in more complicated local fields. We try to address this. Cloud and ground shines can not use simple loss conversion factors. We play with integration, which simplified integration, which can be implemented operationally. I'm going to participate and simplify efforts. Ongoing participation in IACRP on development of approach methodologies, criteria for determining technical basis for exclusion zones for small modular reactors. Now we indeed sit on Canadian standards update committees. So they are constantly involved in the common Canadian standards. One of them is response for nuclear accidents. And that's where this presentation belongs, actually. Ongoing participation, yeah. As a monitoring techniques for rapid characterization of human source storm, we deployed UAV. We used collimated spectrometer and shielded sensor design is shown in the picture, and that's for real time. And real time monitoring will require then data simulation. That's urban discussion. As I said, we deployed the CFD. So we are a bit more looking into that. We didn't do much of that in the past. CFD was mostly for inside containment business. And yeah, indeed we have started in tunnel, as I said. We are looking to establish first in dye-based particle condition rate characterization techniques. That's important. Data simulation for radiology we collected. We indeed started with Gaussian plume, then we went for puff, and then we went for particle. Which is not done. The illustration, I believe, shows you the Gaussian. Flight paths example and simulated those measurements and comparison with validation against iterations and refining loop concentration through measurements to dose and estimated concentration then. And on and on exercise. We look also for the ground parameters for anything underlying our measurements, the position in the first place. We look into cosmogenic and heterogeneous blend varieties, seasonality, nothing, and so on. It's specific, and we really found we are well within parameters shown recommended in Canadian standards, so that's really also Canadian standards. We measured, as I said, near short lattice dispersion. We just go out and we collect tritium. That's as simple as that. You see my back leaning towards Centrum tritium in the photo. As easy as that, as I said, environmental levels of tritium, they're benign, yet measurable, and you see the boost power station in the background on the drone, and that's Bruce Peninsula to you, and drifters were sent out. They initially were thought to help us with discussion. They didn't, obviously, because they are buoyant. And it's not just surface, but also buoyancy, which present us with convergence and divergence, inadequate components to lateral dispersion and vertical. So we use drifters from certain time only as markers for us to go. However, we found that that's where models fail. We found that drifter trajectories on quite a few patterns, weather patterns, were never simulated properly in models. So right now we work on emergency response protocol where the drifters will be sent in any case. And we may probably follow some findings to confirm where the cumulative concentrations. Decision support systems, example, and we were indeed deployed our capability during the pandemic. We looked into the stochastic region, non-stochastic region, and so on. Radiological risks were assessed. That's pretty much it. Yeah. So, questions?
Thank you for your presentation.
That's a key slide for questions. Where you are, where we hope to go, where you think would be interesting for you guys to collaborate. So, thank you for attention.
Do we have any questions?
I have a question. Would you provide measurement of the dispersion coefficient from the Great Lakes? But how are you planning to use this coefficient? Because as I know, ibis that use Canadian system do not include aquatic models. So do you planning to provide some modeling tools with these coefficients with aquatic dispersion? What is the goal?
Yes, absolutely. That's a goal. Yeah. And the tool, our first thing we are looking at is Poseidon, box model, and then indeed Canadians still use Gaussian tool model. Yet it is nowhere, there is no place where it is recommended for emergencies. It's still used for licensing and long-term average those consequences assessment. So we will supply this near-shore dispersion measurements as recommended size-specific dispersion. We are pretty much in line with what Canadians have measured in the past. This is definitely way different from Hugo parameterization, which we developed for a very different environment. And we will have these efforts documented and recommended and placed in standard, but that's a bit a long way to go, still a couple of years, I would say. We have to publish it first. We pretty much finished it. We are stuck a little bit with vertical dispersion assessments. Because too much dynamics and seasonality on top of microscale dynamics. Yeah.
Okay.
Thank you.
Thank you very much.
I have a question from.
Yes, please.
According to the actions, emergency actions planning zones, I noticed that you have the names of the emergency actions planning zones different from the recommended of IEA emergency names of emergency planning zones. And the question is about the correspondence between Canadian emergency planning zones and IAA emergency planning zones, in particular about the precautionary actions emergency planning zone in which actions might be implemented before the release of radionuclides. Only in when we have the high risk of release.
Okay, harmonization is indeed on the table. We are indeed aware of this inconsistencies, and we are working on it. That's Canadian presentation actually, I shared with this one. We have a language implement as well. And I aim to all this. In particular, we are working on oils, operational intervention levels. That's very long section. In short, yes, we are aware of that. And once again, I would rather pass this question to my boss or to Bell, and you have his email, you can contact him anytime. He will be honored to have to take this discussion. Thank you.
Thank you.
One question.
On your last slide, you said that 2D mapping was prohibitively expensive. Can you clarify what you mean by that? Because that's what's done after an accident, no?
One of the ideas tested was the dissemination of disposable radiometers. They would be burned in action. And even that was prohibitively expensive. That's what I meant. Actually,
so you're not talking about helicopter surveys?
Okay. I meant helicopter. Well, yes. This helicopter, that is absolutely viable approach. Except here we go with need for robotic platforms and danger to the pilot. There is a cost in that coming anyway. So what I meant, we cannot have even 2D picture wherever we need, whenever. That's the point. The oldies are limited in our source. That's actually my bottom line here. We are limited in resources, no matter how good we plan.
Okay, thank you very much.
Thank you.
I didn't want to diminish any other approach. Value, not at all.
Thank you very much for your
And if
presentation.
you have any failures from that, so don't you worry about it.
Secure.
Thank you very much.
Please, we will have discussion here after section. Be with us, take part in the discussion. Okay?
Absolutely.
Okay, thank you.
Thank you very much. So next, let's finish we'll continue with the presentation by Tabashny that we started in the previous session, and
Я прошу извинения, перепрошую, шановні, тому
so I'll continue the translation, I guess, right?
маю повернутися до тієї презентації,
I apologize for that I have to return to the presentation that I started in the previous session.
Я хочу сказати, що з початку військових дій в Україні
I want to say from the beginning of the military invasion of
Український
Ukraine,
гідрометеорологічний центр, в тому числі і Центр прогнозування наслідків радіаційних аварій,
Ukrainian Hydrological Center
перейшов на щодобове цілодобове чергування.
switched to the day-to-day shifts of day-to-day shifts.
Враховуючи, з ким ми маємо справу з російською агресією,
Considering the Russian, that we have to deal with Russian aggression and invasion,
можна очікувати
we can
будь-які
expect
наслідки
any kind or any kind of consequences
в тому числі
of using weapons as well, and even the nuclear weapons.
В зв'язку з цим центр перейшов на щодобове, чотириразове моделювання ситуації навколо кожної атомної електростанції.
In view of these potential consequences, our center became switched to daily shifts with 4 hours modeling at each Ukrainian nuclear power plant.
Ви знаєте про те, що і Запорізька станція знаходиться під
So you know all about the situation of the Zaporizhzhia nuclear power plant.
під владою росіян.
They are occupied by Russian military forces.
І ракети були спрямовані на південно-українську атомну електростанцію.
Russian rockets were aimed at southern nuclear power plant of Ukraine.
І в Рівненській і в Луцькій областях теж, і в Хмельницькій областях були проліти ракет, вони розривалися на побутовій інфраструктурі, але виключити, що наступного разу ця ракета не цілить в атомну електростанцію, не можна було. Тому розраховується модель 4 рази на добу для кожної атомної електростанції.
So the reason for this daily shifts, this 4-hour modeling, is because the Russian missiles are flying over various, across almost all regions in Ukraine, aiming at the civilian infrastructure. However, we cannot exclude the possibility that this rocket will, at some point, will hit the nuclear power plant, causing the nuclear disaster. This is the reason why we have to do continuous monitoring and produce outputs every 4 hours at each nuclear power plant.
Чому 4 рази? Ну, на цей слайд ми вже обговорювали.
So we have talked about this slide.
Це пов'язано було з тим, що, по-перше, ми маємо щодоби 4 прогнози на МАЦ, не 0,5, а 0,25, які перераховуються завдяки спеціальній програмі, розробленій Інститутом проблем математичних машинних систем. Цифровий прогноз.
So the reason for 4 forecasts, because we are using the data of 0.25 degree forecasting weather prognosis that is reframed or rearranged using the software developed by Ukrainian mathematical and programming.
Звичайно, що по кожному прогнозу вони будуть відрізнятися до певної міри. Мало сенс робити відповідне моделювання.
Of course, each forecast will be different, and the modeling is rather difficult.
Для кожної атомної станції реалізовувалося 2 моделі. Одна пов'язана з розплавленням ядерного ядра атомної станції, з плавлінням паливних стрижнів, а друга пов'язана на іншому блоці, умовна аварія пов'язана з втратою охолодження реакторів. Звичайно, що...
So for our modeling, we consider 2 input scenarios, called library 1, library 2. The first one is where we have the loss of it's a core melt scenario, and the second one where you'll have a loss of coolant. So like maybe similar to Fukushima, right? With a loss of coolant and power supply. So those 2 scenarios are considered as a standard input for the whole simulations. Could be one block, one site is one library, and next is another one.
Ці сценарії, вони були в Родосі, ми нічого не видумували.
These scenarios are coming from Rodos system, so we didn't modify those.
Ну, відрізняються вони головним чином, звичайно, це потужністю викиду. Перший сценарій, він фактично відповідає 7-й категорії МАГАТЕшно по потужності, а другий 6-й категорії.
So the major difference that they have one level difference according to the IAEA categorization. Top one is the level 7, and the bottom one is level 6.
Перший це близький до Чорнобильської аварії, а другий ближче до Фукусіми.
The first one, you can consider the first scenario of library 1 is the closer to the Chernobyl nuclear power plant accident, and library 2 is closer to Fukushima one.
Ну, це ще раз підтверджує те, що для кожного прогнозу погоди ми будемо мати різні наслідки аварії.
This slide is just to demonstrate that for each forecasting of nuclear disaster, we will have a different outcomes depending on the weather situation.
Тут 2 фактори
Two factors are important.
Сунуто було в часі викиду.
So that this is the change, the delay of the release.
Для кожного прогнозу сунуто в часі. Ми бачимо з вами про те, що контури зон запровадження контрмер, контрзаходів, вони суттєво відрізняються для кожного із прогнозів.
So if you look at this if you look at that closely, you will see that the shift, the time of the release, if it are shifted, the weather will indicate different zones of exposure.
Для кожної атомної електростанції, звичайно, що розраховувався час приходження хмари, відповідно з відповідними цифровими характеристиками, коли вони.
So for each nuclear power plant, we calculated, as was discussed in the first presentation, like the time of cloud arrival.
Будемо так говорити, це для Запорізької станції.
So that here you see for the Zaporizhzhia nuclear power plant, the arrival is from blue, it's very short, and the red is very far, so 35 hours.
Відповідно, маємо, коли приходить хмара в Україну, наприклад, в Росію, більше.
Here you see that the numbers of like 22 hours that the cloud travels through Ukraine, and then from 8 to 35 hours the cloud travels over Russia from the Zaporizhzhia nuclear power plant.
Для інших атомних станцій це перелік розширювався від до прибалтійських і для західних країн.
So for other nuclear power plant stations, we hope, of course, we have different directions that affect European Union countries.
Відповідно, розраховувалися, ну, як на нашу думку, найчутливішим це є категорія дітей, і тому ми вибрали в якості засоби, які необхідно, контрзаходи, які необхідно застосовувати, які треба планувати, не дай Боже, щось трапиться, це захист дітей. Промінення щитоподібної залози у дітей до 12 років.
So to consider the worst case scenario, we selected the group of children younger than 12 years old. So they are most vulnerable to the steroid problems in the future. So we choose them as a target group and did an analysis for them.
Виділяли зони відповідно до критеріїв, які встановлює норми радіаційної безпеки для дітей і для дорослих, де там 200.
So we made the zones that are determined by the radiological safety levels and for children and adults.
Відповідно визначались області, для яких фактично де можуть бути такі рівні опромінення населення ймовірні, умовні аварії, звичайно. Умовні.
Значення
50 і 200. 200 мілізіверт.
So these are the levels of concentrations from 200 millisievert, and you see the zones of 50, and based on that zone you can identify which regions are affected. As I said, Dnipropetrovsky region and which Kharkiv's region, and each region has a district that are exposed to that level.
Всі ці розрахунки входять в інформаційну довідку, яка розсилається по всім обласним центрам гідрометеорології, оскільки представники цих центрів є членами територіальних комісій з техногенно-екологічної безпеки. Вони там відповідають за оповіщення адміністрації управління областю інформацію про радіаційну ситуацію на території України, зокрема в їхній області. І тому, звичайно, що вони повинні оперувати і мати можливість спиратися на інформацію, яка розраховується в нашому центрі.
So this information is distributed through our network of collaborating agencies. That I don't think I will be able to repeat all of those, but the idea is that this information is distributed to them and to the potentially impacted districts and the regions of Ukraine. So as a keeping the public informed regarding the potential consequences and the evacuation ordinance.
Звичайно, що повний перелік населених пунктів і опис для кожної станції, для кожної області ми не надсилаємо для того, щоб не збуджувати, коли нічого поки що немає. Це може привести просто до підвищеного психологічного тиску на населення, на керівництво, щоб не наробили, так би мовити, клопотів. Але така можливість існує.
So when they deliver this, the result of their forecast, they don't include the names of the areas or districts in Ukraine that are potentially affected. And the reason for that, not to cause panic, because this is not the actual accident, but rather than a model prediction of future scenarios that has not happened yet.
Завдяки згоди Карлсруї Technological інститут, ми маємо можливість встановити в кожному обласному центрі, в кожному центрі гідрометеорології клієнтську частину системи RODOS, для того, щоб вони могли безпосередньо заходити самостійно. Там робоче місце радіолога, радіолог є в кожній області, щоб на цьому робочому місці радіолога у нього був доступ до тих нарахувань, які можуть робитися і частіше, ніж 4 рази, якщо в цьому буде потреба.
Thanks to the RODOS system that provides that friendly user interface and accessibility from the site, each Ukrainian radiologist that are located in each region of Ukraine, they could access from their laptops or desktops to the RODOS system to download the 4-hour output, as well as making their own scenarios if necessary to provide more detailed information for their region in Ukraine.
Крім аерозольної компоненти, програма RODOS дозволяє розраховувати рівні забруднення поверхневих вод. В даному випадку,
in addition to the aerosol concentration, we can look at the contamination of surface water features. Yes.
На даному слайді ви бачите для Запорізької атомної електростанції станції забруднення поверхні землі.
In this slide, you can see the contamination of ground contamination released due to the Zaporizhzhia nuclear power plant accident for the contamination of iodine-131 and cesium-137 on the right-hand side.
Спеціальна модель, яка дозволяє, вона оцінює рівні забруднення Каховського водосховища поверхнево, пов'язаного з випадінням радіонуклідів на поверхню, а також на території, з якої можливий змив радіонуклідів у Дніпро.
So this, in the RODOS system, we can, using this ground deposition, we can calculate the contamination of Kakhovsky reservoir near the Zaporizhzhia nuclear power plant, and the concentrations of iodine-131 and cesium-37 in the surface waters.
Має працювати анімашка.
So it's supposed to be animation, but somehow...
Я перепрошую, повірте на слово. Іде просто-напросто видно, яким чином послідовність нарощування концентрації в Каховському водосховищі, яке відбувається забруднення і очищення на протязі 3 місяців.
So unfortunately, animation didn't work, but you were supposed to see the propagation of the concentrations over 3 months as the contamination propagates through the reservoir, taking over all surface water, as well as then washing away by the fresh water that comes from the upstream, and that would be the kind of the travel 3 months travel time of the contamination pool.
Для кожного населеного пункту, розташованого на берегу, який користується водами Каховського водосховища, можна розрахувати динаміку зміни концентрації радіонуклідів у поверхневих водах.
So for each city that located nearby the Zaporizhzhia nuclear power plant, like Nikopol, Marganets, and Energodar, so you could calculate the concentrations in the surface water in those cities for iodine-131 in the top row and the bottom row cesium-137.
Для того, щоб вони могли застосувати відповідні заходи для очищення або обмеження користування водою, як для власного, так би мовити, для споживання, так і для відгодівлі скота або для різних систем зрошення.
So having that information allows them to make decisions about the water use for drinking water, irrigation, or cattle feed, and then decide on some preventive actions.
Розрахунок був зроблений для 16-го.
These results were 16th of
16 числа.
Якого місяця?
Вересня. І
І
далі фактично очищення для різних місць воно відбувається в листопаді, в грудні 2022 року.
So this simulation forecast was made for the last month of September 16th, and you see that the concentrations, the maximum, the reach of the concentration, and the cleanup, which is the cleanup is about by December of this year. for iodine in the cesium radionuclides.
Прораховуються дози, які можуть бути отримані відповідне населення за рахунок споживання води, яка...
So here you could see the doses that could be potentially affecting the children, as it is here from 1 to 5. And the top is, I guess, it's the iodine 131, and the bottom row is cesium 137 for 3 cities, Nikopol, Marganets, and Energodar.
Ну, в даному випадку тут приводиться слайд, на якому в черговий раз ми намагаємося показати, наскільки коректно працює система моделювання RODOS, порівнюючи результати моделювання з результатами конкретних вимірювань на прикладі поширення у 2017 році відомого рутенія 106, тоді фактично всі аспіраційні установки, які гідрометслужби, вони всі тоді зафіксували визначено певну кількість рутенія на аерозолях, які вони відбирали протягом свого, так би мовити, регламентного спостереження.
So this slide demonstrates the example of validation of our modeling system, RODOS. On the example of 2017 case of ruthenium-106 that was observed at various sites, as you see in Ukraine, Romania, Vienna, Stockholm, Athens, yes.
Ну, фактично вся Західна Європа і найближче, це де більше всього було зареєстровано, це Румунія. У них і найвищі концентрації були зареєстровані.
Highest observed values of ruthenium were in Romania, see here.
Ну, а тут фактично знову чергове порівняння розрахунковане і виміряне безпосередньо. Найбільші концентрації спостерігалися в Одесі.
And here we show the concentrations that were simulated on the left row and measured on the right-hand side, on the right.
Я нагадаю, що ви пам'ятаєте, за яким режимом працює аспіраційні установки гідрометеорологічної служби. 6 годин на добу, 3 доби по 6 годин, усього 18 годин. І цього було достатньо для того, щоб можна було зафіксувати певну концентрацію, і, зокрема, в Києві, і в Баришівці. Запоріжжя – це дані системи атомної електростанції Запорізької.
So for Zaporizhia, the data comes from the Zaporizhzhia nuclear power plant, but for the Odessa, where we had some aerosol observation stations, you have to remember that these stations that we have at some locations in Ukraine, they operate only 6 hours per day and for 3 days, 18 hours total, and that was enough actually to get similar results that to validate our modeling results.
Дані цих спостережень та інших, тому що щороку ми спостерігаємо на території України, то цезій до нас залетить 137, то Ю-131. І завдяки кооперації з екоцентром, у зв'язку з кооперацією з атомними електростанціями, ми обмінюємося результатами і можемо звести докупи все це і тим самим говорити про те, що ми довіряємо тим результатам, які обраховуємо за допомогою системи RODOS.
Thanks to the collaboration with Ecocenter, other nuclear power plant stations, networks, we exchanged the data that was recorded by this from various sources, and then we can aggregate them together to validate our modeling of, for example, like cesium-137 or iodine radionuclides, to say that our modeling is relevant and consistent with observed data.
І наостанок про максимальні концентрації, які залетіли в Україну з рутенієм 106.
And lastly, I want to say about the highest concentrations that were caused by ruthenium brought to Ukrainian territory.
Відповідно до розрахунків, найбільші концентрації мали спостерігатися над Азовським морем і на містах, які знаходяться на узбережжі цього моря, зокрема в Бердянську.
The highest concentrations, due to the following simulation, the highest concentration of ruthenium was supposed to be above the Azov Sea and some parts of the coastal line of the Black Sea, like Berdyansk city.
Де протягом 12 годин могли спостерігатися концентрації, які перевищили норму радіаційної безпеки для рутиння 106.
So following from this result, the concentrations were exceeding the limits of radionuclide safety for 12 hours. Це дані були підтверджені?
Ну, ці ні, звичайно.
But we didn't have the data to confirm that forecast.
На лінії переміщення хмари, яка змістила рутині, стояла Одеса.
But Odessa site was on the way from the ruthenium cloud.
В Одесі максимальні концентрації досягали 350 батарей на кубічний метр, але, ну, відповідно до розрахунку, звичайно. Але це було там декілька років, там 4 чи 5 років.
So Odessa monitoring station picked up highest concentrations of 350 millibecquerel per meter cube, I guess, and that was for 2 hours within the cloud movement of ruthenium.
Прошу вибачити за деяку плутаницю.
Sorry for the confusion, and he will take your questions.
Все хорошо кончается.
Questions? Okay. No questions. Okay, thank you very much. And now we go to the, as according to the schedule, next presentation is, yes, Tomski.
Good morning. It's nice to be here with you. As in fact, I can meet some people after years, like Jim after 25 years, I guess. So it's an unusual occasion, I would say. Not maybe very fortunate, the other way. Okay. I know Mark already 30 years or more, because we went at the implementation and development of the rotor started. The practically started at a similar time, or Mike, you were fast. By 1 or 2 years maybe. Okay, and what I'd like to show you here is a bit different application of the rotor system, because rotor is by the definition devoted to support decision-making process in case of emergency. But our application is a bit different in this case, because we think about the usage of the rotor system for the plant, first Polish nuclear power plant, and how this system can be used in such a case. So the goal of this project was to perform a number of different simulations for the expression of radioactive material in environment, and various dose calculations in order to estimate the size of the restricted use area and emergency planning zones. Also, this is for short-range simulations, and for long-range simulations, also those estimation in case of a major accident release. And of course, one of the part is devoted to the implementation of the hydrological model chain. So this is which was done with the help of Ukrainian colleagues. So I will show you later. So at that stage of the project, we stayed to consider two possible localizations were considered. It's Lubiatovo, which is just at the coast, and it's Żaranowiec here. It is the Żaranowicki Lake, I will show later. So those two localizations were considered. The final selection is that one. Of course, there are a number of different factors that influenced to undertake this decision. But at the moment, at that stage of the project, we had to calculate for this both
both for localization, which are not far. I think the distance is about 25 kilometers, so it's quite close, one to the other one. So it was massive calculations in that sense that we had to calculate a number of different doses. So for the restricted use area, which is more or less the same, it's not the same as exclusion zone. Because we have different definition in our regulation. We use restricted use area, which is a slightly different definition. It means that, in principle, it means that no hospitals, no schools, or something that can be within this area. But the normal link is possible. So we have to calculate 33 different values. Mostly that was effective dose for girls, children, infants, including or without injection for various time periods, starting from short 7 days up to 1 year. Then target dose for adults and children, equivalent to absorbed dose. Actually, absorbed dose cannot be directly calculated into the system, so we have to do something with this. For emergency zones, the 75 endpoints for doses and 90, 60 endpoints for activity concentration in food stuff and feedstuff. So I listed some general information about the type of doses we had to calculate. You can see there were effective doses, but the doses for particular for tablets, lungs, skin, and so on. Again, with and without injection, and additional for some heavy isotopes. And concerning activities, it's mostly for iodine, cesium, and strontium. So you can see this is a big amount of different calculations, different output we had to produce. In case of long range, that 14, this is mostly effective dose for adults and children. Also starting from different periods up to lifetime, and also absorbed dose for thyroid. And hydrological pathway should be also taken into account. So we have to implement this hydrological pathway into the general system. So I will show how it was done. So the first question was which meteorological conditions should be used. And according to our atomic law, it's explicitly written that we should take into account the most adverse meteorological conditions. What does it mean? It's a question of interpretation, of course. So we had several meetings with our regulator. Finally, we decided to use 3 different methodologies to cope with this definition. And that was, first of all, it was the longest period of the occurrence of atmospheric inversion, which is a typical situation. You can expect that the doses can be high. Then the conditions favorable for the long transport of particles towards the biggest cities, Gdynia and Gdańsk, which are something like 100 kilometers or maybe less from these places. And take into account the whole area around the Sprant and PP, the conditions favorable for a high exposure and deposition. So for each of this, each method, the reference year has been selected based on the 40 years meteorological monitoring data. So we selected these 3 different reference years, and from these years we selected again 5% of the most adverse meteorological sequences. So that was our approach to how to understand this provision. Apart from this, data. We used also data from monitoring from the mast, and so that there was 2 years monitoring period, which is typical period in case when you have to plan, when there are plans for building NDP. So we have 2 sets in principle of meteorological data, one based on this historical data, and the second, this is also in a sense historic, but it's new data, yes. So this one are based on some synoptic stations, or I would say that, and this is based on this new meteorological mask that was in place. Okay, so as I said, this JRODOS was used to find this restricted use area, internal and external emergency zones, the so-called extended emergency planning distance, and food consumption and contact distance. So these definitions are more or less, I think, are in much agreement with IAEA, some documents. But apart from this, we use our calculations have been used also to verify some safety criteria defined by the European utility requirements, the documents revision D and E. So some additional calculations had to be made because of this verification. The JRODOS system, which is implemented actually in 2 locations, is in our institute, and operating the system is implemented in our regulator. But in general, it's organized in that way that the first implementation was in our institute, then we transferred to the regulator. And that was also the case when geological regions were defined. So we prepared the data for these 7 geological regions, the ecological regions. So it mostly concerns the information about types of plants which are on this area, and the growing time, and all this typical information that are used for these models to estimate intestine losses. So we use this, and this is some example of the results of this calculation. Some area which is denoted by this is the place of the Riviera Locopolino. And based on this, we will produce 100 of this type of these types of figures. Based on this, how it was used later, it was used in such a way that, for example, here there was added that within the circle, it was determined that the first idea how the evacuation region can be. So it means that. We prepared also some very rough estimation of the transportation means needed in case of severe accident, basing on this area. So I mean that can be not only some traffic cars. So we had collected information about the private cars. About we have to calculate number of buses that should be used, and possible usage of oil rail. So that also we did. For long term, for long distance calculations, we use data prepared for our Institute of Meteorology and Water Management. For the mass model, that was already few words were spoken about this model. So for each, first of all, this because of the specific of the characteristic of this severe accident, the release in this case the release the duration of the release is almost 1 month. But the most let's say, the most material goes within the first 2-3 days. So the idea was to find such places in neighboring countries that should be affected the most. And because of this characterization of this risk, our Institute of Meteorology prepared trajectories and to find the dates to find such dates that this plume will go very fast to the receptor point. That was the idea. So they prepared some trajectories, and there was selection of the 10 different vertical levels, and the fastest trajectories were selected for each sector. And apart from neighboring countries, we used also some country borders. The country borders were defined as countries, but also voivodeship is an administrative region in Poland. And also we consider cities with inhabitants more than 100,000 people. So we had again something like 50 different receptors here. And include also special for the hydrological models, we prepare sequences that should lead to the highest deposition of the water reservoir, just to have the worst case. So just to show you some trajectories, it was here to Finland, to Netherlands, Germany, somewhere in Poland. So we see our Institute of Meteorology found such dates that almost straight line to the receptor. And this is a case, for example, of Netherlands, which is not a neighbor, but they ask us to do that. So we can see that there was almost direct straight line to the receptor. So okay, now I'm going to say a few words about the implementation of hydrological model chain. It was mostly done with delivery data, actually, but it was this team. Sergei is not here, but he is in Warsaw. Roman connected us yesterday. Mike is sitting here. Sasha Porotenko is fighting against Russian troops. This is the situation. I will show in a moment on the map. There is Radioactivity lakes and two tributaries, two rivers in flowing, and Radioactivity lake and outflow from Radioactivity lake to the sea. And there's a coastal region, and these models have been implemented. So it means that the whole hydrological model changed. So this the trace model for the watershed model, one-dimensional transport in the river, two-dimensional that was using for the lake. This is full dose model aquatic model, standard in Lodos, and Poseidon in order to estimate doses in marine environment. So this is the situation. This is the Radioactivity lake. The location of this was in the south part, somewhere here. So this is in yellow. Then we have this tributary from west and from the south, and outflow also going to the sea. So this implementation is within in the Lodos model chain. So we considered the whole path. It means starting from the atmospheric dispersion. There was calculation by Ritis for the watershed and the rifts, and causes because of this inland contamination, inland water contamination. Then passes to the sea. So again, there are some sea rifts. Poseidon, or the other one was through the coasters, also to have more detailed information. So this is just an example of some calculations. I'm not going to discuss all of them. This is still this is the implementation of the crosstalk, so it means that there is bathymetry that we prepared and the calculation degree here. Then you can see how is the movement of the contamination. It's the first day, the second day, fifth and 10th day. So you can see the movement is quite slow. So it in principle it takes 100 or 3 months to go to the sea from this place. This is the story. Again, some results. You can see that then you have in the south part, and because of this tributary here, which is not south, then you have additional contamination from the river. So it's south part and from the west part. Yeah. So, and implementation of the Poseidon model. For this, Roman used the memo-Nordic model for the Baltic Sea to calculate the flow. And there is a compartment model. We can see that this calculation, this grade, depends on the location. So it's closer to the place. The grid is more dense. So this is, we had some information from the voice, so we can compare the results of this model with the measurement data. And this is shown here. So you can see these red points are the measurement data, and this is flow in there's 2 contributors and north, south, and east-west components of the flow. So we see this is really good verification that the model works fine. And then, based on this, the Poseidon model was implemented. And again, some example results here. So, in total, the total number of Radioactivity calculation was, in this case, we calculated more than 2,000 cases for the large plus DMT. DMT is the model, basic model for the food dose calculations. So it's almost 1,000. Some special calculations for the radiological model chain that we selected this special meteorological conditions with higher deposition on the lake. And so you see the quite massive calculations. And there are some geological limitations. For example, we had to calculate the energy for fetus, which is not implemented in the others. Maybe the meeting will take when it will be. There was some discussion as far as I know about that. Then there is a question about calculation of absorbed doses. So we did outside of the others based on the ICRP documentation. For some integration times, we had to make some interpolations. Some of them were ready. Also, there are sometimes there were limitations in the number of material steps, so we need to use higher time step. This is because of this long-term calculations. Yeah. So for normal operation, Geodos was not very suitable, so we use another software, which is PCCream. Instead of, so, but in general opinion is that this Geodos can be successfully applied for this extensive calculations, not only in real emergency, but also for this more, let's say, statistical in principle calculations. Actual Geodos has built in some statistical calculation, but all this visualization of the data plus statistical all this information, we just extract the calculation values and we did it outside of the Geodos system. I think that's all. Yes. Thank you. So thank you for your attention. Any questions? All right.
Thank you. Very interesting to hear this experience of Poland in this field. And I have two questions for the beginning. The first one of your last conclusions, that Gerodos is not suitable for operation period. For normal operation period, yeah. Could you please explain this? And the second is about zones which you also calculated using Gerodos, and your zones which are established according to IAA recommendations. And what is about precautionary actions planning zone? What is the size of the zone and how it is seen within the Gerodos calculations?
Okay, concerning normal operations, the main point is that PCK is, okay, we used actually Gerodos to calculate, and then we compare the results with PCK. PCK is much easier to use because you can have statistics, meteorological statistics for the whole period, and within one round practically you can calculate everything. In case of Gerodos, I did such a way that we prepared the monthly release, and for each month we started the calculations and so on. So then next you must sum of these results, and you can, because of some limitations in the integration period, sometimes you cannot have the data for exactly the time you want to have. So there are a number of, you can do that, but this is additional way that you should do. Concerning this, the question of provocational zone, you know that we did exactly what our company did, the PEJ, this is Polish Polski Elektrownia Jądrowe, because previously it was PGE, Polish Energy Group, now it's changed the name. So we did what they wanted. So this part, information is not, it's not necessary for the licensing. It will be necessary in the later stage. So we of course, our calculations can be used because so many lot of data. It's rather not a question to make additional calculations, but rather to make processing according to the information you would like to have. So it's in principle, because of this mass calculations we can extract most information.
Sorry, for the moment you did not calculate according to these recommendations of IEA to understand what is the area within this zone. Because it is very important that in this zone you might make precautionary actions before the release.
That was the idea of having the auto system. That you can start countermeasures actually before the
preparation everywhere is before.
Yeah.
But for example, distribution of iodine pills. This is in case of possible emergency.
Yes. Not it's, you are right, absolutely.
Any more
I have a
questions?
question. What now in the States, situation now with the Polish nuclear power plant, because it was two locations, assessment.
One location was selected, but there is no official selection of the technology.
Okay, it's kind of the reactor, yeah?
Which kind of reactor? Okay, I can tell you, we made these calculations for Westinghouse, AP1000. This is because this company has signed some documents with Westinghouse. But this is not officially selected because when this situation with gas in oil, which is now in the world, our government got two additional offers, one from France and the other from Korea. So the situation is not it's not clear still.
But location is
already selected.
But maybe after you select the technology, you should.
We should again make more detailed calculations.
Yeah, and maybe also
we
have to get permissions from neighboring countries.
Thank you very much. A comment about this. About the next presentation.
Okay.
Thank you. Alex, would you try to conduct very expedition? But now for 30 in the morning California, San Francisco, Berkeley. Please write message to him. I have included, unfortunately, when we plan a program, due to the time change, the time zone, we didn't take in mind what is the real time in California. Oh, very clear. Oh, great. Very say something.
Yeah. So can I give you a presentation?
No, we see only you. You should share your screen.
I will share the screen. Do you see the screen now?
No.
Not yet.
Not yet. Oh, now some second. Great. You will see it. Please put in the demonstration mode. It will be better to see.
Yeah.
If it's possible.
Oh, about now?
Yes. Great. Everything okay. Please start.
Please go ahead.
So you see my screen?
Yes.
Okay. So thank you to the organizing committee for your kind invitation to give a presentation at this seminar. And I'll be talking about the assessment of soil and groundwater at your host of vulnerability. And this is work in progress conducted by scientists of Lawrence Berkeley National Laboratory with the help Lawrence Berkeley and Lawrence Livermore National Laboratory with the help of Ukrainian scientists. I will start with the definitions and the illustration of generic or drastic approach broadly used for the evaluation of the groundwater vulnerability. We'll discuss the main modes of the groundwater radioactive contamination at Chernobyl as a case study which I used as an analog for the development of the GIS and modeling-based drastic modified approach. This approach was tested for the area in the vicinity of the Zaporizhzhia nuclear power plant. And I will finish with a few challenges and lingering questions. Groundwater vulnerability is the term used to define how easy or how hard it is for contaminant released at the lead surface to reach groundwater. In other words, it defines a degree of insulation or an aquifer from pollution. It is obvious to state that all groundwater systems are vulnerable, and uncertainty is inherent to all vulnerability assessments. The current drastic stance for the following 7 parameters used for the evaluation of the groundwater vulnerability depths to the water table, groundwater recharge, aquifer and soil medium, topography, impact of the variable zone, and hydraulic conductivity. Drastic indexes are roughly analogous to the likelihood that contaminants released in the region will reach groundwater. Each parameter assigned a weight and a relative weight, and the sum of the multiplication is used to determine the degree of vulnerability. This method was first proposed back in the 1960s and was broadly used since then. One of the main disadvantages of the generic plastic approach to that is that it does not take into account the absorption-desorption processes affecting the reactive transport processes of radionuclides. And here the graphs of the relative value of the parameters of the generic plastic model. For example, when the depth of the water table increases, its relative value decreases. When the groundwater recharge or hydraulic conductivity increases, the vulnerability decreases. In the generic plastic model, when the land surface flow decreases, the vulnerability increases. However, this relationship is controversial and subject to further investigation. And here, flow is a formula used to calculate the intrinsic aquifer vulnerability. Since the introduction of the plastic model, there are multiple modifications of this approach, including the applications of the statistical models, process-based simulation models, and index-based models. However, to the best of our knowledge, there are no modifications to the generic plastic model for the assessment of the ecological groundwater vulnerability using field analog studies and modern GIS and modern techniques. Now I will talk about the Chernobyl case study using the information relevant to the evaluation of groundwater vulnerability. Since the 1986 Chernobyl accident, Chernobyl has become a unique experiment in international collaboration. I would like to present some results of the Chernobyl studies to be used as analogs and serve as baseline for the introduction of drastic modified approach. Generally, there are two types of groundwater contamination: point source subsurface contamination and area distributed contamination to the land surface. Airborne radionuclide materials, they deposit mostly on open land surfaces, and here is an example of a well-known map of seasonal contamination within the Chernobyl exclusion zone. And leakage of radioactive materials at the Chernobyl nuclear power plant industrial site caused radioactive contamination of groundwater. Radionuclides that were directly deposited at the nuclear power plant site migrated into the shallow unconfined aquifer in the environmental sand. On the left, you can see a map of the strontium concentration, with concentration over 500 per liter, and on the right is a map of the ratio of uranium-234 to uranium-238 activities. When this ratio is more than 1.1, it indicates a downward migration of the uranium released from the nuclear power plant. And the nuclear power plant, in this case, can be a point source of groundwater contamination. Another important factor is the point source is a low-end temporal distributed source of contamination. You can see that the storage of contamination in the groundwater, so ground increases with time, and at the same time the groundwater pH increased to about 11 or 12. It can be hypothesized that the addition of hydration products of cements caused an increase in groundwater pH, which in turn caused the desorption of strontium from the strongly alkaline mineral deposits. However, if anybody has a different view of how to explain this phenomena, I will be happy to discuss. Here are published results of two-dimensional modeling of strontium and concentration in groundwater originating from the nuclear power plant industrial sites, indicating that the groundwater flow is expected to remain within the Chernobyl exclusion zone and will not reach the treated river. On the top are predictions for conditions based on the constructions of a usage confinement of sarcophagus, and below are predictions taking into account the new metal sarcophagus. However, these predictions are possible that the checks of contaminated groundwater was not taken into account. So, how contaminants distributed with depths to the land surface. Once deposited on the land surface, contaminants have penetrated into the subsurface. The plots of the concentration with depths show that the majority of radionuclides were accumulated in the top approximately 5 centimeter topsoil layer. The depth of radionuclide migration depends on the sorption of radionuclides by solid particles. For example, strontium moved further downward because of lower sorption by solid particles. Another phenomenon shown on this plot is the effect of differential flow when the radionuclides appear in a deeper layer at higher concentration in the borehole compared to the layer above. Then surface depressions may cause fast flow and transfer to the radial zone of groundwater. Long-term depressions can be seen from aerial photographs taken from Google. You can see dark spots which are in fact ground surface depressions. Chernobyl exclusion zone depressions may capture up to 60 to 80% of surface runoff. And this slide illustrates the phenomenon of accelerated migration of radionuclides on the surface of groundwater used to water propagated depressions. The terrain map of S0 of the watershed at one of the sites within the Chernobyl exclusion zone shows that the surface runoff is directed from the top to bottom of depressions, causing an accelerated migration of radionuclides within the depressions. Surface runoff is funneling into the depressions. The cross section on the right shows that infiltration is greater at the center of the depression, causing deeper penetration and increase in concentration of radionuclides at the center of the depression, shown by red lines for strontium and cesium. Accelerated radionuclide migration could reduce the presence of weak subsurface sediments below the surface and depressions. And the application of geophysical methods such as groundwater penetration data and isotopic methods are needed to identify this zone. One of the methods to identify such zones would be the application of the linear analysis of the surface topography. Here's a map of groundwater vulnerability of the key region, showing the area with the most key of the very high water vulnerability, which responds to the low protectability of groundwater. The groundwater level in the vicinity of the Chernobyl nuclear power plant is shallow, which is one of the main factors causing the high plastic index. The water level drops in the directions of the south of to the south of the field, the vulnerability drops too. So, in summary of the Chernobyl analog study, radioactive contamination of groundwater is caused by both point source migration from the groundwater flow and aerial distributed migration from the land surface along the preferential flow zone. The distribution of contaminants from the land surface depends on the types of land use and the distribution of local surface depressions in deep near-surface sediments. These areas can cause rapid penetration of radionuclides from water table. To improve the accuracy of predictions of vulnerability, we need to apply modern GIS methods to analyze the regional elevation maps and radioactive transport modeling, taking into account variable sorption desorption parameters. And furthermore, the new methods which takes into account these processes as a drastic approach where one L stands for linear, another L for length, and K for KT parameters of distribution. So now about the broader concept for history of the GIS and modern embracing the plastic approach using the data from the region of the power plant area. So as a first priority in our study, we started with the area of 200 by 200 kilometers with the center of the region of the power plant. And here is the soil map of this area showing the presence of relatively small or middle channel zone, so that drainage soils and salts within the area of low humus and weakly humus channel zones. These small areas so that drainage soils can serve a zone of accumulation of radionuclides. But an additional digital elevation analysis is needed to determine whether this zone would serve a zone of fast migration of radionuclides or zones of long-term accumulation of radionuclides. Next, what adapted geological hydrogeological analysis of the territory based on the five hydrogeological map of the Peripheral area. This map includes hydrogeologic perceptions from the south to north and west to east, which are shown on the next plot. These perceptions includes 17 wells, and then these 17 wells are shown by red symbols on the GIS based upon the map, which will then be used to assign the given parameters for each well locations. For this, we also created a database of ecological points, including the types of sediments, depths to the unconfined water table, isometric head of the artesian confined aquifer field of the solids and geochemical composition of groundwater. Using this data, we calculated the drastic parameter and assessed the degree of vulnerability, which are shown in this slide in the table. The degree of vulnerability is low for one well and medium for the rest. However, we have not yet included the evaluation of the effect of zones based on the analysis and the effect of land use. Now, I would like to address some results of the analysis of digital elevation maps. First, here is a Google space great image which shows several rows of buildings. So this analysis was conducted by First, so look how these buildings look like the digital elevation map. You can see here this dark color rows for the two-dimensional and three-dimensional presentation of digital elevation maps. So the rows of the buildings on previous slide. And on the right, the corresponding denoised maps. Now, the geometric analysis of those maps was conducted on the accumulation of zones, slopes, and flow streamlines. And to plot the erosion deposition map. This map, along with the clay content map and sand content can be used to help and identify zones with the potential accumulation of radial lights. Now, the newest map consists of the aerial distribution of horizontal and vertical surfaces of the surface, which were then used to calculate and plot the map of integrated curvature. And on this map, you can see in yellow color some zone which can be called cut spots, in which we can expect accumulation of radial lights. But whether we will be transported to what transported past the water or accumulated in the surface zone, it will depend on the land use and the area analysis of these locations. The last portion of the presentation is on reactive transport modeling. The overall goal of reactive transport modeling is to advance the drastic approach that includes the absorption parameters of radial lights into the vulnerability assessment. We conducted proof of concept modeling using two types of models. Hydro's lumping modeling to assess the water travel time and contaminant transport based on the empirical coefficients of KT and radioactive decay. And P-Plotron model which allows one to take into account sorption-desorption processes and based on the geochemical composition of porous solution and the logical composition of sediments. Pink bottom is an open source and state-of-the-art masonry department for subsurface flowing reactive transport pole. This slopes system of generally non-linear partial differential equations described in a multi-phase, multi-component, and multi-scale reactive flow and transport in porous region. Here are some examples provided here simulation of storage energy transfer for two wells which are previously shown with different stratigraphy. Here is mostly low, and here in this case mostly sand. Seasonal variations of the rainfall were model, but the transformation was not taken into account. We assume that these are washed-out conditions that correspond to zone of fast preference of flow and transport of radiant flights. You can see the concentration are given here in moles per liter for 25, 50, and 100 years as examples. And on the next plot, our examples producing items one deep simulate the electrical distribution of sponsorship, taking into account KD and sponsorship between two pictures. This is the chain, between the chain sponsor and simulation show penetration of sponsor to 3-meter depths for 50 years and meter concentrations 2 orders less. Approximately the same depths distribution of sponsor is obtained using direct time. First, results of items 1 model and season 147 display different depths of season propagation depending on the taking of the KD parameters, showing once again the need to include these parameters in the evaluations of the vulnerability index. And finally, a summary of some challenges and questions. The assessment of the GIS and model guided evaluation of soil and vulnerability requires knowledge of geology and geology, soil media, the whole picture chemistry, but often non-reliable data are available. And with the help of integrated scientists will be able to continue this work. So global analysis showed the need to modify the generic cluster approach, in particular to get the surface readiness and improve analysis and the retardation for trading advice. And this new approach was tested using data from the super user area and helped to identify multiple challenging problems. So here is challenging problems, but I exceeded the time, so I'll skip these slides. So the work was partially supported by the laboratory Radioactivity development programs for Lawrence Berkeley and Lawrence Livermore there. Thank you so much for your attention.
Thank you very much for the very interesting presentation. Do we have any questions before we go to lunch? Oh, one question, Professor Alter.
Okay, maybe I need to go.
Yeah, please go to the closer to the microphone.
Hello. So I have a question. So you mentioned that transport, over and flow transport looks very important for your analysis. But as long as we measured in Chernobyl, the over and flow is very, very there. So what kind of infiltration parameter do you use in your model?
I don't hear very well.
Okay. So very good.
If you can repeat your question.
Oh, okay. So, so you emphasize the importance of landform to transport the radionuclide in Chernobyl, but as long as we measured in plot studies, the overland flow is very, very rare. So what kind of infiltration parameter do you use for your model?
Here for the infiltration model, we used conventional parameters for simulations of infiltration for the radial zone. I applied the precipitation. We don't have direct data from the meteorological stations, and I downloaded data from the NOAA database for 20 years, and then this data were repeated for 100 years. Other parameters were used for UNSODA database, parameters of unsaturated soils from the UNSODA database.
Yeah, I think saturated flow is not important for radial transport organ flow. So anyway, I'd like to discuss if you send some material to me, and so we have updated data, so we can discuss more in detail. Infield data.
Right.
Okay.
Thank you very much. Any more questions? Okay, well, if we don't have any more questions, so we'll thank again Boris, and we'll finish this session. Thank you very much, Boris.
Okay, so we now a little bit had the program, but interesting. We have 40 minutes for lunch, then we have pretty large session, and then we have some discussion. I will have received several proposals about the topic of discussion. Thanks to James Smith and Clive Williamson. And if somebody has some else idea, please send me emails. So let me meet at 2:40. Okay? 2:40. Я-то его помню еще 70-е годы, где-то геологию, потом он исчез, Я же не могу ему сказать. So that's why our suggestion is
show that when you're all back in Ukraine, following organizes a joint meeting.
Oleg just called me yesterday asking we to have a preliminary meeting.
We didn't make a preliminary meeting.
Вони будуть виконувати свої рекомендації, що буде можливість автоматично запису спектрів заданий інтервал часу на внутрішній Ні, ну так не треба. В ньому изначально было установлено 3 процента. А нам надо таке. Нам не надо нейтроны, а там сентилятор.
Вони його використовують спектр
Акушер. Мені саме головне, що вони писали, що вони нам рахували.
Вони потужність дози перераховують із спектра, так?
Так.
Мені треба тільки імпульсом. Ми все одно будемо його калібрувати.
Типа ідентифікатор.
Ми хочемо його розуміти.
технології, так, все одно, якщо він використовується і експлуатується для землі, так технології, яким чином дивиться розвиток, вони розуміються.
Мені досить не
Спереду врахування фоновий спектр, потім бере загальний спектр, і фактично не сесія бере весь робочий діапазон, який вона, і говорить про доступ, а потім доступ. Там немає цього дорослого. А просто листати, то листки не листати. Ще треба уточнити, тому що ми більше знаємо за ви знаєте складені знають. Власне, є мене. Так, ну, одна проблема, що я весь час буваю Староцькою сьогодні, що ви працюєте як математик. Ваші природи математики не вдаються, і от так як рахують, ви кажете, дозу, вони отак рахують і ідентифікують спектр. Дуже погана ситуація з визначенням і з статистиці. Статистичні відхилення з достовірністю, достовірність визначають невизначеність, точно. Як Блендінково, є цезія. Цезія, це цезій. Це цезій, є два варіанти. Або це цезія, або не цезія. А варіант, що якби де ні, вірогідність того, що це цезія, або ноль, або стояння. Менше не буває. І посередниці не буває. А у когось там, два прикладати співпадають, 50% історії, що цезія один, вони визначають якусь відповідь, а у когось не два. А вірогідність це відношення надфозу цього визначення, цього піка, воно визначається по якимсь технічним, я не знаю, це я знаю, як це визначається. У термофішера, як це визначається, це працює технічно. У атомному теорії, коли ми взяли спектр, ми вивели воду, ми взяли цезій, потім білковик, потім ми взяли європи, перемоги. Європі разом з Ковальськом, Стецею, там у Європі така кількість піків, що народ бере по вісі, і він рішає фіскальні переходи. Ну, враховуючи для кристалами не вирішити таке, але з ним можна щось робити. І просто перевчитися, що минулого року, а зараз ви вже почалися міжнародних прогресів. Зараз Паризьку готуються ці спектри, проводяться для докрутення. Якщо докрутить, то взагалі Івановичі і Рашова.
Ну, це взагалі цікаво, дуже страшенно. Я хотів, у мене гамма-спектрометрія, це моя спеціальність була, я підлогу робив по гамма-спектрометрії.
Я робив на спектрометрії, я
на кафедрі експериментальної
вже серце, вже за 20 років, я вчора почав згадувати, що ми сиділи на дівчатку, Волочарку, щось там не вчити, я в школі викладав, Хорошо, я вже все забув. Я тільки пам'ятаю, що студентам, ученикам можна лінійкою просто. Зараз нельзя.
Ні, діти нельзя.
Добре. Дякую.
Щодо вашого питання, заболотнення цього проблемища. Які казати? Будете питання? Будете казати, що не фактор заболотнення. Водою. Таке, нерадіційно. Це моє питання, тому що скільки відзвості я не бачив якоїсь розвинутої аналізу заболотно-хімічного, тому що знаю, вирізу. Мені те, що розповідали, що багато використовували цих і
реагентів безопераційних, все інше. По-друге, скільки я пам'ятаю, коли я там працював, що вони весь час намагалися пробити так званий нередакційний. Складати хоч якісь проби на якусь хімію, що не там. Це теж якось вони не пішло. Я раніше працював в інституті геробіології, на водоймі охолоджувачі, відбирав проби із 77 років. Інститут геробіології до аварії проводив дуже детальні дослідження водойми охолоджувача. В тому числі там працювали психологи. Ці світи десь є в архівах Інституту геробіології. Що я точно можу сказати, що кілька разів за час роботи станції до аварії були аварійні скиди масла у водоймі охолоджувача. Якраз ця територія, де вона показала, що на станції було розставляли. Це якраз ця територія найбільше постраждала від цих скидів. Причому, що таке скид аварійний скид масла? У водойму потрапило один раз, по-моєму, 20 тонн масла, другий раз 60 тонн масла. Значить, це розвалилися підшипники турбіни, і вони там крутяться маси, так? А зверху повітряна оболонка, водяна оболонка, яка їх охолоджує. І вони розвалилися, і все це масло попало в цю воду, і вся вода відбувається. Воно треба розтинутися. От ми вже після аварії, коли працювали на водоймі охолоджувачі, це останні мої експедиційні роботи, там були, це 2004 рік. Ми ловили там рибу, ми відбирали термометр, ми ходили в чоботах, ходили там по воді, в береговій зоні, ну отак, так? І йдеш, там на дні розвивався фітоперифітон, знаєте, ну, так? Килим такий, і от ти піднімаєш на цей фітоперифітон, і звідти знизу піднімаються плями масла. Ну так, це проблема, і я просто не бачив, воно йде постійно. Вимірення на одну путів.
А от там, де вони живуть, да, пробок дивитися, так зараз просто в цих пробок подивитися, що там ще є, яка там ще є. І, крім того, ще один такий був, це можливо на гризуні. Масло, я думаю, на гризуні точно було. А от там ще були скиди. На Чорнобильській станції, як і скрізь, в принципі, на інших станціях, завжди були проблеми із якістю води і з кількістю зависів води. На Чорнобильському водоймі охолоджувачі, на Чорнобильському водоймищі охолоджувачі до аварії, в принципі, був досить інтенсивний розвиток фітопланктону і величезна кількість систем там висіла прямо в воді. Ну, величезна кількість, це мається на увазі десь порядка 25 мг, 30 мг. Ну, це достатньо багато. Так от, секундочку. А потім після аварії, коли біологи тут перестали робити, що вони зробили, не знаю. Але вода раптово просвітліла. Видимість у воді в водоймі охолоджувачі стала
метрів 8, а до цього по 200 септів це було десь максимум 1,5 метра. От. От працює, тому що була затруха, не затруха, хімічна. Отруєння ужа одного разу. Це я знаю. Друге, це коли це влітку було при дуже високій температурі. Скидання з заводу. Але реально це було влітку, що я пам'ятаю, там виборся, лежала відомо на деревах. А друге, це вже десь кінець жовтня. Ніхто не чує. Прямо нафтопродукти придбала з МПЗ. Ну, так. І ми її 2 тижні супроводжували в зону. Це так. Я десь читав в якійсь літературі, що на якихось інших станціях для того, щоб пригнічувати розвиток фітопланктону, використовували щось мовомірну поросу. Розкидали в воду, і це ж насправді ці всі екологічні служби, вони були і у нас, були в Росії, були в Радянському Союзі. Вони старалися це все контролювати. Через те скидали це все не афішуючи, а потім дослідники, відбираючи кромки і аналізуючи кромки ґрунтів, відходів по тонким шарам, визначили, що в якомусь шарі там була дуже висока концентрація. Ні, що робити, навіть, там як. Ідея була в тому, що знайти точки, де працював Сонячний центр в 9-10 році. Вони перед тим, як водою спускати, їм лабораторію проєкту як вуглевої зйомки. Вони чогось там не було. Вони багато що робили. Станція? Сонячний центр вже працює за іноземцями. Вуглева зйомка, це взагалі така речі, це може непонятно. Не знаю, як вони там виходили. Вони там щось точно словили, що подібне розуміти, я не пам'ятаю, що такі, такі. Надали білу. Нежиттєво помітили. Ми до автобус загнали з спектрометром. Ідея була, коли там кінець кінцем соцтреку, кажуть, давайте там дорогу. Ми приїжджаємо, коли десь на початку жовтня. Ходимо по тим точкам, там все змінилося. Вода впала, воно там просохло, і тут не буде коректно. Сидимо, що робити. Просто виїхали там, в розводні. Так вже з'явилися там нові фітоценози. Давайте їх будемо розпізати. Тобто, давайте. Ідея була в тому, що розуміємо, там загалом хтось живе на тому груді. Не в тому, що більше факти. Ми розставили пастки на цих 9 точках, прикинули, куди з одного боку машина заїжджає, з іншого якась там диференціація. Я був здивований, коли там десь через першу групу прийшли, почали щось виловувати. Тому так сказав, що ти випадково. Там були якісь ком'юніті. Але воно було там дуже таке там. Навіть влітку його самі вони розрізнялися. А от потім за останні декілька років вони почали стабілізуватися, там дійсно цікаво, тому що я вам розкажу, що першого ще до Рошек, коли ми почали там з Володимиром так аматорськи приїжджати, ми побачили, що невідомо, коли так десь критично змінилися на поверхні. Це навіть було в якомусь американському учебнику екології, що викладався на радянській частині. Що там десь показувало, що там кінець водопілля, начебто там, що площа зменшується водного озера, але доступність риби і кількість риби для птахів взагалі, що зростає. Тут аналогічна ситуація, яку ми приїжджаємо і бачимо, що птахів кожен місяць, птахи, вовки, лиси. Тобто для них це стає, тобто вони підходять до цієї берегової лінії, особливо там, коли швидко вона. Тобто вона просто відходила і вони просто забиралися цих черепашок. Двічі, коли ми їздили перевіряти, коли ці поступили на машину, ми зустрічали вовків. Ну так, фейс-то-фейс, дистанція там 50 метрів. А вони цікаві, так? В зоні агресивного, де потім не зустрічали. Ось, і це був такий двір. Потім почало зростання, і водойма стала приваблива для відвідувачів птахів. Алло? Да. Значить, тобто, щоб аналізувати кількість відвідувачів птахів, треба було приїжджати на воду. Щоб вона була захоплена, вона була не цікава.
Ні, там теж
ну, так. Дуже були такі не дуже класні захисні умови. Велике водне зеркало це не так цікаво, як ця система вебу. І я пам'ятаю, великі 2 тому ми стоїмо і там бачимо 5 чорних ворог разом. Те ж саме вже регулярно, десь у вересні місяці ми бачимо скопу. Останній парадокс, у нас орнітолог, він там ще двічі знаходив філіна в зоні. Ввечері. Ось, і в нього там ідея була, хіба там, треба виявити ввечері. Період, як кажуть, розмноження, коли він там локалізує, він шарився, там, спокійно, не буде. І потім йому дзвонять, кажуть, що знайшли мертвий пташок. В общем, Пугач зробив гніздо в цій гордині. От там на верхніх цих, на верхній стіні, ну там було закінчилось рік тому, трагічно, коли там пташеня випала. Ну, завдяки те, що ми знайшли. Але і в цей рік ми прийшли, ну, тобто самого Пугача ми не побачили, хоча той рік фотографували, а виходимо на цей рік, ну, і є Пугача, і його вже. Його присутність, значить, ну так, такий парадокс. Багато молодих еліт, але половина вибирає собі це. Ну, так, скоріше. Я кажу, що я сам тиждень вибрав, їздив, вночі туди-сюди.
Тут дуже цікаво було, тим більше, якщо, ну, там, не знаю, зараз у вас доступ скрізь є, так? У всякому разі на водоймі не ходить.
Ну, на тому більше, військова особа не рятують.
От загальний підхід у фітоцинології, і, до речі, не тільки фітоцинології, це і зоолог, точно каже. Ви Протасова знаєте? Хто ж його не знає? От Протасов, я вважаю, в інституті гідробіолога, він як еколог, не зоолог, а саме еколог, він, мабуть, самий підключений. І ми, коли з ним працювали на водоймі охолоджувачі, ще до Баварії, він, по-перше, вони туди завозили спорядження акрологічне, і вони працювали і вивчали зооперифікон із цим спорядженням. Так от вони робили трансепти. Вони робили трансепти, прокладали трансепти, і вони вздовж цих трансепт регулярно там, в певні періоди проводили зйомки і збирали на тих окремих місцях в одних і тих же, відбирали проби і дивилися, як там протягом сезону і протягом кількох років, як міняється динаміка цих зооносів. І от зараз відбуваються сукцесії, коли осушили на водоймі охолоджувачі. От закласти такі трансепти на водоймище охолоджувачі, щоб
фітоцинологи там попрацювали і подивилися, яким чином, що там відбувається, для того, щоб відслідкувати реально послідовність, тому що ми всі бачимо, що міняється. Так? Тож там вже якісь зони відчуження наслідки російської окупації. Всі багато розповідають, так? Але нічого не документують. А тут би потрібно було теж із цими концептами, щоб хтось цим зайнявся і все документували, яким чином це відбувається.
Було цікаво. Коли привезли академіка Дідука, не зрозуміло, за які академіки сказали. Тобто вони працювали, як всі, 6-10 але потім це Погано залишив на всі ці свої точки, тому що його економічний прогноз не виконався.
А прогноз про що?
Економічний прогноз розвитку. Ну тоді ще. Наприкінці свят тоді подарунок. В общем, суть в чому? Тут спочатку опублікувалося. Вони опублікували на англійському статтю якраз саме ідея, що інспектор, то що прогнозно, що спостерігається. Очікування і фактично.
Окей, але прогнози оперативні про що? Аварії, що нас? Так, після аварії.
Коли аварії, ви ж себе людей, коли
Вони було куча концертів, всього, тобто вони такі, по системі.
Йому привезли його команду, він так походив, так класно, що він признав свою роботу справу.
Все по-іншому.
Не викладався, але я не знав, це класно, і давайте там починати знову.
Той час йдемо до тому, що може треба підходити з різних. Якщо сам питання, що організує, що є загіння, диспутацію лісника, як воно розбивається. Вони наскільки пам'ятають, навколись. Люди, що перекладено, писалося, що основною місцеві підходити, замінятися поезією, щось такого.
Ну так, вони такі радикальні були.
Ну зараз воно буде навкруги. Це ж не пов'язано з тим, що люди пішли, а пов'язано з тим, що сухіше стало.
Смотри, я сейчас, по цифрам вообще не готов обсуждать. Я этим вопросом не занимаюсь. Саша там занимается. Кто будет трясет все вопросы, для нам расклад, тогда будет конечно. Я цикл не надо. Я працював, понятно, на академии, а працювали його учні. Я кажу, все класно, да. Ми там за білі там 5000 кілометрів працював по
Посмотрим, опять же, непонятно, сколько там, сколько
ничего. Сейчас Саша команда. Это вообще Маха класс индикатором проектов. Исключает разговор. И вони теж кажуть, там 94-го останній тема вона закінчилась і все. Я просто цих людей якось через животство за що витягнути, воно не хоче касти. Я кажу, так. Для них. І вони теж приходили, дивилися на ці переговори. У нас навіть не роботознавці, ми дивилися, кажуть, знаєте, роботознавці відділи. І показують, що досить швидко дивлюся. Ну, на переговор там щось виходило. Так, досить розуміється таке, політики стану.
У Джима були дуже цікаві ідеї стосовно відродження комах, розвитку комах на зараз.
Did you receive answer from Isan? Here is a copy of the views from the
They don't receive.
So you already received the source? You did not already receive the source?
Yes.
І комах є, що тут ще набрали кілька звинтів, набрати на цю балу вагальну.
місто граничного речовини. Так, тому що ми звернулися з тим, що після пожежі буде циркуляція. Воно ніколи не розродиться, треба там заганяти якісь там суперхарвестер, щоб він саджав квадратних різнових засобів.
We try to reach this numbers because later what we noticed we have some kind of a formal present. It's from the database of our non-database of our university. So it's for your institute, it's just it's the example of our university in Cyprus. And this personal present for me. But the meet here, the whole picture, you have activity of the whole of my site. Suppose it's spring, make the next steps.
Я думаю, що щось перемішали, там були такі електросистеми, дуже активні корпорації. Ну, відповідно, точно захисника там є. Що ви чекали?
But also, we will also another you see the presentation of Czech but this is problem. Now it's the same. I just present to please explain to what it is said.
The official
Red cow is a symbol of our practice.
Поступово я розумію, що не це робить. Кожен скаже, що це ніяк,
He presented technology of this year. And then we organized the post of black guys, straight and this program is problem is Americans who would move to Chernobyl. So yesterday was Russia. If Americans come here, and Ukrainians would come. Maybe it's also to be able to from this and even if some solstice our example illustrates possible Ukrainians come here from Poland, Americans go here, and
кілька місяців, якщо цікавить місяць Чорнобиль,
it's about the idea that you will come to the best time of maybe somewhere in April.
Він буде до 16
It's a long winter, snow in Fukushima up to the mid of March.
Okay, so it's not from this. Last winter, прийшов час розчищати дороги до Божої. І в тому числі і виробити Холодно всі документи, потрібно було взяти дозвіл на природу на ці речі. І він природу, і не дав дозвіл, кілька років.
Yeah, because the cover was
Yes. Some part of the lake was open to nice.
Днем ехать полчаса, там один трамвай, а в Варшаве есть бюро. Каждый день офис транспортных центров. Вот напротив квартала слева, я имею в виду
Где ты не был ночевать?
просто я раздумывал, где билет в одну сторону, и надо все делать. Я здесь приехал, что одноразовые если вы в городе, вы есть кресло сразу я полечу, что как бы все. Leaving, yes, I was quick.
I think we have given chance
As Wolfgang does.
Yes.
No, but we have new laws now, so
Yes.
you can speak on the other day.
Good idea.
Now zero about situation you continue after 1st of January in some way.
In some way, yes.
In some way.
For one more year. At least now we know that plus 1 year.
So
maybe we can give results.
but it's at university or as contract? Maybe as contract.
You don't know.
I don't know. He has access to us. He's allowed to enter the center. He works officially, I don't know, 2 hours or 3 hours a week.
A week?
Okay. Alright. So because he is,
So he's arranging quarters with his wife and
we are glad that he is with us at all.
yeah, that's fine. It's not the usual setup. So if you are on the leaf, then you are on the leaf.
Yeah, but what's the now in Poland? Because German system is very strict.
Not so much. Not so much. But I can go on Italian tomorrow if I want. Yes, but you could. But if but nobody can force me to do.
Some kind of the age harassment.
But if I decide to do that, I can still wait, but for maximum 33 months. So it's almost 3 years. So this is the basic. So, but as I'm involved in so many different projects, they want me to keep me as long as possible. You want to keep working, and you cannot. It's forced to be.
But first I remember the Claudia, she worked several years as a another company.
Last year, and then another. Yeah, probably it will be the same setup. I don't know. But you of course, it's also that, but
it was his use.
His.
As I know, at the moment when he retired, it was under his executive. I know some rumors. At this moment was not very good atmosphere as a team, and he was happy that he could close the door and never returned.
Okay.
So, what's it?
Yes, okay, so yeah. What time is your taxi? I'm leaving now.
Right?
I'm leaving, I'm trying to get you a question start.
Oh, good. Oh,
Yes, nice to meet you. Relax. Nice to experience from.
I hope to see you again there. I very
She's also retired since already 5 years. So I need her from time to time, privately.
Please get like this speaker.
Thank you. Прощаемся до Радаша.
そうだ、私、発表なんだ。発表します。30枚のスライドを15分で発表します。と思うね。でも、まあ、これは、同窓会ですかそうか、そうなんですかね。I don't have a share from you will join. Yes,
and this is local administration. And formally they are responsible for looking at the population. This is massive which obliged local administration to do this. They are obliged, this already is the law. The formal they are obliged for all the lifetime of industrialization that's on the left. If this is here, there is no federal. But all these plans concerning evacuation, etc., should be prepared by this local government. But what the politicians should say, which are leadership. This is so it's kind of support. And
This is quite early stage of this process. So we are in the very beginning. Really, it should be implemented, really implemented, not only just assessments, but really implemented after you will make the choice according to technology. Yes, exactly. But anyway, we could have some, let's say, estimations of the news transportation. I don't care who assure that this number of buses will be available or not. I can say, if you have 100 buses, then we can if you have less, then it will be that's all. This is the choice. As you Okay, dear colleagues, I invite you to the final session. So, our session is shortage because according to agenda, we plan to have 4 presentations. But one of the presentations is from the member of Australian Parliament. You know that continue to be not very good news on Ukraine about the situation yesterday was the decision of now Radioactivity, decision of Putin to prioritize the Zaporizhzhia nuclear power plant. So it looks very strange because according to this decision, power plant will be operated by Rosatom.
It will go from microphone.
The situation is that nuclear power plant, this is hot stove, cold stove, not working, but now we say that nuclear power plant is going to Rosatom. From other side, all nuclear power plants are working with the license
that they received from national enthusiast. It means in our case it's Ukrainian inspectorate. But they say that Rosatom will take the nuclear power plant, but it will in accordance with the Ukrainian law. And of course, now next step from Ukrainian side, they ask about the assumption, international assumption of aside Rosatom that stolen nuclear power plant from Ukraine. And therefore also all this activity needs legislative background from Ukrainian side. And therefore our parliament members then prohibited to leave country yesterday and today. Therefore yesterday was a presentation of parliament member Ruchina, and yesterday today we have planned that we have presentation from the also parliament member who is head of the National Radiation Protection Commission, Mr. Kaparino. But he could not come, very busy, he could not participate in that. Therefore, in this session, instead of 3 presentations, we have 4 presentations. We will have only 3 presentation for the group of people including Namasansei, we have a presentation recent Chancellor of Kapalenka, then presentation of Jim Smith, and then presentation of Kashpar. So it will be these 3 presentations. And we are planning to finish the initial plan after we have discussion and time for the informal discussion, so we will be very strict. So please, Namaste.
Yes, okay. Thank you for the introduction. I will present a quick overview of the issue of evacuation order and lift of evacuation order in Fukushima. And then I will have additional comments or some explanation from Oleg, and maybe Tatiana is not here.
She will come.
Okay. Yeah, I hope our experience in Fukushima about the evacuation, the lift of evacuation, will be helpful for your place in Ukraine, where the discussion is going on about the lift of evacuation or lift of relocation. I can skip this, but of course the first week evacuation order was issued according to the distance from Fukushima Daiichi and the Fukushima Daiichi nuclear power plant. But after the position was clear, not very clear, but the position was confirmed as far as Itate village. The evacuation order was extended to this area, and in addition to this, in addition to this red area is 20 kilometers radius from Fukushima Daiichi nuclear power plant, and between 20 and 30 it's evacuation prepared areas in case of emergencies, and this is a planned or deliberate evacuation zone. And this preparation area is cancelled in the autumn of 2011. And then in the winter, in the December of 2011, national government issued their new plan to make a new evacuation arrangement according to the dose rate of the areas. And this is how they arranged. The highest dose is above 50 millisievert will be difficult to return zone. And between 20 and 50, it's a restricted residence area. below or close to 20 millisievert, it's evacuation order cancellation preparation area. And you may sometimes mention to Fukushima evacuated area in Fukushima, like a Fukushima exclusion zone, but this term is not well defined. So these terms are well defined. And this the arrangement of the areas went on for each municipality. So started in April 2012 and lasted until 2013 summer, and then almost simultaneous. This is a completion of new zoning, but then lift of evacuation order. This green and yellow. So lift of evacuation in preparation zone and residence restricted zone. The lift of evacuation order started. And this is the former population of each area. In total, evacuation order was issued for 84,000 population. For difficult to return zone, it's about 24,000 population. This is the maximum area where evacuation order was issued. And the lift of evacuation order started from 2014 April. It took place like for each municipalities and lasted like until 2020 March, where evacuation order partly issued, lifted for Futaba camp. So now the areas where evacuation order is issued looks almost like this, but slightly different now. I will explain later. And this is these are criteria for lifting the evacuation order. Of course, one is dose rate. Dose rate, it's a matter of argument, but 20 millisievert is the criteria of dose rate. And of course, the basic infrastructures should be recovered. And the third one, I think this third criterion is very important. So enough discussions are made with the prefecture and the municipal governments and the residents. And during this discussion, this 20 millisievert is a matter of argument, and the residents will not accept this 20 millisievert criterion. But United Nations Human Rights claimed that, urged that Japanese government to halt the ongoing relocation of evacuees there. So the United Nations Human Rights told that the 20 millisievert criterion is too high after like.
What do they know about this?
20 millisievert?
Human rights. What do they know about those?
So that's the criterion. The written criterion is only 20 millisievert. So, but when at the time of lift of evacuation order, the national government had this meetings with the residents. During this meeting, national government have shown this kind of like result as a result of decontamination. And you can see before decontamination, this is the yellow histogram, and the blue is after decontamination. So this is like average before decontamination is 1.6. And after decontamination, the average is 0.6 microsievert. And maximum recognizable, maybe like 1 or 1.2, 1.3 microsievert per hour. So, and they shown also the like this data. Probably this is more persuading for local residents. They before lift of evacuation, so test measurement was done. So how much dose they receive if they stay in their original place, and this shows that most of them receive like less than nobody exceeded 5. Not nobody. Most of the measurement were the dose rate corresponding to 5 millisievert per year. So it's close to 1 millisievert per hour. And probably during this meeting, the local residents agreed that lift of evacuation, knowing that the annual dose is not 20 millisievert, like 5 or less than 5 millisievert. And this is another project of national government. National government, together with municipalities where evacuation order is issued, started specific recovery restoration zone. This is for Futaba town. They started 2017, and by this specific designation, national government can implement decontamination or demolition of houses or contaminated buildings. And the similar specific recovery restoration zone was started for Futaba town, Okuma town, Namie town, Tomioka town, Iitate village, Katsugawa village. So except Minamisoma city. Minamisoma city has difficult to return zone, but the former population in this zone for Minamisoma city is very small. It's like a 10 or 8, around 10. So they did not start a specific recovery zone, recovery restoration zone, but other municipalities set up this specific restoration recovery zone. And this gray area is the difficult to return zone. And within difficult to return zone, the national government, together with each municipalities, designated the specific recovery restoration zone and started decontamination activities from 2017 and 2018. And this is a 5 years project before lift of these specific recovery restoration zone. So the part of the municipality has started the lift. The first one was Katsugawa village, very small area within the difficult to return zone, but this green area is already lifted. And this is the Okuma town. Okuma town. This red area is a specific restoration recovery zone. And this area is lifted for evacuation order just this summer. And now I mean, in 2018, this Ogawara area of Okuma town, they have less contamination. So they restarted several years ago the municipality office here, and they developed into like residential area and like a commercial area already. And they are trying to connect this new area and the former business area. And after some argument in the council of Futabatan, they also lifted at the end of August for this specific recovery restoration zone. So I just want to another thing. But still, after the lift of this specific recovery restoration zone, still like not small area of difficult return zone exists. But national government announced that this area, if the former residents wants to go back, or someone newcomers maybe okay, but they didn't have announced yet. If the former residents wants to go back, national government will help decontamination so that they can return within 2020s. And if these former residents wants to restart the agriculture, national government will also help. This is the rather new announcement, but it's made in 2021 August. This is how it looks like in a former busy street of Okuma. Former residents could choose whether they demolish or decontaminate their property, their houses. But most of them chose demolition because they have not lived there for a long time. The building has a lot of damages. So they have to restart from the reconstruction, actual reconstruction. So this is the summary. The criterion, all the criterion national government says is less than 20 millisievert. After the discussion, including the former residents, the actual lift was done when about 5 millisievert, less than 5 millisievert was achieved after decontamination. And I mentioned to specific recovery restoration zone, and also I mentioned to difficult return zone outside specific recovery restoration zone. Okay. And we should have invited Ukrainian colleagues to this museum, the Great East Japan Earthquake and Nuclear Disaster Memorial Museum this year. So these histories are also like exhibited in this new museum, which started 2020 September during the COVID pandemic time. Okay, thank you. That's from my presentation. So, please add comments.
Thank you, Nando-sensei. Very interesting experience of our Japanese colleagues. And what I would like to say is that in contrary to what we have in Japan, in Ukraine, the territory which belong to these contaminated zones do not change or did not change since 1995. Chernobyl legislation was established in 1991, and from 1991 to 1995, the list of the settlements which which are belonging to the radioactively contaminated zones was only expanded. And from 1995 until now, just 6 settlements, as I remember, or 4 settlements, Рівненській області 6 settlements. Two settlements in Volyn Oblast and 4 settlements in Rivne Oblast were shifted from the zone of obligatory resettlement to the zone of voluntary resettlements. Why they did this? Because according to legislation which was existed at that time, people which refused to evacuate, to resettle from the zone of obligatory resettlement should lose all the compensations, rights for compensations and privileges. And they only could keep these rights if they shift to another zone, if they leave the zone of obligatory resettlement. So local municipalities sent a letter that they ask to shift their municipalities from the zone of obligatory resettlement to zone of voluntary resettlement. In such a way, they resolve this issue. Only 6 settlements. So in Japan, we can see in 10 years about over 60% of the territory was returned to the population. But in Ukraine, we cannot see this. All the territories which belong to the obligatory resettlement zone, except these 6 settlements, still remaining in the obligatory resettlement zone. The issue is, during the adoption of the Chernobyl legislation, really nobody thought that there will be a time when we should think about returning this territory to the people. And we should understand it was Soviet Union, and everything belonged to the government, to the state, not to the people. And it was a decision. The situation in Japan after nuclear accident and after contamination of the territory, territories which were evacuated were not withdrawn from the management of local municipalities. Local municipalities were still responsible for this territory. They were evacuated, but they still were responsible for these territories. And they became drivers to revival of this territory. In Ukraine, we do not have these drivers because this territory were withdrawn from the management of local municipalities. And the proper mechanisms to return this territories to people were not created. So our task now is to make this careful analysis of the situation, and we really did this together with our Japanese colleagues, and to suggest mechanisms which will provide the possibility to return these contaminated territories, which belong in particular to the zone of obligatory resettlements. And for the moment, we do not have any real situation which requires such strict radiological restrictions. On these territories, people can live, and in principle, people can cultivate these agricultural lands and have crops which the level of contamination of these crops is less than the national standards for food products. So the only issue now is to create these mechanisms. We are working over this. And first of all, we are trying to change the legislation and to make the only criterion for this radiological zoning should be the annual dose, effective dose for this population, not level of contamination. Because in principle, this level of contamination, surely those, the reduction of those is much quicker than the reduction of density of contamination. And really, those is the criteria of the safety, and everything should be done taking into account those, and from those are there secondary criteria, including density of radioactive contamination, should be calculated according to present situation present in these areas. This is the first direction. The second direction, to create mechanisms to elaborate some regulations which will give us the instrument to assess the existing contamination of existing territory, and to say that this territory for the moment should belong to this zone, not to which it was belonged yesterday, and to create the mechanism of this shift. Who will be responsible for this? Because during Soviet Union, many decisions were taken, and now we can find who took these decisions. And respectively, we could not find which government body or which local government body should take decision to pass these territories to local population. So we are working over creating of this mechanism. So this is, and we are supported by our Japanese colleagues. And if you ask, do you know this only from the researchers of your Japanese colleagues, or you should know this maybe even without this research? Sure, we know this even without these researchers. But Japanese experience is a good practice, and we can show this practice to our government and say, please, look at this good practice. Let us follow this good way to return these territories back to local population. Thank you. Maybe some questions?
I have some questions for the previous speaker. You told in your presentation that the people who are returning to those territories, they prefer their houses to be demolished instead of decontaminate. And but this is their family memory or some heartfelt feelings. But no, they prefer to demolish it. I don't understand who will pay them for next houses to be built on the same territory.
Okay. These houses in the area in evacuation order issued, and so national government compensated. They get money, not small money. It's enough money to have new house someplace for house owners. If they live in an apartment, rent apartment, they will not receive this money. But the house owners, this is like a damage of whole building. So this is one reason they could easily choose the demolition. And another thing, this is something actually in Japan. Like most of the people, not all, houses are not something eternal. It's very temporary. So if it lasts like 25 years, 30 years, that's enough. Not always. And the more important thing is tomb place. Tomb place. Their tomb place in difficult to return zone is well managed. Tombstones are well polished. This is the more important thing than houses.
Thank you. Number Sensei, as I remember, after evacuation in Fukushima, there was an information about when they started to assess the situation of these houses. There was information that essential part of some of houses had some leakages of roofs. Leakage of roofs.
Ah, yes.
Yeah. And many years passed. So if they had leakages of roofs,
of course.
Yes.
So
some houses were damaged.
Yes.
And surely people maybe, in our case it was after Chernobyl, people preferred to get better roofs from the government and not to demolish, but to change roofs. Ask governments to change roofs of the houses. What is this in Japan?
Yes. Yeah, I thought probably they could choose there. If this is, but this only should be possible after lift of evacuation. And you can, I should remind you that before nuclear power plant accident, there was the earthquake. So roofs has, yeah, you are right. This is also a big damage. But if not, there are invasion of wild animals, especially wild boars or raccoons. These are invaded in the houses and destroyed some part of the system. We say that for small mammals as well, mice, and sometimes the human. There are just like still took place in many cases. So these are reasons of choice of demolition. Yeah. Also. Thank you. Yeah. Thank you.
Все, ты не выступишь? Я включу, выступить. Ты. with Yoshinka. Maybe would like to speak on the seminar. Would you? Oh. Okay, thank you very much. And now I would like to ask to take floor to present his out. So let us Professor James Smith to take the floor.
Did you get my presentation?
Oh, you sent to when?
This morning.
To the
organizing committee. Yeah.
James Smith. Yeah, it's PDF. Okay.
Yeah.
Could you please turn off the lights?
Okay. Oleg has given a very nice introduction to more or less the whole talk, actually. So we had a project to look at some of the issues about rezoning in Ukraine, and Oleg has explained lots of things about that already. So this was a joint project with EcoCenter, with SAWESM, with the Ukrainian Hydrometeorological Institute, with Valeri's group in the Institute of Agricultural Radiology, and some UK scientists, as well as CIRAD in Norway, Deborah Orton and Yevgenia Tomkiev, who are experts in ethical issues surrounding rezoning and radiation in the environment. So I'm just going to give a brief overview of this project we did called iClear. And so we were working, as Oleg explained, the zone of unconditional resettlement. So we did some work in the main exclusion zone, but mainly we were working in the Narodici district, which is in the second zone. And so it's an area where there are still people living, but there's no official use of agricultural land allowed. And so I'm just going to briefly show some of the work we did in Narodici, and this work was done by Valeri's group, he and Slava Levchuk, looking at a field plot in Narodici to develop a protocol. And I don't take credit for this, this was Valeri's excellent idea, to develop a protocol which says, can the land be used to grow crops safely or not? And we know pretty much that it can, but we need a mechanism that can hopefully eventually be put into law to say that this land is safe to use again. And so Slava Levchuk chose this field plot in Mezhaliska in the Narodici district, so it's 100 hectares, and then he characterized it for the dose rate distribution. So this was a walking survey with a dosimeter, which he then turned into a map. And we can see the dose rates here. The dose rates are relatively low, so about the maximum of about 0.3 of a microsievert per hour. And then he took samples to work out the density of contamination to compare this with a dosimetric survey. So here we have the dose, which is much quicker and cheaper and easier to measure than the cesium contamination in soil. And so this was to develop a relationship for this whole area between the surface dose rate and the cesium contamination in kilobecquerels per square meter. And this means that if we want to extend this, we can do it over a larger area more simply, either using a walking dose rate survey or using drones. And so the map of the field dose rate was then converted by Slava into the density of contamination in kilobecquerels per square meter. So we can see it goes from about 150, 200 kilobecquerels per square meter up to about 400, 450 kilobecquerels per square meter. And in this area, in this distance from Chernobyl, we're not concerned about strontium and plutonium and americium because most of the fallout was confined to the 10 kilometer zone, although we did measure those just to prove that they were not significant. And so then Slava and Valeri turned this into a method for calculating what's in the crops so that they could come up with criteria. And this is based on the old criteria for zone 2, which is the zone of obligatory resettlement, which the field is currently in. And this is the zone 3 criterion, where the rules are much more relaxed, so crops can be grown in zone 3. And the results showed that this field could be classified under the criteria for Ukraine. It could be classified in the zone 3 area rather than in the zone of obligatory resettlement. And they also did a calculation of statistical calculation of how much was transferred into crops based on the surface contamination density to again show that crops could be safely grown at this level of contamination of cesium. So the other thing we did, and this was my work in this, was to do a Monte Carlo risk assessment to show that the dose to an agricultural worker on a typical farm would be acceptable. And so it's a dose to a farm worker for a typical agricultural work on 100 hectares of land. It includes external inhalation and skin dose, and also it was done by Monte Carlo assessment, so we could look at the uncertainty in the dose rate estimate. And so what did we find? Well, this is the external dose from cesium-137, and this shows the variation in external estimated dose to a farm worker. And the higher doses is the range of worldwide external dose rates from naturally occurring gamma-emitting radionuclides like potassium-40, thorium series and uranium series nuclides, and also cosmic radiation. And some of these high areas are parts of the world which are very high altitude, where you get high cosmic radiation. And so we can see it's very clear that the additional external dose, not only is it below the acceptable or guideline acceptable limit of less than 1 millisievert per year, it's less than that, but it's also much less than this very wide variation in external dose rates we see worldwide. So millions of people around the world get doses up here from external radiation. And then we looked at the inhalation dose, and of course, as various people, including Valeri, have shown from the work on the forest fires, the inhalation dose. So this includes inhalation dose from dust, from crops, if you're processing crops, the inhalation dose from being on a tractor and inhaling dust when you're ploughing or cultivating the soil. The inhalation dose is really low, so less than 1 microsievert per year. And of course, the approximate range in worldwide inhalation doses from radon series radionuclides is between about 100 microsieverts per year and 100,000 microsieverts per year. So this is kind of obvious at these dose rates, but it's important to do this analysis to show that a worker on these fields would not get a significant dose. So apart from developing Valeri's protocol on how to classify agricultural land, Yevgenia and Debbie in Norway also
talked to people about what they were concerned about in those areas and what they were concerned about, issues around rezoning. And of course, they're not just worried about the radiation. That's often not the highest thing on their list of priorities. They're worried about having enough food and having jobs and futures for their children and all the things that everybody in the world worries about. And so they conducted interviews with 40 different people in the Narodici area and asked them what it is you're concerned about relating to rezoning of land. And this is some of their results. So there were various positives and negatives about rezoning as the people saw it. So some people recognised the importance of rezoning for reusing the land. The villages would feel more alive because there's more people there and people working. They were happy, although the Ukrainian experts know more than the British experts anyway about the issues. People like to see international validation of what the Ukrainian experts were saying because it gives them a kind of feeling that there's some objectivity around the decisions that are being made. So they liked the fact that independent experts were involved in making decisions. People felt that ordinary people wouldn't benefit from it, so they were worried that the big agricultural corporations would come in and use their land and they wouldn't see a benefit. They're worried about issues around land exhaustion, typical issues that you get in agricultural areas anywhere, excessive use of pesticides. They were worried that some of their unofficial use of pastures and collecting of wild foodstuffs could be affected. And of course, not everybody, but some people were of course worried that the land is contaminated. So attitudes to rezoning, so they saw some positives in terms of investment in the area. Many people know that the land isn't that contaminated, but they're concerned about loss of benefits primarily, and there's still a hope because if you live in the difficult to return zone, in theory you have the opportunity to get a house outside of that area, not the obligatory settlement zone. But in practice that isn't happening. It hasn't been happening for many years. And of course there's a mistrust of authorities. That's not unique to Ukraine, of course. There's a mistrust of authorities all over the world. And of course there's an understanding or a concern that the land is contaminated. And again, in terms of rezoning, people like the idea that international scientists were involved to give an objective view of the rezoning decisions. So that was what we talked about on rezoning. It kind of came to a stop with COVID and of course with the war. But we've been carrying on with another project that we started in ICLEA, which was the Chernobyl distillate alcohol project. And so we did some experiments in the exclusion zone to grow crops, and we found that the crops were slightly contaminated. But when we distilled the crops to make a kind of vodka or moonshine, then we couldn't find any radioactivity in the distillate. And this is important for selling in Western Europe at least, because in Western Europe we know there's radioactivity everywhere, and every foodstuff has radioactivity in. But people don't. If a product comes from Chernobyl, if there's 1 becquerel in it, people will be concerned. And so the beauty of a distillate alcohol is that we couldn't find any radioactivity from Chernobyl only carbon-14 we could find. So we started this project and we set up a social enterprise called the Chernobyl Spirit Company. And the idea is that, well, what is happening is that we're selling this product in the UK and abroad to a certain extent, and we're making some profits and giving those back to Ukraine. So the idea is that the majority of profits generated will go to support people living in the regions most affected by Chernobyl. And so we've produced about 5,000 bottles with the help of a distillery in Ukraine, and we imported them to the UK, and we've sold about 3,000 bottles so far. So we're making, it's working in a very small scale. But perhaps in a more important way, it's working in changing people's perceptions of these contaminated areas, because people in the UK need to understand that the Chernobyl zone isn't what it was 35 years ago. It's changed a lot since then. And so we got worldwide media attention. So we got a media reach, they call it. It means the number of people that potentially could have seen the story in the billions. We've had lots of visitors to our website, which not only sells the product, but it also explains about radioactivity and Chernobyl. And so far we've made some donations to support refugees and some people in the Ivankiv area. So that's it. That's a brief summary of what we did in the iClear project.
Any questions now?
Yeah, Oleg.
Thank you, Jim. Very interesting. Do you have some feedbacks from people who bought your atomic orbital?
Yes, they like it. They like it.
Do you have on your website a place to put comments? And can you read these comments?
We should do that. We should do that. But we had some really nice emails from people saying, "Fantastic project," and we've had maybe over 1,000 people in the United States emailing and saying, "When can we buy it?" And we recently we released 400 bottles via a whiskey website that sells all over the world, and they all sold. So people are interested.
Even in Australia.
Even in Australia, yeah.
What is the price of one bottle?
It's very expensive because it costs us a lot to produce. So one bottle so we have 3 flavors. So they're fruit distillates. They're nicer than vodka. They're not exactly vodka. So our apple one is 45. Our pear one is £55, and our plum one is £65. So it's very expensive, but people are interested and people want to support the project, and they see that the profits are going to Ukraine. So after the war, the BBC did an article saying that this small company was keeping going despite the Russian aggression, and we sold 1,000 in one day. But it's a complicated project. It's a complicated, yes.
Jim, I have advice for you. That many scientists have opinion that the low doses actually improve that. So let you go this direction.
Yeah, maybe we have to be careful about that. We have to be careful about that. Yeah.
Jim, what about the wine with data of Chernobyl accident?
Oh.
When we had the seminar in Crimea, maybe, do you remember?
Yeah.
15 years ago, I buy the bottle with the data of Chernobyl accident in the laboratory and measure the activity of cesium in this bottle. This wine was the real decision.
It's a new marketing.
Yes, very, very small.
Yeah. Okay. Thank you.
Yes, thank you.
Professor Kasparov to give floor to presentation. Final. How many presentations do you have to this? Maybe not feeling that something more than safe, maybe what?
Alec, as I said about the problem of Jim
the problem rezoning in Ukraine now is very important. But needs to separate two problems. The first is the settlement, and second is the territory. Because for the settlement, very good we can use effective dose. For the territory, we use another criteria because it is not possible simple estimate the dose for the population, only for worker, only from the contaminated product, but it is not simple and need to have the special protocol. After the Chernobyl accident, we use for the evacuation criteria the dose 100 millisievert during the first year after the accident. Half part from the external dose and half part 50 millisievert from the internal dose. It was the same density of contamination with cesium, strontium and plutonium. And after 5 years, in the law of Ukraine about the resettlement, we used also this value, you can see, without any very good description. Because, for example, the resuspension factor changed in 1,000 times during this year. About the strontium, also we had the change of contamination of product, and with cesium also we had the oldest in the sorption of cesium in the soil and change contamination of the food. In the law we had 4 different zones. It's exclusion zone, the people was evacuated. Second zone with effective dose higher 5 millisievert with cesium contamination, this strontium, and another zone. And you can see for plutonium, in the law we have the isotope of the plutonium. But we have the plutonium also isotope 241, and the activity this isotope is more high in comparison with alpha emitted isotope 238 and 40. But in the law, we have only the isotope of the plutonium. It was very big mistake, because the people came to ask what is the density of contamination here with another isotope of the plutonium. And the 40th zone was liquidated in 2014. In December 2014, and now we have 3 zones. The biggest zone is 30th zone. It's about 800 settlement, and the 40th zone, and here this territory. If you can see in the exclusion zone now and use the criteria for the cesium, it's red, blue with strontium and with alpha emitted plutonium. The contour is the same, maybe 10 kilometer zone. But for plutonium 41, you can see the boundary we will have outside the exclusion zone. Because now the ratio between beta emitted plutonium and alpha emitted isotope plutonium is about 10 times. And here is the density of contamination with strontium, cesium, and plutonium for 2086. And you can see the most important, the boundary we will have is long-living isotope of the plutonium. And this territory will be, density of contamination will be same during the very, very, very long time, because the half-life of plutonium is the isotope 239 and 40 is very, very big. If we use the density of contamination, the settlement, and use the decay of cesium, now we have only 10 settlements where the density of contamination will be higher this value for the 30 zone. We haven't any settlement with density of contamination higher the limit for the second zone. And we have any settlement with density of contamination with dose for the second zone. And for the third zone, you can see only 10 settlements. But if we will estimate the dose by means of the official method, for this settlement, dose will be less 1 millisievert per year now. About the strontium, maybe in 2014 we had the project of European Commission with estimation density of contamination with small state, event of region, its near exclusion zone, with strontium and cesium. Very good data for each settlement, and we obtain now we have 38 settlements where density of contamination may be higher the level for the 30 zone. But real for this settlement, the external dose is less 0.5 millisievert and the internal dose, and 10 years ago was less 0.4 millisievert. Because we have a real correlation between density of contamination with strontium and the passport dose in the dose for the population. And the density of contamination is not very good criteria for the influence of radiation to the population. And last official data about the dose for the population in settlement, the official passportization, was 10 years ago. And we have here 25, 1086 settlement where the effective dose was higher than millisievert. This settlement in Rovno region and Zhytomyr region with high density of contamination. And 10 years ago, we create the special expert conclusion for the change of the status of this settlement. It was the special expert conclusion for each settlement with analysis of density of contamination, dose during the 5 years, from 2007 to 2011. And we obtained the support for different ministry, agriculture, health, Academy of Science from the law. And for each settlement, we had this conclusion with dose, with density of contaminant. Here's the conclusion about the corresponding to the law, the criteria of law. And real, 10 years ago, we haven't any settlement for the second zone and 100 settlement for the 30th zone from 800. About 10 times less, it's 10 years ago.
It was recommended by the expert conclusion.
Yes, it was expert conclusion, real. But support, but the public opinion was very, very negative. I take part in the Kiev region administration, and the public opinion was very negative to the change of the status of this settlement. And you can see here, it's the data of dosimetric passportization, its internal dose, red, and the external dose. For this 25 settlement, the highest influence we have for the internal dose by contamination of product. In Japan, another situation. Its influence of internal dose is very, very low, and the most important is external dose. But in our case, we have the very big influence of internal dose, and in this case we have a correlation, you can see, between density of contamination with cesium and the total dose. It is not internal dose, it's the total dose. Internal and the external. But for the external dose, we have very good correlation. because in the passportization we calculate external dose from the density of contamination, multiply density and coefficient. But the total dose, we have a correlation for the Zhytomyr region and for the Rovno region. You can see very, very different density, but the dose is, it's for the Zhytomyr region, but here it's for the Rovno region, where density is very, very low, but the dose is very, very high. Because for this region, we have the contamination of the milk, high level of contamination, and from the official method, we calculate the internal dose from the consumption ratio and the activity concentration, average activity concentration in milk in the potato. Potato is not important, but most important is the contamination, the milk. And from this, we have very, very good correlation between contamination of the milk, for example, in Rovno region, and the total, the dose. It is not internal dose, it's the total dose. But the correlation very, very good. If we have the contamination of milk high 220 becquerel per kilogram per liter, we obtain the dose high 1 milliliter. It's very good work. And our institute, we have the data about the monitoring, about the contamination of the milk in Zhytomyr and the Rovno region during the last year. And we have this data, and the half-life decrease of activity concentration in the milk is more critical settlement now from 8 to 16 years. It's decrease of activity concentration. If we use this value for the estimation decrease of internal dose, the same the decrease of contamination of the milk, we obtain now only 12 settlement where the total dose may be higher 1 millisievert. But it's very, very conservative because we use the highest value half-life. Half-life maybe 8 year, 10 year, and real, the number this settlement is more or less. And you can see also this method, from this method, we have very conservative estimation because ratio between the real internal passport dose and the dose estimate from the content of the cesium on the body of the people is very, very different. The dose from the measurement by means of body counter in the average in 10 times less in comparison with internal passport dose. Here you can see the settlement from dosimetry passportization 10 years ago for the settlement where the passport dose was high 0.5 millisievert. It's blue. And here is from measurement of cesium in the body. In any case, this dose is less 0.1 millisievert. Because the passport dose estimation is very, very conservative. The difference, the average in 10 times. Why the passport dose is very conservative? Because we have the very different contamination of the milk during the year. The highest level we have in the pasture time. And they take the sample also in the summer and obtain the difference between average content of cesium in the milk. Because for the estimation average dose, need to have the average value of contamination milk in the settlement. It's very, very difficult because need to take sample during the year. It's first problem. Second problem, this settlement is very, very big. This very different group of the animals. And the animals, this use the different pasture, with different landscape in forest, in the peaty soil, in the good soil. And you can see, for example, for Cerniki settlement, it's different pasture, and here is different contamination of the milk. The difference may be higher 10 times. And I know from my experience, during the transportation, the people take the highest contaminated milk. It's simple, and people very good know where it's contaminated. And also there are the different methods, decrease of contamination milk. The people use contaminated mushrooms and another method during the transportation. And if you take the sample milk only 2 times, in winter time, in summer time, for example, 10 sample 2 times during the year, we obtain the average contamination of the milk in the settlement with an error about 60%. It's very, very high error, very conservative. And the conclusion of this work is very, very big, but the show, it is not possible to use now density of contamination for the settlement, only the effective dose. And need about the plutonium, I said, because the ratio between plutonium now it's about 9 times. It is not possible use this radionuclide. Also, the influence of americium is not very big. It's only in half time higher in comparison with alpha emitted isotope of the plutonium. But the estimation, the effect of resuspension plutonium isotope and the influence in the total dose now we have for the level about 1 microsievert per year. It's in comparison with dose limit 1 millisievert. Because the suspension factor now is very, very low, and plutonium is not important radionuclide. And also I said we have the real contamination of the milk now in Ukraine, and the real only for settlement where real high contamination of milk, and only about 4-5 settlement where dose, effective dose will be high 1 millisievert if you will use the old method calculation of the dose. And the Ukraine from the low radioactive contamination territory, it's a territory where the dose may be high when high 1 millisievert. And from this data we have about 5-10 settlement where the dose higher than millisievert from the low, it's radioactive contaminated settlement. Another settlement in Ukraine is not radioactive contamination. I don't speak about the exclusions. And need to remember now the people obtain the biggest part of the dose. And change of the zone, we don't change the status of the people because people obtain this dose. It's for the future people, for young people, for this territory. It's conclusion. And
мы после very important. Мы delete conclusion.
Because it's very, very big conclusion. Now we prepare article. This article will be published. Discussion. And it's very interesting Ukrainian people about. Okay, Jim Smith said about the estimation, the contamination of agricultural field, and we continue this work. And now we have information about the 2,000 hectares of contaminated territory in Žitомир region, about the real density of contamination, and we can prepare the conclusion about this.
I think we know.
About this territory. Thank you very much.
Thank you very much. And we will have next discussion. So these two options. So now ask. I have question. Please question. Please teach on plan.
Professor Kasparov, thank you very much for almost lecture presentation about the structure of the doses for population in the north of Ukraine. I just wondering, we all know that for regions from the north of Ukraine, it's very difficult to eat what they can get from the nearest forest. Wild berries, wild mushrooms, game, local fish, and sometimes, particularly for the poorest group of population, this is the major part of their diet. But I didn't notice from your presentation the consideration of what the contribution of this sometimes heavily contaminated foodstuff in the formation of the internal dose for this maybe very specific and small group of population. Can you share with us your take of the impact or possible share of this external dose which they consume with the locally gathered wild heavily contaminated stuff?
Thank you very much. I can. This study, this because there are the people with very high uptake of mushrooms, maybe fish, and the difference for these people for the content of cesium is average maybe very big. But it is not criteria for the zone, for the change of the zone. But if you see the measurement of the body, the average value in the body, it's including the people with big consumption, mushrooms, and other products. And the real is low normal distribution. And for this critical group, it's the same. For also the same representative person now. It's 10% the people with highest dose, internal dose. But the real, the ratio between this critical group is highest dose. And the average value for the settlement in Ukraine for the internal dose, it's 3 times. And we calculate this, but it's 3 times. But the difference between measurement in the body and passport dose, it's 10 times. And 3 times higher in comparison the people with very big consumption of mushrooms. And for the external dose also there are the difference between average value and for the representative person. But this ratio 1.8 times. And if you method we will use the representative dose for representative person, also we have only 5-10 settlements with those high values.
May I just? The whole body counting is being conducted by the Institute of Radiation Protection. And in Žitомир region, they are working in several districts, and they make several hundred measurements during 1 year in several districts. And within these several hundred people, usually less than 5 people have more than 1 millisievert per year, and maybe one person could have from 5 to 10 millisievert
With internal doors.
It is not possible country or the separate people with very, very high need. The group, critical, it's the same critical group in the old publication.
Okay, we will now continue discussion as discussion, guys. So, I prepared several slides about the questions to this item to discussion, but it's not all. We have 5 slides. I have question to organizer, local organizer. What have we limit in time? We should start to eat and drink here when?
We can start in
Not now. I have to.
in 15 minutes. We can start now.
Ну, сейчас, мы можем еще поговорить? Okay, so, idea was, I put some questions from my point of view of the summit of discussion. Plus I received several proposals. Let's go through the list, and we'll see if somebody would like to add something, let's discuss. So, I look on the most heavy discussed items during the seminar. I will start from the first point is radionuclide, sorry for mistakes in drinking, radionuclide fate in the Chernobyl exclusion zone and dispersion through the border of the zone. First question, item quickly discussed, forest fires, impacts inside Chernobyl exclusion zone and through the border. We have seen several presentations and was formulated this conclusion by example, several conclusions by Dr. Talerka, that in reality we have not real danger from the increasing of the level of contamination during the forest fire outside. But it's very important to make this calculation for outside because in Kiev know very well is a panic each time when forest fires. So we should produce information, and my feeling is that one of the most important in such forest fire situation to catch contamination, because if forest fire in Chernobyl and government will say nothing in Kiev, nobody trusts. Therefore, it's very important to catch this low level to show to the people that low level exists. And my feeling is we have experience with STC and RS that they catch as well today this small level. But I am not pretending that I know everything. So, what do you think? What is the main threat inside Chernobyl zone from the fire? To people, to doses, have somebody idea? What is the most level of danger?
The doses in Kiev.
No, Kiev doesn't know. Inside Chernobyl, inside Chernobyl, no. What is the main threat?
Fire itself.
Not from space. Stay is something. Would you like to say something about what is your view? Please stand up.
I can say, but frankly speaking, I don't understand the question here.
My question is, okay, we study forest fire, but if you study something in Chernobyl zone, we should find most dangerous situation. The group of risk, maybe not people, but maybe about animals will be impacted. Who is the most, during the forest fire inside Chernobyl zone, the group of risk?
Only firemen.
Only firemen.
So firemen from the law, from BSS, need, before the beginning of work on contaminated territory, obtain the information about the real estimated dose.
What about people from ecocenter?
But it is not dangerous.
They also should be more people. The personnel.
Kirill, you have experienced many forest fire. What is your feeling? What is the major needs for you? What forest fires happen? What do you need? From support from science, from technology, from monitoring, what do you need?
By laboratory was good.
Досвід використання чи участі в пожежах, він показує те, що
Залу говорите, пожалуйста, зал на лицо.
Forest fires?
І оперативна інформація, вона залежить від того,
The operational information depends upon the
next factors.
Наскільки працює ця система збору даних, аналітика і підготовка проєкту управлінських рішень.
Collection of the information of the analytical processes.
Підготовка управлінських рішень.
And the preparation of management decisions.
Окей,
Чекаю. До військових дій в зоні відчуження.
Before the war actions in the exclusion zone.
Система традиційно-екологічного моніторингу достатньо продуктивно працювала.
The system of ecological monitoring was worked at a high level.
Крім того, що тут були показані Валерієм Кашпаровим
Today we saw
система
the system by Valery Kashparov system.
Chernobyl Fire.
The information about the Chernobyl fires.
Сама система АСКО, вона працювала і мала два блока прогнозування.
The system of automated radiation monitoring, it worked itself and it had two, and the system had two blocks.
Перший блок це
shortly, please, not presentation.
Для того, щоб ми оперативно це знову таки виконували, нам потрібна мобільна лабораторія, яку у нас вкрали.
We need a mobile laboratory in order to have the opportunity to perform our duties. This mobile laboratory was stolen.
І аспіраційні установки, все інше буде.
Okay. Question about forest fire to natural reserve. What is the main danger for natural reserve? Who will speak?
The main danger is all forest fire due to the wildlife.
What?
Wildlife. Plants, animals, and so on.
Not people, wildlife.
Which live in the exclusion zone, but as I saw the seminar, it's not the impact of radioactive contamination, but the threat of the fire itself, mostly.
Thanks. Grasha, question to you. You study impact of the forest fire to the forest situation for the ocean count of radioactivity. Did you find any serious impact or some impact to the environment during the forest fire? How would you comment?
Yeah, actually the solid liquid coefficient for the cesium and the strontium are a little bit different. I mean the normal condition against the normal condition. So the ash materials, it's easy to release the cesium and strontium for the water.
But how many percent is 100%, 3%?
Currently, I couldn't, found such a.
But it exists, so we should continue.
And this time, I'm asking to UHMI staff to evaluate such coefficient by the laboratory experiment. So the future.
This is ongoing experiment now. Okay, great. Thank you. Question to Gina about next question. Presentation. We have growth of the water exchangeable form. If you look at the such situation forecast, it means that during next big flood, amount of strontium in the water increase. What do you expect? What is the limit of this growth? And what is the situation next year?
Well, according to our estimation, we are nearly to get to the equilibrium amount of exchangeable or available form of strontium at the same time, which for our geographical condition, for our region, geochemical region, is equal to 70 to 80%. So from the total content of strontium, at the moment, from 60 to 80% of strontium could be potentially involved in transport with the water flow. At the same time, we observe a significant deepening of the inventory of strontium in the soil profile. But we all know that during the flooding, only very specific uppermost part of the soil, so the content of strontium only in this very small upper part surface of soil could take part.
Okay. So, what you say? You say that we now near the peak. Situation will diminish. Risk will diminish.
And then we will go just down.
Okay. Next question, very highly discussed it was. In some areas of the cooling pond, we see, as I also demonstrate, sharp increasing of the concentration of strontium in the surface water. And without plateau, it continues to grow up. Question, what is the reason? What is the limit in the surface water? And also question for the groundwater. In groundwater, we also see such increasing, mainly in the northern part. We have today seminar, because before the seminar we have 3 days discussion with the working project, different opinion. But I will maybe ask now some kind of the discussion. First, Dmitry Bugaevich, how you could comment now? Only shortly, main message.
Actually,
come here, please, Dima, come here.
I have.
But people should stay.
Okay, I made my model, the conceptual models describing this phenomenon in my presentation. For the surface water, the main reason I see is change in the water exchange rate in water bodies. So you have a source of strontium, you have water exchange rate, the source of strontium are dissolving fuel particles. So if you have slower exchange rate, you will have more or less constant flux of strontium from fuel particles plus lower exchange rates. It means that you will have rise in strontium concentration. There was very, very sharp rise in strontium 90 in Mission Lake during last year. In my opinion, that it could be some well-induced event, maybe someone put some radioactivity.
You was there, your result of your activity.
Could be a result of maybe of subtraction, I don't know. But it is very.
He says that some people increase amount of the strontium.
Maybe Chernobyl nuclear power plant, or maybe. No, it's very hypothetical, but in my opinion, it could be very variable, because I calculated how much you need to add strontium. You will need 40,000 becquerel per minute.
Wait, I'm done.
Yeah.
Okay. First about groundwater, then we'll return back again. Groundwater.
With groundwater, so it is true that in several wells there is increase of strontium 90. But some wells are not influenced by the cooling pond. There are 2 wells near Semihodizaton and Pripyatzaton. This rise is observed during the last 10 years.
So your opinion not significant because very small amount of.
No. In several wells it is can be related to the drainage of the cooling pond, not in all, but in several. In my opinion, this could be explained by this hydraulic mobilization of the stagnant solution.
Okay, thank you. 2 opponents. In surface water, or Prozac or lab, who will speak? As opponent to him.
I can see.
Yeah, true.
I can see.
Yes, you would like to say something? Come here.
Actually, during the feasibility study of the drawdown of cooling pond project, which was implemented in year 2011-2013, I remember, we did some prediction of the future increase of concentration of strontium in the water. No, in the water of cooling pond, yes. And 2 main reasons which we considered during this making this prediction. First of all, is the interruption of the artificial water exchange because the pump is not in operation anymore. And second is the reduction of the phases ratio. So we have a significant decrease in the water level, but we have a very heavily contaminated sediments. So there will be something like a new quasi equilibrium between these 2 phases. So the level of our predicted concentration was about 50 to 100 becquerel per liter for strontium. So we're quite far away from the value.
Your prediction will continue?
Yes, yes.
Okay.
This will continue for...
As an opponent from the groundwater, Maxim, please come here. Could you comment something from Bugay say about groundwater? Only quickly and short. Many questions here.
Yes, many questions. So, as opponent to Dr. Bugay, I would say that we shouldn't neglect the possibility, especially during the cooling pond drawdown times, that the slow decrease, as we said, it's maybe 40 centimeter per year, what kind of reactions we can expect. And if those reactions are important, the drawdown of the cooling pond water level, decreasing the groundwater level in the sites, various wells, which are surrounding cooling pond, especially in the north area, not so much into the close to the treated K7. But those slow declining, what processes can we expect, or processes that we didn't account when we did the modeling of the cooling pond decline? So I think despite the KD coefficient and all of that, maybe there are processes we can look at from different point of view to consider it as a potential source.
Thank you. My conclusion is this part. Not clear.
Not
we have as a first open question, and we have time, but we will, the problem is problem. Because if only image, tomorrow some correspondent was here, he written what I say, and we say that concentration strontium in cooling pond increase in some places to the level of beginning of 90s. Panic in Kiev, so we should have answer. So it's our task to analyze and to find the source. It's very key question. Okay, next one. Natural, I jumped a little bit, but natural ecological reserve. Still not clear conception. So it's now the border of the reserve coincides with the border of Chernobyl zone. The same time inside is industrial site. Industrial site that should grow up because country need in the after we build the wall, we should construct some plants for processing spent fuel and storages inside Chernobyl zone. How you image how you live together inside big industrial plants, big sites, and natural reserve around. Somebody from natural reserve. Denis is here, Vishnevsky? Oh. Okay, so please you. So please also come here shortly, but people shouldn't. Let's go.
First of all, on these plants, on these facilities will be built in the industrial territory. It's inside exclusion, inside the 10 kilometer zone, and it shouldn't have a big impact on the life and work of the Warsaw reserve.
Sure.
Because there will be only movement on the roads, maybe on the railroad to the site, and it's all not have a significant impact on the work on the wildlife. It will be only on the small corridors around the roads, from my opinion. And I think it's not will be a problem for Chernobyl Warsaw Reserve to live with such industrial sites.
Okay, clear. Position is clear. What is here? Some opponent? Other opinion?
Attention between Chernobyl Pushcha and reserve.
Yeah.
It's different organization of the territory of reserve.
It will be different. Reserve it's
production of the wood.
Reserve have 85 to 87% of territory, and in this territory we work on everything in the forestry and wildlife management, nature protection, everything. And we have 10 kilometer zone, and it's probably, I can't say certain because we should ask the Southern about it, and probably it's in 10 kilometer zone will be Chernobyl Push as enterprise or as part of another enterprise working on the forest management in that territory.
Okay, we'll continue. We'll come back. Thank you. To the next question. It's not end. Let's speak a little bit about monitoring. We have several very interesting presentations. And so what my view on the situation? It's a question about optimization of the monitoring network after the return to the normal life. including escrow and other point measurements, increasing role of the drones and the helicopters, and method of the 3D mapping. I will ask our guests from participants from United States and United States and Sweden comments. Eric, could you make some comment about these items?
Yes.
And Jake also, well, you have to take a comment your boss. So one per one or together, what do you prefer? Please.
Go ahead, Jake.
Okay. Please come here.
So I anticipate that in the near future, the availability of scene data fusion technologies, as well as other mapping technologies pioneered by other groups, such as the University of Bristol, are going to make the capacity to rapidly map large areas and perform other forms of mapping that are not radiation sensing, such as structural mapping, much easier. So I anticipate most likely in the next several years there'll be scene data fusion systems deployed in the zone. The cost of such systems is going down. The availability of the technologies needed to build them and understanding of the methodology is becoming more widespread. There's already a couple of groups internationally, one in Japan that I know of, that's looking to do very similar work to what we've done in the past and develop their own variety of systems. I can't really comment on the ASCRO monitoring network, but I would like to speak with some folks about that later. Yep. Eric?
That's a good response, Jake. You're much more knowledgeable about the technologies than I am, but one part that I would point out, and you touched on it, is the cost, and that the cost is now going down, which is a good thing because in my interaction with donors, the technology is not so much important as the price. And there's a cost-benefit analysis that has to be done for this. What are you benefiting from this really amazing technology that you can't do by sending somebody around with a handheld detector in the traditional way that we've been doing for a long time? Now, there are special considerations at this time because of landmines and things like that, so that makes it necessary to do aerial characterization. However, there are cheaper means for aerial characterization as well. So while the technology is there and it's very interesting and it's very powerful, we also have to keep in mind pricing, especially when it comes to our interaction with donors.
Okay, thank you guys. I would ask now Oleg Brajay, because from the ground he experienced with a scroll from which year we developed a scroll in Chernobyl. Where you start with a scroll?
When it started in 2006.
What do you see is the most now urgent problem with the scroll zone, and what do you see about perspective? What do you need to make the best in the world scroll system, mathematical system in Chernobyl zone? What do you need?
The first problem is the power supply everywhere. Second problem is sensitivity for air controls. And second problem was because in Chernobyl during the war it's communications of channels for communication between SPRO and other. And if we find solution technology for build such system, we will have better system in the.
But about the technology of this mathematical system, you know the level in the world, and so it's now decrease. What have some preference? What kind of technology could be used?
First, we used spectrometric gauges for measurement, and so for communication, satellite connection.
Okay, thank you. Okay, next. I have such a question. We see the very good presentation about Ukrainian legislation about relocation of the people. My question is, what about criteria to return territory to normal life? Because my understanding is, I am not expert, there is a difference between territory you must relocate people and criteria if people could return back to the normal life. What do you think about situation in our country, in Ukraine? What about criteria? Maybe I would ask numbers and say, what was criteria in Japan when people return back?
Yeah, I presented about this three criteria. One is the dose, annual dose, less than 20 millisievert per year. And second is like recovery of infrastructures. So of course it's like water, electricity, or gas. Not only these common infrastructures, but like hospital or like grocery stores. These are also necessary infrastructures. And the third one is discussion among prefectural government, local municipality, and former residents. So three criteria. But I should remind you again that 20 millisievert criterion is not directly applied. After the discussion, so the permissible or acceptable dose rate per year is decided mainly by local people.
Problem is that in Ukraine we have not local people in Chernobyl zone for 36 years, so it's please your comment.
For the exclusion zone, the question should be somewhat turned. This is not the criteria for returning people, but this is criteria for suspending of the radiological restrictions. For the moment, this territory belongs to the radioecological reserve, but on the whole territory we have radiological restrictions. So we can make measurements and we can make predictions, and in principle a part of this work was done by Professor Ikhtarev's team about maybe 15 years ago, and it was published. At that time it was about half a territory of the exclusion zone, which according to radiological criteria might be returned to normal life.
But now it's much more.
Now this is about 70% of the territory on which the radiological restrictions might be suspended. So we should know this, and we should define the territory on which radiological restrictions will be remained forever, and this is the special industrial site. And the rest of the territory, which and the radioecological reserve, in principle, it should operate on the territory on which radiological restrictions are suspended.
Okay. Have you some comment, quick?
Yes, it's now the boundary from the law of Ukraine, the boundary 10-kilometer zone. It's real the boundary where people can live.
Go to the first one.
It's criteria 30 zone. So the second zone, it's only the territory in 10-kilometer zone. Now, for plutonium, strontium, if you will use those criteria, maybe it is not 1 millisievert, 20 millisievert. It's maybe the fourth zone.
Thank you. Let's move to another question. It's my personal question. And we have several questions from different people. My question, because it was before summing up of the our discussion. If you look to the bright new future of Ukraine in 2030, 2040, 2050, and let's look on this problem of Chernobyl zone from this point of view. After 30 years, amount of cesium and strontium diminishing much. So question is, how long we are planning to preserve radiological criteria looking for this future that I never will see? What do you think about it? Please.
In principle, we have exclusion zone in Ukraine,
But we have in Ukraine also other territories inherited from the former Soviet Union, on which radiological restrictions are necessary. And maybe you know that there was a plan to make a law on the management of this kind of territories. This is not the management of Chernobyl territory, but the management of all kinds of territories on which the radiological restrictions are necessary. For example, the Pridniprovsky chemical plant. And there is a draft law on this, and according to this, the governmental body which is responsible for management of these territories should regularly revise the restrictions on this territory.
But so stop. But at this moment we have not municipal, we have Soviets. So does should by themselves diminish their own size? Yeah?
Right. I told you, for the moment, we do not have any objections from Soviet management to restrict, to suspend radiological restrictions. This does not mean that people from local communities should come there. This will be their decision together with radiological reserve. But these territories should the radiological restrictions should be reserved, and the territory might be shifted to local communities. Yes, and no objections absolutely from Soviet management.
Tomorrow? No, after war.
If we have mechanism, yeah, let us do tomorrow.
So problem is legislative mechanism, yeah?
Yes, yes.
Okay.
We have, when Jim came to Narodici, we signed with the management of local communities the memorandum of understanding between the Soviets and Narodici local administration that we should find the way how to return not only their lands to them of the second zone, but also lands of the first zone, because several territories of the several settlements in Zhytomyr zone belong to the exclusion zone.
Okay.
They are outside the general border of the exclusion zone, but they belong to the exclusion zone.
So unfortunately I planned to involve this discussion representative of our parliament. They could not come, but we should start discuss with them. Item. It is order of previous president that the external border with Chernobyl reserve coincide with the radiological border of Chernobyl exclusion zone of 1990. As for scientists, for me, is nonsense. Question. Somebody supports this idea that the border of Chernobyl zone coincides with the border of Chernobyl exclusion zone? Please remember.
Can I just make so relating to your first two questions, so it seems to me that by 2030 the second zone should disappear. It seems that it's a clear agreement, and as Oleg has just said, the question is legislative, it's not scientific. And the second question, the nature reserve is fantastic. The third largest, we call it the third largest nature reserve on mainland Europe, but it should be without radiological restriction. And so...
But they will disappear in 2030, 2040.
No, the second zone.
Yeah. But if you provide the measurements and those criteria, after 2040, nothing also for a significant part of today's zone. I say that in year 2040, Radiological criteria not only disappear for the second zone, but also for the major part of the Chernobyl exclusion zone.
But it should stay as a nature reserve.
It's your point of view.
My point of view.
Would you agree that we have all success, for example, a part of a country you have national reserve? Everybody will agree with you?
Well, I think Britain is different to Ukraine. Ukraine's a big country with a declining population.
Okay.
Britain is a small country.
So for Ukraine not, but for Ukraine yes.
So it's not so. So I think that the world community should support Ukraine to keep it as a Europe should support it to keep it as a nature reserve.
Okay.
Not a radiological reserve.
Good discussion. Denise is here, please.
Yesterday I asked Jim about whether there was some examination of the change of genotype for wild animals living in this area. So in this sense I can support this idea because that will be something that you can examine in the future. Yeah?
That's in the 10 kilometre zone.
Yeah, it should be.
In the nature reserve, we don't. The doses are really low.
Yeah.
So I think it's good as a nature reserve, but not as a radiological reserve.
But I return in this case to the question that I asked to the Alexander Barsuk. How to live together? No, you speak, the other people, please comment. Denise and so on. How it will be? We have plan, Ukraine need place for the processing and spent fuel, it's clear. Ukraine need place for the storage of nuclear waste. And it's clear that Chernobyl, from the needs of the population of Ukraine, is some place should be done. Chernobyl is the best place. Who start to think how they will live together? This heavy enterprise and it's maybe reasonable to make some corridor, wide corridor, between external world and industrial zone to give possibility to people to make their work. Or another problem, for example, deep hydrological storage. Also there. Now the national reserve block everything practically. I'm sorry. Denise, any comment about this? What your point of view? Please come here.
So about connection of industrial zones. All the roads and another infrastructure elements like electric lights, gas line, etc., they located outside of lands of national reserve. And everybody
the same, what I said, and Denise has the same opinion. All the roads were not in reserve. It's supported by the specialized enterprises like
national
regional enterprises, of course, in Kiev and maybe some smaller one, and it's not needed to make any corridor bigger than there is a road and some part around the road to maintain it. Because people won't work near the road, they won't go by foot to the work and anything like that. They drive the car and it's not have big disturbance for them.
But for example, people need place for the deep geological storage. Not in the industrial site now is the selection of several sites outside industrial zone, in the territory of the reserve. Would you start to work with them?
It's still the open question about the geological storage, and we don't plan to work with them because there is no problem for now. And I think if they find the location, it will be the directive of the cabinet of ministry or president to change some zoning or to change borders of reserve, and it will be some legislation steps to make. It will be not a problem in case of biosphere reserve. And as I remember the story, the territories the storage is bad planning, it's mostly on the anthropogenic landscapes.
No, it's a one with okay, but the position is clear. Okay, somebody else would like to comment on these points about how we combine industrial life, industrial needs, and bioreserve is a today border with Chernobyl. Some other opinions? No, please. Thank you.
For second one, may I my opinion?
Please.
As for
say please to the people.
As for opinion of the bioreserve, there is no question to at all, because it's already we have. The president directed about the establishment of the Chernobyl bioreserve. Also, we have the director of cabinet of ministers, which give the land under the bioreserve to us. So it's not a question at all. And it was implemented established in the borders of the zone only because there is no people in this territory, and we have a lot of wildlife. So it's
clear, position clear. Thank you.
And also, it's not. You can make any research in the territory of biosphere. It's not like forbidden.
Okay, thank you. So we also have received several questions from our colleagues. Question from Dr. Zakrotensky. Basic of data from Chernobyl and Fukushima. Can we formulate recommendation for long-term actions to be implemented to the children support system for consideration? I could first of all answer by myself what we have as experience difference between Fukushima zone. Situation difference between Chernobyl and Fukushima, I don't discuss about differences fallout. It's very different landscape and very different climate. Practically Japan is a territory practically tropical rains, rainstorms, typhoons, and at the same time where it's a mountain area, Chernobyl is a plain. And first time for this big accident we saw very big impact of the soil erosion and transport of sediments on the radionuclide transport. And as a result, this children's support system was developed before. I say about RODAS, as a we see needs to implement the models that include well-based description of the erosion processes and from the watershed and transport of the sediment in the watershed, much better than we had before. So, as for modeler, for me, such lesson. Maybe I'll ask Talerko, after this, your many years experience in Chernobyl, what do you see the key needs for the further development of the monitoring tools for emergency response? Can you make some comments?
First of all, I think this the decision support system must include the several tools for the estimation for the assessment of uncertainty and so on. The first. Second, if we say about different scenario of this accident, if mean the situation with the nuclear power plant, if you mean, or another situation, we have some additional scenario of this different situation. And very important problem is the verification of result of this modeling on the real measurement data, and especially is the new formulation for the formation of system of monitoring. As far as know, Dr. Oleg Verstychovich now is preparing the some regulations for the formation of system of monitoring of the hydrometeorology network, the system of meteorological station which measure the contamination, radioactive contamination. It's very important to form some additional requirement for the
number of measurements, the instrument for the maximum online measurements in very short time. I understand that online, but very short time measurements of ear contamination radionuclide, and these problems which must consider together with the problem of the decision support system.
Okay, thank you. Please. And also we speak about the monitoring and exclusion zone, but for me the most important, the Chernobyl exclusion zone is the best site for the radiological investigation in the world, because it's very, very different. Radionuclide, very different. Landscape, density of contamination, formal fallout, its reserve, the different animals. And in Chernobyl zone, we must to have the special experimental site with very good description, history, density of contamination, contamination of different vegetation, plants, animals, and continue this site and monitoring equipment for this site by support of Sergeyevka Center and reserve. For the terrestrial environment, for the water environment, it's
international hub for
yes, because the monitoring is good, but
this is also the contamination of could be.
Considering this, also one issue which was raised really earlier, what to do with the former cooling pond. Because when I worked in the Soviet, Chernobyl nuclear power plant, at that time, we wrote a letter to Soviet that they had decommissioned the nuclear power plant, and they considered that this object could be used, for example, for some solar systems, and everything should be covered with concrete, and solar panel might be arranged on this territory. And at that time, I told, please consider the necessity of these territories and importance of these territories for international research on radioecological issues. And now, our point of view of this territory of the cooling pond, should we arrange some scientific hub territory and maybe pass this territory to radioecological reserve, because for the moment the territory of the cooling pond doesn't belong to radioecological reserve. It belongs to Chernobyl nuclear power plant.
I agree, it's maybe one side from another, because it is not natural object. But in Chernobyl zone we have very good natural object. For example, Lake Glubokaya. But after 30 years, Dmitry Gudkov, the other people study the influence, radioactivity, radioactive in fish, in Daphnia, but real. Dmitry Gudkov calculates the dose for the fish. The highest dose in winter time were the fish in the sediment. From radioactive data in August for the depths higher 2 meters, we have oxygen in the water, very big amount ammonium, and fish cannot live in this condition. And real, we don't know the dose after 30 years for the fish, but study the effect. And also, it is not only contaminated territory. There are very nice clean lake, for example, in Chernobyl exclusion zone near Ivanovka. And for example, it's very good for the control lake. By Dmitry Gudkov used Glubokaya lake and control lake near the Kiev. It is not good because need to have the clean lake in Chernobyl and contaminated lake. It's also site for the investigation because we obtained the result only in comparison with the same and other factors, but only the different density of contamination and contamination. And the same situation for the terrestrial environment. Our people, our colleagues very good know this place.
Professor Londa, please continue.
Okay, so yeah, I agree completely. But in addition to the geoecology, I think it is very good site for hydrology and mass balance science in its all many kind of environmental sciences. We come here to work together to study more. For my purpose, it's a more hydrological based study of transfer of the radioactive material. It's not just radioactive issues. Also, it's quite a good place to work for the long-term hydrological changing, because of its remained the forest growth, so that water budget changing, that will be resulting in the changing of, runoff from the rivers. And also, we did, establish an erosion plot that should be updated, the erosion parameter, something like that. Unfortunately, due to the COVID and the war issues, we cannot actually complete our main purposes. But Center had taken a lot of hydrological data, and also I hope to continue to collect the river water data, and also some of the equipment like automated automated water sampler or some other equipment. I hope to continue this hydrological monitoring in this site, and hopefully we hope we will come back again in the future. But until then, I hope to continue the environmental monitoring, especially hydrological.
So Professor Roden fully support the idea of the scientific hub, and I might make comment from colleagues from Ukraine that it was order of the president of the creation, development of strategy to develop this hub. So, but my view is also the marginal profit we could receive, if we have the union of two hubs, one hub here in Chernobyl and second hub in Fukushima, because, for example, for scientists it will be very useful to compare different conditions, mountains area, area of plains area. So in future, good future if the two hubs in the two countries connected by some way, and people who provide the study could move between these two hubs. Thank you for everybody for this point. I will start to answer to this question about Russian tactical nuclear plan. In principle, we start to think about this in the March, in the beginning of March, because it was clear more or less to what direction the situation is moving. And if you say about the main difference between, but you understand everything, but I many times now say the interview for TV, is a big difference between accident in the nuclear power plant and nuclear warhead, because what we have in Chernobyl, it was not nuclear explosion, it was dirty bomb. Yeah, because if it's a huge dirty bomb, it means huge amount of the radioactivity and explosion by such vapor, gas, mix and so on. And similar was in Fukushima, it also was dirty bomb. And dirty bomb, they disperse big amount of the inventory to the environment, and also the release of the iodine and so on. What we have situation, I'm not big expert, let me say. But what I could understand from the general approach, warhead is plutonium warhead, and during this explosion, plutonium disappeared. And we couldn't, or not, I don't know exactly, but it's a question. But only few institutions in the world, I tried to provide research, who know inventory of the Russian warhead, who could may answer on the question. I know name of the institution, I suppose. And we try to include in collaboration many, you see, we collaborate now with Japan, Germany, Ukraine, start collaboration of two big laboratories, because I don't know, put your attention or not, Boris Abishenko today presentation from two laboratories. And this one laboratory is Berkeley laboratory, and other was Livermore, who understand American structure, understands the different tasks of this laboratory. So we hope that, but what is important for us, the existing Dehelium support system is ready to make this calculation, because what you should, how you could provide efficient calculation. Your model of the simulation of the dispersion should be connected with a good meteorology, and after you calculate dispersion, you should have a model that calculate countermeasures, evacuation zone, doses, and so on. What we have now in Rhodos or in Argos, we have this environment, but only for different source terms. Today, for example, Tabachny demonstrates source terms they use. By the way, I will have a comment. Where this source term is taken for Zaporizhzhia? Because different kind of nuclear power reactors, of course, they have different inventory. And it was special, where Rhodos was installed, it was special preparation of the scenario for VVR 1000 reactors that use it in Zaporizhzhia. Who did this? In Slovak Republic, there are nuclear power plants that use the same VVR reactor. Therefore, the group of experts from Slovakia, they developed scenario of the maximum release in situation for VVR reactor. So it's very source term specific. And you see, he demonstrated, but also it could be prepared scenario for warhead. What you should know, of course, explosion, general power of explosion, and you should also have some information about inventory and остаточное загрязнение. Как? Remaining contamination, because much of contamination will be destroyed during the. Of course, it's very difficult to say about this task, the two scientific tasks, but as scientists, we should think about it and we should be prepared. I suppose that we will make some preparations together with our international colleagues, and therefore what we're doing now together in Japan, Germany, and Europe, United States, it will be good basis for the further calculations.
I should just say that if you try to think about this, first of all, you should contact military, because they have this information. And
it would be secret that Lawrence Livermore Laboratory is the only one laboratory that belongs to the Ministry of Defense. If you don't know, I will say.
Yeah. So, defense people,
you see my answer, yeah? Okay. How to support the next generation of young scientists in radiology and radiation protection in Ukraine and around the world? We are getting old. So when I receive this question, I start to think who is the youngest person in this our conference. My internal feeling that it's me. But my passport says I'm quite different. And therefore I would like to invite here Sato-san, Igarashi-san, Jake, youngest United States scientist, please come here. Paulina, where is Paulina? Come here.
Actually, my father used to say that we are not getting older, only our children are getting older.
Yeah. So, you present here the youngest generation. It's a big pleasure to see you here. Please, you have the possibility to say about our future. What is your main? Come here. What is your work and selling in each from each of you? What is the main domain to role? That is your what support you need from the such old guys as we are?
Anyone else want to start? Well, frankly, from an international perspective, the opportunity to come to Ukraine and to work on research projects, as well as to meet the folks that are involved, those opportunities are very limited. In my time at MIT, in my time at Berkeley, the only reason that I have managed to go to Chernobyl, meet you folks, has actually been because of things that I discovered outside my university. right? My first trip to Chernobyl was facilitated by a friend. I think that establishing cooperation with more universities and easing the barriers to actually coming and visiting the site, and not visiting in a tourist capacity, because in a tourist capacity, it's very easy to visit, pretty warm, obviously, but it doesn't provide you with the necessary access to the experts in order to start building your career. So what I would highly recommend is, reaching out to more universities internationally, establishing more cooperation, and figuring out ways of bringing people on site. In 2018, I was part of a program put on, I think it was mostly funded by JAEA, to go to Fukushima, the Nahara Robotics Center, and a couple of different spots in Tokyo to learn about Fukushima, the robots being developed to help work on the problems that are encountered there. I can envision a similar situation or a similar program being developed in Ukraine.
Thank you. Next.
So actually, I have studied about the radionuclide concentration and in the groundwater from PhD students in Fukushima University. So now I moved to University of Tsukuba and continue to study the radionuclide concentration in groundwater and groundwater dynamics in the Chernobyl nuclear power plant. So I'm very happy to continue to the study about the radionuclide concentration and groundwater radionuclide power plant, because my hometown is in Fukushima. So many people and many friends affected by tsunami and the radionuclide program. So it is important to understand what has happened in the Chernobyl nuclear power plant. It is very important for me, and to tell them in future, to tell the people in future is very important. So I recommend to the not all the people, so you all to and he said to collaborate in the project. So there are many projects, Chernobyl, Fukushima, and other countries. So let's continue to invite the new researchers. Good job. Thank you.
I want to say that I have a really good experience in being young scientist in Ukraine, but actually I think that the first thing is money, because young scientist in Ukraine, its salary, it's like the salary of cleaning stuff, and I'm really happy for cleaning stuff, but for young scientists, it's because we are just have money to eat, but not to be enthusiastic in science. And also, it's not my experience, but I see other PhD students, and I have a feeling that they become PhD students and they were encouraged to be the students by the university. It's only because university needs to have the students to have also to have some money for students, and and also there's a problem that students, they don't know about the plagiarizing, so they plagiate all they see. So they need to know this to be a good scientist and to be good in the world, but in Ukraine, we are dying just young scientists. It's my feeling only. But I had a good experience in our institute. I'm really happy to be here.
Это хорошо, я очень какие-то
Yeah, so actually I'm 39 years old, so not so young, maybe middle, like a machine or something. Okay, so I started my career from the district from the 2017, and I spent a lot of time to visit in Chernobyl, more than maybe 20 times or more. I'm not sure, but and I also spent many times to lead previous paper after the accident in 1986, and I led the paper, report, book, everything. And of course, I have a chance to, how can I say, touch the experience in Fukushima because it's easy to, how can I say, because it's Japanese. So anyway, now I'm thinking the pure science, I mean, for instance, physics, radiochemistry, or something, is not only to answer the question from the public. So I'm thinking that we need to, how can I say, more effort to share our idea to public for a better future. So that is my current thinking or mind as a middle age. So yeah, thank you. Yeah.
Okay, thank you. And for Singh, 40 is a border.
Yes,
Okay, but I would like to comment to what say now Polina about the life of young scientists in Ukraine. You see today Dmitry Bushnik was one of my scientists in my team in Kiev, and he now working 15 years in Germany, and from my team maybe it's 18 young scientists come who now working not in the shops but in the best training centers. From one side for Ukrainians this brain drain problem is a problem. From other side you see that now is a hard period for country, all this network working. It means that in the future when situation will be better, they will return back, and such story as Maxim that 20 years living outside Ukraine will be very rare. People will return back and you have to Ukraine. And in this moment it's very important this international cooperation and the possibilities for Japan to invite Polina or Arena Bordeaux. It's very important, and maybe one of the in Soviet time I said we have big conference have usual some kind of the recommendation to somebody. And we discussed it before we start this conference, do we need or not to write some recommendation? And we take decision to open this question and ask you. First of all, we will ask maybe Mr. Shevchuk. He's not here, but okay. So Yeltsin, SNRU representative. Do you need Ukrainian authorities some recommendation from this conference? It's not, you shouldn't answer immediately, but if yes, we could communicate very simple one with another, and we could think about, today was many good ideas, and we could put something on the paper and have some back response. So, but one of the recommendations is very clear. Now is the situation of war in Ukraine, Ukrainian young scientists, women working mainly abroad, but it's also good because they continue to work in the science and they could return to the country with situation will be better. So we will could support this, apply to the international scientific community to help the young Ukrainians to work abroad in this very difficult situation in the country. I'm near exhausted out of these days. And we have still plans that we will have closing up, and we will have very short speech with these organizers. It means in this case, Poland,
Ukraine and Japan. So numbers and say Stavritemsky, and if Maxim could come for closing, we will say that he. But before closing, would like somebody else to make some comments, recommendation, questions? Would like somebody to take floor now before the closing, or we'll go to the drink? Okay, please.
I only want to try and answer my question.
Yeah.
I think this goes together with the hub idea.
Yeah.
And we talked about it for many decades, that we need a center in Chernobyl, and maybe in Fukushima, which supports projects from all over the world and inside Ukraine to support young scientists to come and learn. Because Fukushima and Chernobyl are the best places in the world to learn about radioactivity. And so when Ukraine wins, and there's lots of money going hopefully from Western Europe and the US and Japan to Ukraine, I think it should be one of the priorities to construct a center for radio ecological and radiation protection research at Chernobyl.
Okay, thank you. Somebody else? No, in this case I invite here to come here as from the beginning. Slava, come here. And we skip to Anderson say in the beginning, Anderson say, please come here. Now on the closing. Okay. I will add. Придет сейчас Максим. Максим идет, да? Сюда. So, okay, so we are 2 very intensive days and intensive nights for somebody. So we are organizers. Find your final words at the end of this 2 days meeting. Please start.
I was oriented on schedule and planned several calls from Ukraine. I want to say thanks again to Fukushima University and National Center for Nuclear Research Poland for organizing this beautiful event. I want to thank for all your initiatives, propositions, and your support. I think it was really fruitful, good time for communicate and to plan our next activities. We will win, and we will win with your support. Thank you so much.
I would like to thank everybody for participating in this wonderful conference. And first of all, I would like to thank the Japanese side for sponsoring this event. And I hope that such events will be at least annual. And I hope next year. Next time in Ukraine, of course, but still we have to have this tradition of gatherings and sharing our experiences and showing the people of the world how Japan and Ukraine can cooperate and can fruitfully exchange their knowledge. And this is very important, I think, and I would like to thank the Japan University of Fukushima for organizing and for having this event and having me as a co-host here. Thank you.
Okay. So, as I talked earlier, actually we haven't finished our research yet because we just install equipment and waiting for getting the data, and then we can come here. So Japanese funding is stopped, but we would like to come back again, and I hope to work together, even without funding, but yeah, we try to get funded, but so anyway, we would like to continue the study in here in Chernobyl. It's quite a great place to study compared with Fukushima. So that hope we will keep in touch, and anyway, we will come back again. Thank you.
I'd like to thank you very much for coming to Warsaw. It was very difficult, it's still very difficult time especially for Ukrainian colleagues. So we understand it very well. That 100 years ago, Russians, Soviet troops were close to Warsaw. So we were in quite similar situation, as you know. So I think that this meeting was very successful, that because a number of scientific issues have been raised, quite very important for radioecology and for all the radiological aspects related to the remediation actions for Fukushima and Chernobyl. So, and this is very important, as Jim said, this is unique places that you can really make a very good scientific research in this field. So again, thank you very much for coming here. I'm sure that the number of contacts have been established here, so I think there will be a fruitful cooperation in next years. Okay, thank you.
Okay, Honda Sensei has told what I should speak as a PI, so I say something different. Yeah, science-based decision making is very important. So as like decision in the policy of government or nation. But sometimes in Japan, I feel that decision making is not done based on science. Now sometimes I feel is like decision by money or like priority of capitalism. But this war between Ukraine and Russia is, to my understanding, this war is not war between capitalism and socialism. To my understanding, this is a war between democracy and dictator. Another thing I want to add, this meeting is not realized unless we have Mark in our institute.
In this case, I also would like to say something. I am, we have such, после Russian language, such problem. Мы простых задач не решаем, потому что они сложны. We not try to take simple tasks because it's a bore. I like very complicated tasks. Так вот, this task was extremely complicated. To organize conference in Poland, sitting in Fukushima, with all the problems, one person will not put finger, say that way, Mark, you maybe forget about bureaucratic system in Ukraine. But I answer, I am under the pressure that three bureaucratic systems, Japanese, Polish, and Ukrainian. But of course, it couldn't be solved without all support and big will to participate in the conference. Of course, when we prepare the list of the Ukrainian participants, more than 20%, I was absolutely not sure that we will receive amount of the people here, more than 20%. And this list shocked even our funding agency. That we should put a very big justification why we invited many people. But it was a joint will. It was our will to organize this. And it was will of Ukrainian people to meet together, to work together. And then it shows that our seminar is a big success, I fully agree. And this combination, of course, of some of my efforts, but all the efforts of all of you. So I would like to, when I was young, many years ago, it was such movie, который назывался «Если бы парни всей земли». Very young people remember. But they people remember. So it was, the title of the movie was, in a case if the guys of all world work together. It is very hard situation for our country. This understanding in all civilized wars, what numbers say tell, that it's war between country of freedom with country of tyranny. And this joint feeling create wonderful international team. And this international team help us to be together here and to make this. So I would like to drink to all of us. We should go to the next part of our meeting. So thank you a lot for all your support. Thank you for good work.
And please remember that Warsaw is all the time open for you to come.
Thank you. Thank you.
Okay, so we have here some drinks, some Sergey.
Stream.